innovative presentations, and of course, valuable networking opportunities. Few announcements. I request everyone to keep their phones in silent or do not disturb mode throughout the course of event so as to maintain the requisite decorum. Our schedule for the day includes three technical presentations in the morning, followed by panel discussion before lunch. After a lunch break, we'll have another panel discussion and then conclude with three more technical papers. We are going to begin with the presentations really soon. I request all those outside Oman Hall to please take their seats inside. Thank you.
You can use this also, right? Yeah, up to you.
So good morning, ladies and gentlemen. The stage is set, the presentations are ready. Let's dive into today's agenda and make the most of the sessions and interactions. I invite the learning technical presentators to please take their seats on the stage. Thank you, gentlemen. With the excitement for new idea and innovation apparent in the gathering, we begin the first round of technical paper presentation. Each speaker will speak for about 15 minutes, followed by 5 minutes Q&A session. Warning bell will be rung to cue the speaker at 13th, 15th, and 20th minute. To start, I would invite Commodore Amit Ray from Directorate of Naval Design, Submarine Design Group, Indian Navy, to present on marine robotics, developing an indigenous ecosystem. So,
Good morning to you all. It is a pleasure and a privilege
to be here and renew bonds with so many stalwarts, colleagues, and dear friends. I shall be talking about marine robotics, the requirements, our current status, and what, in my opinion, we need to do to take it forward. The requirements, what I am referring to for marine robotics, are applicable for autonomous marine systems. And when I say marine robotics, what I mean to cover is autonomous marine systems. Many of the pictures shown on the slide here include products developed by organizations and individuals in this audience. Why is this an idea whose time has come? There are numerous applications, scientific, industrial, and defense, for autonomous systems which we need to be aware of. A variety of solutions have been developed to meet these requirements, starting from ocean buoys for monitoring of wave heights, for sea state, and as futuristic applications as submarine-launched AUVs in the future. A word on the nomenclature. UUVs refer to unmanned underwater vehicles in general, classified into remotely operated, where they have a tether, and autonomous, where they do not. What are the main technological challenges that make this field so exciting? On the left, we have the features of the hostile environment and certain aspects that need to be addressed to meet these challenges on the right. The Indian Navy has drawn up an ambitious roadmap for unmanned systems with more than 100 such units of various categories planned to be inducted by the year 2030. The capabilities for UUVs are often correlated to their size, which is linked to greater endurance. And the defense applications are listed in this typical matrix, where the first column has the applications and the size increases from left to right, commensurate with increasing endurance and range. The absolute necessity of an indigenous ecosystem for unmanned systems has been emphasized by the top levels of the government and is a focus area of the Indian Navy for the reasons as listed here. To give some glimpses of developments across the world, China has 3 major research institutes dedicated to AUV development. More than 500 firms are engaged in AUV systems and component development. They have more than a dozen types of AUVs in production already. The US Navy has been bringing out its unmanned systems vision as a regular document for the last 20 years now. An example of specific vehicle development, which was initially funded by the US Navy's Office of Naval Research, was gradually improved, scaled up, developed over 20 years, and exported to 25 nations, and today more than 400 such units are in service. Another example, the Boeing's Echo Voyager, whose development started in 2019 after winning a competition against Lockheed Martin, and the first of this was inducted by the US Navy as late as December last year. So where are we? As a nation, Indian developments of AUVs and ROVs have taken place over the last 20 years, and this is a snapshot of the journey. Pioneering efforts were undertaken by the CSIR laboratories of the National Institute of Oceanography, Goa, and the Central Mechanical Engineering Research Institute of Durgapur. The NSTL of DRDO made their first AUV almost 20 years back. Trial started in 2003, 2005. And the NIOT of the Ministry of Earth Sciences, the erstwhile Department of Ocean Development, has also played an important role. However, the utilization of all these prototypes has been limited. The TOT to industry, which took place, also did not translate into production, into series of orders, and that is unfortunate. Many products have been demonstrated in the past 3 to 5 years. Apart from the top row, all the other products have been showcased in the last 2 years. So this is how the ecosystem is transforming today. In my opinion, the focus on Atmanirbharta and the impetus given by the Navy through the IDEX program have brought in a new wave of enthusiastic startups into this field. What are our limitations? We have very few designs. We have mostly imported components, limited trials, and limited opportunities for field testing. There are several stakeholders and ministries that are either users or developers of these technologies, and synergy between them is the need of the hour. Specifically, there are several national missions underway, each with ambitious goals and generous funding. In the Navy's submarine design organization, we have put in efforts over the last 3 years to understand and encourage this indigenous ecosystem. We have developed in-house designs, placed several R&D contracts with eminent institutions, academic as well as research. Our ongoing engagements include a very fruitful partnership with Technology Innovation Hub of IIT Bombay, which is part of the National Mission for Interdisciplinary Cyber Physical Systems. And TIH is funding the projects suggested by us, and 7 projects are underway, each of the value of 1 crore. We aim at developing prototypes for each of these projects within 8 to 10 months. Separately, we are steering the development of an AUV called Jaya, which is going to be a test bed for the new technologies that get developed. This is being done by National Institute of Oceanography, Goa. In the year to come, we hope to develop these technology development prototypes and evaluate them on our testbed AUVs to validate and compare their performance. Now, actions proposed for the forum here. These are some technology areas I feel we need to focus on, and they vary from software to hardware to operations, materials, and so on. We need to focus on development of certain critical components which are presently all being imported. These could also have a huge potential for export in the world market. Some specific technology projects that need to be worked upon. The first bullet was an idea of an AUV that could maybe float to the surface and then fly into the air. I thought it was a dream, and last month I saw a video on LinkedIn that the Chinese have already demonstrated such a product. So that is the pace at which things are moving today, and the ecosystem that we have consists of a number of stakeholders. So I have just tried to link that for each of the activities or focus areas on the left and in the middle, we need to have one lead stakeholder, with the government focusing on certain aspects, academia, R&D, and end users on others. Now, my last few slides are on certain suggestions and actions that could be considered. Some basic suggestions. Let's start with connecting and collaborating more deeply and widely. That is why I have been flashing a similar set of slides in various forums over the last few months. And for some of you, it may therefore be a sort of repetition. we need to demonstrate capability. And that capability demonstration can come only by making prototypes which are not necessarily conforming to a specified set of requirements, but rather to demonstrate what is possible and to expand the horizon of the end user. This enhancement of capabilities needs to be stepwise, gradual, and need not be in one go or trying to match with the best in class in the world. By progressively gaining field expertise, we keep improving reliability, and thus we can influence the end user in widening their horizons on the use cases, triggering their imagination. And I want to emphasize here that naval architects need to stay relevant and become wider in their domain of expertise by taking on the mantle of systems engineering. And unmanned vehicles and unmanned systems are a classic example of where systems engineering can truly be demonstrated to its full potential. Some suggestions for each of the stakeholders in this hall and participating in DIMS 2024. My personal wish list for a network of collaborators with close trials facilities, testing agencies, and a designated area for undertaking oceanographic experiments, maybe of Lakshadweep, maybe of Gujarat, which could be opened to researchers and technology firms who are actually developing a body of knowledge for a specific area over a period of years. And finally, a specific proposal close to my heart. Let us come together to form a virtual or distributed center of excellence in marine robotics, where some bring knowledge, some bring facilities, some bring people, and we could share information, resources, and conduct outreach and upskilling activities together. The existing national missions and corporate R&Ds should be able to provide the necessary backing. And I'm sure the energy and expertise in this hall can make this a reality, which I feel is the need of the hour. Thank you very much.
Thank you, sir. It's now time for the Q&A session for technical presentation. Please feel free to ask any question that you may have. You have to sit.
Thank you very much. Yes, sir, please.
Yeah, thank you for a wonderful presentation. I have just one question to you. In the course of the development of a naval architecture to be a systems personnel, what should the academic curriculum be, in the sense that from where it should go? Right now, there is nothing in control systems as a part of the academic curriculum. So what do you recommend to do?
Yes, sir. Sir, in Cochin University, in the Department of Ship Technology, the syllabus that we had 25 years ago, I feel was quite robust and widespread to give us a toehold in all aspects of system engineering. Unfortunately, we did not pay enough attention to subjects like electrical engineering, electronics, or control systems, which were covered to some extent. And today's curriculum that is there in institutes like IMU, I feel they have introduced aspects of software engineering, control systems, and a flavor of design thinking, even though it is not actually mentioned as a subject. I think with this, it provides enough tools in the arsenal of a naval architect to be able to take on these things. Otherwise, as so many others in this hall, people have taken on those roles without any formal training.
Yeah, sure. Thank you.
Thank
Thank
you.
you very much.
Thank you very much.
A really organized and appealing presentation, sir. With the Indian Navy paying attention and taking such strides in unmanned system, the nation surely is under safe hands. A round of applause for Commodore Amit Ray, please. Now I request you to wait as we set up the next slide.
Shall we start? Yeah. Good morning, everyone. I'm honored to be here in India. I came from Europe, a long trip for me, but it is worth it. And today I would like to present to you with our solutions we have available for electrification of ships. So my name is Michal Robenek, and I'm a solution manager at ABB, at Marine and Ports, who are the system integrators for ships. So it's important to start with looking into what is the pathway to carbon-free shipping, what is available for us, and how ABB see that. So to start with where we are today, we have available fuels and technologies, which are methanol, LNG, and when it comes to technology, typically it's diesel electric. But this is not enough to decrease the carbon footprint, and we need to continue. So next technology which is already available is battery systems. And for battery systems, we need, of course, the charging systems. When we talk about vessels which are rather short distance, the batteries are the perfect match. But for longer distances, currently the batteries are not offering sufficient energy density. So we need to wait a couple more years, perhaps, and then we can see also batteries which will be fitting to even smaller vessels and will be able to operate longer distances. But alternative is also fuel cell systems, which would be representation of what we today use in combustion as a combustion engines. So it will be carbon-free when we use hydrogen, compressed or liquefied, or there are also other fuels available together with fuel cells like ammonia or methanol. So IMO is pushing industry to act to decrease the carbon footprint. They have set the limits to 2050 to be carbon neutral, but we see that there are some signs that it can be manageable within 2040. So let's work all together to achieve that. We can achieve that with two ways, basically. If we look into today's systems on board, which are mainly diesel mechanic, can be improved either by improvement of the efficiency, or it could be also by changing of the technology or replacing the fuel type, as you like. So the first would be shaft generator, which is the small step. It will provide savings when it comes to OPEX. It's not so significant CAPEX change, And it's typically the first step we see on board of vessels. Of course, there is no system which fits all the operation load profiles, so we need to select the proper one, but diesel electric is also very useful, using the engines based on the load of the propulsion. To even improve the situation, we can apply the batteries, and but for optimization of engine performance. But when we talk about the fuel change, then we have battery hybrid vessels, so batteries with diesel engines, which could be in the future replaced also with different fuel types. Because nowadays there are also engines which are able to cope with dual fuels. Or you can select the fuel battery vessel, which gives the best efficiency possible. And as I said, the fuel cells are suitable for longer distances. So when we do the electrification on board of ships, we have two choices. We have AC system or DC system. I will describe why DC looks more feasible for hybrids. Hybrids really like the DC, because DC is the lowest common denominator. It's the backbone of the distribution system. So if we compare the traditional AC system, and with DC system we can remove the transformers and convert the AC to DC from the generators or from any other sources. And then we can create a system which has lower footprint, it has higher efficiency, and more dynamic load profile you have, the better situation, the better benefit the DC system brings. So we realize that, of course, most of the loads are converters, frequency converters. There are another benefits are that you can synchronize almost instantly, and protection is also very fast with DC system. So our first delivery was actually in 2013, and it has been a long journey. We have also learned a lot in the last 10, 11 years, and we are receiving positive feedbacks. So there is no negative feedback so far about the DC system. So system works. Another thing what can be used with diesel engines is since there is no frequency link, we can use the wide frequency range of operation of the generators. So you achieve the same efficiency and SFOC like you would have with a diesel mechanic system with propulsion. And it's simpler, and simpler also to control and to protect. We have several types of system which we can offer. So for our onboard DC grid, we can offer systems up to 6 megawatts per shaft power, and it's suitable for larger vessels, but we are closely watching the market, and we are prepared also to deliver systems for smaller vessels where there is not sufficient space for installation. So we came with a microgrid system, which is sort of distributed converter system connected through DC switchboard. But as onboard DC grid, also the microgrid provides you with the same solutions. So it's very modular, and you have two possibilities to charge now, charge the batteries. So one possibility is to use the AC short charging, another is to use DC short charging. And when we talk about short charging, why we need it, of course, we need it because there are batteries on board. And there is a lot of batteries, more and more. There's a lot of, let's say, aspects what we need to consider when we design the charging system. And besides of the tides, vessel dimensions, there is also discussion whether this should be AC or DC. In short, AC charging, you are having most of the equipment on board of the vessel. And since battery takes space, takes weight, converters takes space, it's smarter to move equipment on a shore so you can release the space for cargo or for other equipment. It's not just a couple of meters. It's sometimes, if you compare, and I have some comparison in later stages, it takes a lot of space to have AC charging when we talk about several megawatts. So we are really involved in MCS charging system, which stands for megawatt charging system, and we have been since the beginning part of the charging group who has developed the white paper which specifies what is required for such DC megawatt charging system. So we were not alone. It was maybe 100 companies from different industries, even avionics or trucks, buses, and marine was part of that. If we look what we have available for DC charging is the combined CCS2 charger or plugs, which has certain limitations. So 500 amps is not much for certain vessels. But if we compare it to MCS, which is now defined to transfer 3000 amps with single plug, which is liquid cooled, it gives quite good possibilities to charge fast. So here is a comparison between AC charging on the right side and with corresponding power on the left side. So left side you see the MCS charger. On the right side you would have to have 3 times the same size of the plug. Suitability for MCS charging is like that. So we are starting somewhere around 700 kilowatts, but we can multiply the 3 megawatts several times. Depends how many plugs you can have on board of the vessels. We have also one use case which we are very proud of. So we are the first one who are delivering level 3 MCS charging system in New Zealand, Auckland. So there will be 5 charging stations which will have each 2 plugs, and each charging system will have 3.3 megawatts. And we are delivering wide range. So the intention here is to standardize the charging system so it can serve several fleets. And Auckland is a nice example that they would like to have multiple vendors operating their transport system. So they are not depending on one supplier of the ships. But if ships will follow the standard, they can be charged with our chargers. This is simply in simple picture how does it look. So there is a division, isolation between grid and charging system, some control and for voltage and current, cable management system, communication. But why I'm talking about it? What we see today, and we have seen for last maybe 6-7 years, when it comes to DC charging, every ship was connected to charging system, and it was like a marriage. And you know, not everything lasts forever as a marriage sometimes. And sometimes owner would like to sell the vessel. And if they have already a linked vessel to the charging system, it may be costly replacement. So it's better to follow the standard. And that's why ABB really recommends to use the DC charging. And of course, AC charging might be cheaper in a short term, but if you look into the bigger picture, if you want to serve several fleets or a larger fleet of the vessels, it's faster, it's simpler, and it reduces the space on board of the vessel. By that, I would thank you for your attention.
Time for the Q&A session now. Any delegate wishing to pose question may please raise their hand.
Thank you for a short and very educative presentation. I just want a general question. Traditionally, DC was considered to be bulky. You know, even maintenance was a problem, but of course now with BLDC motors and all, that problem is not there. Whereas AC was more rugged, robust, compact. So what has changed in technology now going for DC? For shipboard applications, for submarine applications? I wanted to know your view on that.
Okay. Thank you for your question. All right. So you are probably referring to DC system from old days. Yeah. And then it has been replaced by AC system. That's true. Because at the time, AC system was offering cheap versions. So suddenly the frequency converters came with asynchronous motors. Everything becomes cheap. But now it is about also how to make it even more compact. And with AC systems currently, for many reasons, one of the reasons is to isolate the frequency converter from distribution network. Another reason is total harmonic distortion of the distribution network. We are using transformers. So if you are talking about, let's say, one propulsion could be 3 megawatts, then you would have to install 3.5 megawatt ampere transformer, which is quite bulky. And this size can be removed if you use DC. So we convert directly to generators with converters to DC and then convert it back to AC. And when we control the torque and reference of the propulsion. Did I answer your question?
Any other question that delegates may want to ask?
What's the kind of R&D expenditure ABB has on sustainable propulsion? If you can give me those rough indication of figures.
I am afraid I'm not the right one to ask for our cost for R&D. And but we have various, when we talk about propulsion, it's not only our azipods. We have came also with our Dynafin, which brings also another possibility to improve efficiency. We are talking about propulsion efficiency, close to 80%, which has not been seen ever. So check our website for Dynafin. I recommend it.
And any plans for indigenous or local manufacture of some of ABB products in this line?
I heard that there are some discussions about that. That's all I can share.
Good morning. Just wanted a quick comment on, particularly when you're going for very fast charging of 3 megawatts in a battery-based system. How does it affect your operations cost in terms of the lifetime of the battery itself? Particularly when you're going for very fast chargings, sort of times that you mentioned, as compared to slightly slower charge rates.
Thank you for your question. So when it comes to battery system, to start there with, you need to consider how you would like to charge it. If you want to use fast charging, which gives your operation, for instance, for tugboat, you are freeing the vessel for operation if you charge fast, right? That's what you would like to achieve. But of course, it's affecting the battery lifetime. But there are batteries which are not so much affected, which can handle fast charging, and they are not much affected with number of cycles. So for instance, LTO technology gives this opportunity. But
that sort of increases the capex cost and capital costs. As of today, maybe in future it will come down.
Yeah,
in future it will come down.
But there are also, let's say, more cost-efficient battery types. But there you would have to increase the capacity to match the charging power. So there are ways how to do that.
Anyone else would want to pose a question? Great.
Okay. From a business point of view, what do you think, is there a likelihood that, hydrogen comes and disrupts the entire electric propulsion? And do you see that as a risk, or do you see that there is a possibility for this to coexist in the times to come?
You mean full battery electric vessels?
Yes.
So not talking about hybrid only, but also go directly to full electric vessels. We have also real data which proves that return of investment is roughly around 5-6 years in some cases. So it depends on the operation profile, how dynamic it is, how the savings will bring the cost back to the owner. But it's manageable, possible, and we have real cases where we have seen that return of investment, mainly due to lack of maintenance cost for engines on board, plus reduced capex for generators, but it's mainly due to the best efficiency from batteries to propulsion, which is in some cases a loss is just 7%, which is not seen on a combustion engine.
Okay, thanks.
We have time for one last question. Okay. With this,
my name is Krishna Kumar. My question is regarding fast charging infrastructure. For instance, when you look at the option between battery fast charging infrastructure in island communities, the availability of basic infrastructure itself is quite a challenge. So will they go for the option of what is preferred? Is it the option of having trickle charges through a generator, or you go for a full battery system with shore charging?
Thank you, sir, for your question. Sure, this is a tricky one, because if you have infrastructure which has a weak network, weak grid, then you need to have something to support it. With DC charging, the logical way how to solve it is to apply stationary batteries there, which could not be used only for charging of the vessel, but could be also used for make the local grid stronger. You can have frequency and voltage compensators in the form of energy storage, which is onshore. And it can be charged slowly, but when a vessel comes, then it can fast transfer the energy towards the vessel. So there are solutions to help, because typically in port, you would have to pay extra fee, to the peak power. So using the energy storage saves a lot when it comes to OPEX.
thank you. With this, we conclude the Q&A session. A very inspiring presentation by Mr. Mikhail Robnik. With the world struggling today to reduce the carbon footprint, the actions by ABB are commendable. I thank Mr. Mikhail Robnik, Solution Manager, Short Distance Shipping at ABB. A round of applause for sir, please. Next, we'll have on stage Mr. Sachin Kulkarni, Head Marine Business Sales, South Asia at Wärtsilä. I request you to wait till we put the slide.
Good morning. Good morning, Maritime Fraternity. It's been an honor and pleasure to be here and share some thoughts and ideas on the subject matter. Yeah, so as a maritime industry responsible for transporting over 80% of the world trade, shipping serves the lifeblood of the global economy. And in just 25 years, that means the lifetime of the single vessel global regulations, IMO requires that shipping eliminates the entire contribution towards the climate change. So let's look at few topics today which would cover the agenda. What I'm going to cover today is basically a complex path towards 2050, how we could achieve that is reducing the demand of the energy, transforming the energy more efficiently, and certainty in transition when it comes to the future fuel. Let's start with the complex path towards 2050 and our approach to decarbonization. We all are aware that IMO regulations intermediate targets of 2030 and 2040. Important aspect to be noted over here is that it is not only this intermediate target, but it's also about well-to-wake approach and its implications. Along with IMO regulations on the stakeholders also now have to see EU measures such as EU ETS, which are already effective, and Fuel EU Maritime, which are going to be effective 2025. Now, these are the high level of complexities, what we are experiencing: ambitious targets, indexes compliances, local and international regulations, multitude of scenarios, and technology maturity. Now, under this whole gambit, how to select the right path? Let's look at few of the ideas. Well, every ship is unique. You know, we many a times keep getting the queries that, okay, the same set of solution can I implement across my fleet? And the answer is that every ship is unique, and therefore, with the technology continuing to evolve at a rapid rate, there is no silver bullet to decarbonization. And that's where it's a rather of combination of solution which would be more effective and which would deliver the desired outcome. So what is the Wärtsilä's approach to decarbonization? As I said earlier, there are three-pronged approach. One is reduce the demand of energy itself with the help of energy-saving devices and voyage optimization. Second is transform energy more efficiently with the help of hybridization, electrification we saw in the earlier presentation as well. Use alternative source of energy, that is shore connection and alternative fuels. I'll cover a few of them in this presentation today. Reduce the demand of energy. So it starts with the existing fleet first. Data-led advice is a valuable way to reduce and lower emissions. As we know, decarbonization is no simple task, and with the help of with the challenge lying in the selecting and employing the right solution and technologies efficiently, economically, and the right times. So, well, we are looking at one of the core elements preventing fleets from acting on the decarbonization is uncertainty. There is a sea of unknowns, so fleets are worried about investing and getting locked into the wrong solution. Our decarbonization services can help ship owners find their decarb path with three simple steps. One is fleet decarbonization program, analysis of current fleet focused on the environmental compliances, decarb modeling, real operation data analysis to identify how the reference vessel is currently operating, and evaluate based on simulation to reach to the compliance. And the third and important stage is that the installation on board. When we look at this, the real operational data analysis to identify through statistical and quantitative methodology how the reference vessel are currently operated, and based on that, the simulation takes place and the digital model is created and validated. And once that validation is done, it is basically introduction of alternative technologies on the particular ship. So there are a few options which are open to ship owners and operators looking to retrofit solution as a way to reduce emission and to save the fuel. I'm not going to get into these specific ones. The idea is that just to give that comfort to the operators that these are the solutions which are available today for the existing vessels and as well as for the new vessels when they are planning for the new build of the vessel. Transform energy more efficiently. So we talked about existing vessels so far. Let's look at the future proof of new building vessels. And there are a wide range of options, including the propulsion system, leveraging electrical solutions such as hybrid, shore power, shaft generators, energy-saving technologies, and digital solutions. Now, when we look at diesel electric system, these are suitable for vessels which are high hotel load and the low noise and low space requirement, such as cruise ferries, OSVs, research vessels, and coastal vessels. Hybrid system, suitable for all vessels which are changing load requirements, lots of maneuvering or DP time, like coastal, offshore, tugs, ferries. Energy storage can serve as a spinning reserve and peak shaving and or load boost. This is a legacy system, as we all typically know, a four-stroke engine, a two-stroke engine driving the FPP. This is what we know, which provides a low flexibility when it comes to the subject matter. And that's where we are looking at a future-proof system, wherein you have a mechanical hybrid setup and electrical hybrid setup. My job was made easier with the earlier presentation, so I won't go too much deep into it. But then here we can clearly see, depending on the operation profile of the vessel, depending on the load and depending on the speed and the variation which is demanded, based on that, the mechanical hybrid as well as the electrical hybrid solution. So when we look at the solution, the technical applicability and commercial viability of the alternative fuels will vary greatly, depends on the different types of ships and trades. So deep sea vessels, for example, have fewer options compared with the short sea segment. Deep sea shipping companies comprises of large ocean-going ships that need to store the very large amount of energy, where the main proportion of energy consumption relates to the propulsion of the ship at a steady speed over long distance. Options for the deep sea trades are currently limited to LNG or biofuels, methanol, which are yet to be widely available and at this point of time more expensive than the LNG. The decarbonization options for the short sea vessels are more diverse and include more alternative power sources. For the ships, the shorter distance and highly variable power demands often makes electric or hybrid electric power and propulsion system more efficient than the traditional one. As you can see, as we move from the coastal and short sea segment to the ocean, the application of alternative fuel becomes much more interesting. And as we talked about the coastal and harbor vessels, there it's more prominent use of the electrical solutions. Of course, it has a flexibility of including the alternative fuels as well as the time goes by. So now global regulations have set a clear destination for shipping, net zero emission by mid-century, and radical changes are needed to comply with the IMO target. Both vessel design and power generations are impacted, but the main challenge is fuel, the future fuel in shipping, and related global investment in their production and the infrastructure. New future fuel in shipping are being developed all the time. They include bio and synthetic LNG as well as the ammonia, methanol, hydrogen and biofuels. There is a wide range of engine and fuel gas supply system under development to help you navigate the route to reduce greenhouse gas emission for whichever fuel you want to use. So there is a little certainty around the future of future fuels in shipping. Flexibility is important and crucial. For many potential pathways, the best solution is to develop the engine and fuel handling system that already exist rather than creating entirely new setup. One thing is clear, while the energy transition in process, assets are unlikely to be operated on the same fuel for entire life cycle. And there are many types of sustainable fuel that have potential to become the future marine fuel. The infrastructure is not yet available for many of the fuel choices of the owner. A variety of fuel will come into use depending on the region and the use case. Green synthetic fuels are not expected to become widely available to the shipping industry before 2040. Transition fuel, such as LNG along with fuel blends, are the first step towards the decarbonization in maritime. But what we also know that multi-fuel technology is here today. Combustion engine offers enormous potential for rapid carbon emission reduction, and fuel flexible engine technology provides an upgrade path for existing as well as new vessels from the transition fuels to the green fuels. In other words, decision made today to support the short-term action today can pay off in the long term as well. So cost of emission will close the price gap between the fossil and sustainable fuels. As we can see that fuel prices, the range 2025 to 2035, with the help of the new measures and the carbon tax, the gap between the fossil fuel and sustainable fuel will get closer and closer. And also it shows the price range from the fossil fuel to the e-fuel as such. Of course, it's important from the design point of view to kind of look at the fuel selection because it impacts the structure as well, as the energy density of each fuel is different and accordingly the tank sizes also differs. Sustainable fuel uptake roadmap to 2050, this is how we see in Wärtsilä. So LNG is very well placed as to act as a transition fuel, followed by biofuels in 2030s. Blue fuel, such as blue ammonia, will then act as a bridging fuel. Green synthetic fuels becomes widely available as scale at the gold standard in the late 2030s and early 2040s. So fuel conversion will have a vital role in the fuel transition for both existing ships and vessels built during the decade to come. In case new builds, owners can now select class notation certifying the level of fuel conversion readiness to mitigate future risk. In order to comply with the stricter regulatory targets in the longer term, more operators are looking at converting their vessels to run on the low carbon fuels. But what needed is to make the switch a success. Before any step is taken, to ensure success, it's imperative to start the feasibility study for conversion to alternative fuels. These actions will help you to ensure successful switch to alternative fuels, as well as the compliance of your vessel. This, in turn, can extend the vessel's profitable lifetime. When we see these parameters or the elements to evaluate, there has to be a business case. There are quite a few elements under that business case. Then the fuel choice, which you're looking at. Of course, as I said in the earlier, well-to-wake approach is paramount. Emission reduction targets, availability of the fuel along the route vessel operates, that's important. Finding room on board, as we said that the energy density of each fuel is different, so it's important what kind of space is available there on board. Engine conversion, if the engine can be, particular engine can be converted or not, is the technology there or not, or entire engine has to be replaced. And importantly, the scheduling. The installing the new fuel tanks, the fuel handling system is done in dry dock, so accordingly it has to be scheduled as per that. Flexibility of not completing the conversion at once, so that option also needs to be explored. Ultimately, what does success looks like for you? The reality is that the success looks different for everyone. As fleet owners begin their decarbonization journey, they're faced with 3 C's: complexity, compliance, and the cost. Complexity primarily comes from the diverse fleet of vessels requiring the different solutions to meet the compliance and the future needs. Compliance, the maritime value chain that forces owners into compliance and pushes them to decarbonize by trying the access to finance and revenue closely to environmental performance. Cost, the operational risk associated with CapEx and OpEx. So successfully navigating these will take more than a technology. The 3 steps, what we are representing here, is our belief that success is based on the collaboration. It's a complex process. It takes more than the enabling technology, and this is what we call a true partnership. Thank you.
Time for the Q&A round now. Anyone want to ask any question to our presenter?
My question was for the first speaker, if I may, for Commodore Amit Ray.
So just that the time is running for third speaker right now. So if possible, it can be done after the discussion.
Right, thank you.
Yes.
It's a very similar question that I had for ABB. What's Wärtsilä doing in terms of engineering and development for these new technologies in India? And also if you can share what kind of R&D spend is there for sustainable shipping?
Okay. So all this decarbonization things needs an extremely deep research and development as such, and the process has started a few years back. Currently, our spend on the R&D is around 4% plus of our earnings, which is quite significant as such. When it comes to operation in India, so typically we have actually started a few things even before this journey of decarbonization. So for an example, again, depending on the industry, as far as the maritime industry is concerned, we have already have our technology and the propeller repair, which is already there in the country for last decade or so, which has helped ship owners to reduce their capex in terms of investment of new propellers by helping them to run the existing propeller for another 5 years or so. That's one. Second, we have already example of water jets, which is now 60%, approximately 60% localization is achieved. And for 16 vessels of navals are already been supplied to GRSC as well as Cochin shipyard. So that is already in place. Moving forward, again from the defense perspective, there is a tie-up with Triveni Engineering, wherein we are associated with them for the CPP manufacturing here as such. So from that point of view, the process is already there as such, and as we move along in this journey, we'll kind of see how it goes as such.
My name is Krishna Kumar. Here. My question is, vis-a-vis owner taking a decision to retrofit the vessels with adapting to the new fuels, what is the chance or the popularity of carbon capture so that you don't do much changes, you just capture the carbon, and there is an ecosystem developing, I believe, on commercializing it.
Yeah.
So what are your views on that?
Yeah, so Wärtsilä is already very much into carbon capture and storage technology. In fact, last 2-3 years, we have already executed the pilot project on the land-based application. So the testing has been completed successfully. Currently, we are running the pilot case on one of the ship in Europe, and we expect the future-proofing as well as the entire test to get concluded soon. And somewhere in 2025 onwards, we expect the commercial offering of this product.
We have time for one last question. Can some other volunteer hand the mic to sir, please?
Yeah, good morning. I'm Shrikant. Being a shipbuilder, we are finding convincing the ship owners to go for alternate fuel, while the government of India is promoting strongly the building more and more green energy fuels. Typically, if I look at the cost of building a green fueled propulsion system, ships with such kind of propulsion system cost about 2.5-3 million more. So, are there any substantiating calculations, in more detail could be provided later in your convenient time, so that we can convince, return on investment from the ship owner, how beneficial is it? It will be great in promoting that.
Yeah, sure. So whenever there is a business case, as I was showing in my presentation also, The business case includes a lot of elements, which includes basically the profiling of the vessel and the operation requirement of the vessel, en route, the fuel availability, and based on that, the conventional vessel versus the future fuel readiness vessel. All those factors could be prepared. Yeah, so we can share that information.
Thank you, gentlemen. With this, we conclude the Q&A session. Beautiful presentation, sir. And it is in such gathering we are able to appreciate how the world is coming together to propel towards decarbonization. Wärtsilä also is playing an important role here. Please put your hands together for Mr. Sachin Kulkarni. With this over, I now invite Commodore PHM Sally, Senior Consultant, Subsea Vehicle Design L&T, to kindly come forward and present mementos to our three distinguished presenters as a token of our appreciation. First, Commodore Amit Ray. Mr. Mikhail Robnik. Mr. Sachin Kulkarni. To capture the occasion, I invite all those on stage for a group photo. Thank you, esteemed speakers. I request you to please go back to your initial seatings. Also, I request Dr. Abdul Rahim, President Dostas, on the dais, please. The technical presentations would not be possible without the efforts put up by a technical paper committee, and to comment their actions, I invite them for a token of appreciation from Dostas. First, I invite Dr. Satish Babu, Head of Department, Department of Technology, QSAT. Next, I invite Assistant Professor Anoop, Department of Ship Tech, QSAT. I also thank Mr. Abram Carey, who is not present with us today, but has an equal important role to play in the committee. I request the... Okay, apologies. We finish with this. Now, with the conclusion of today's technical paper, a short break with some refreshing beverage and light eats awaits everyone. I request you to move to both the sides of the hall. The tea is present at both the places. Next session will feature a panel discussion on Green Horizons, a sustainability-driven solution for maritime and offshore sector, which promises to be highly informative. Till meantime, enjoy your eats, network with others, and explore stalls and exhibition outside. Thank you.
We would like to express our deepest gratitude to all the sponsors of this event, beginning with platinum sponsors, DRDO and Cochin Shipyard Limited, our gold sponsors, ABB, and the silver sponsors, Indian Register of Shipping and Catmatic. We also thank Aries Energy, registration area sponsor, and Class NK, the delegate kit sponsor. Great Waters, delegate badge sponsor. We also thank our associate sponsors, GRSE, Goa Shipyard Limited, L&T Engineering, Zentech Incorporated USA, Wärtsilä, Napa, Naval Group.
Announcement, the panel 3 will begin at 11 a.m. Thank you.
And Shipbuilders Limited. Our event partner is Biz Events and media partner is Maritime Standard.
Consistently working on indigenization of defense technologies since its inception in 1958. The motto of DRDO has been Balasya Moolam Vigyana. The source of strength is science. DRDO has been at the forefront of Atmanirbharta in defense, having technical capabilities across the domains of land, air, and sea. Its strong network of 41 laboratories, associated work centers, 5 unique young scientist laboratories are spread across the country. DRDO has developed wide range of strategic and tactical weapon systems, platforms, equipment, technologies, sensors, and has also established state-of-the-art test facilities and infrastructure. The production value of DRDO developed systems inducted or approved for induction stands over rupees 3 lakh crore. Taking forward the thought of Atmanirbhar Bharat, DRDO has been spearheading the indigenization of Indian defense technologies, driving India on the path to pride. DRDO works in 7 different technological clusters, namely naval systems and materials. The cluster provides cutting-edge naval and material solutions for the armed forces. It has developed state-of-the-art underwater sensors and surveillance system, underwater weapons and associated systems, air-independent propulsion systems, protection technologies for marine platforms. High-strength material is also a speciality of this cluster. INS Vikrant is built with the high-strength steel developed by this cluster. Aeronautical systems. This cluster is engaged in the development of state-of-the-art combat aircrafts, unmanned aerial vehicles, aero gas turbine engine technology, airborne surveillance systems, parachutes, and lighter-than-air systems. Armament and combat engineering systems focuses on research and development of armaments, explosives, land-based combat vehicles, and engineering equipments, including ATACMS, world's longest range artillery gun system, missiles and strategic systems. This cluster is responsible for the design and development of state-of-the-art missiles and strategic systems for the deterrence of the country. Electronics and communication systems, state-of-the-art technologies.
There's an announcement that tea and beverages and refreshment are served on either side of the hall. Thank you.
Life sciences, equipping the service with the best. Cutting-edge weapon systems and platforms do not really achieve their intended purpose until the integral human component of the war machine is also optimized in terms of psychological, physiological, and nutritional well-being, with life support systems and protection from all conceivable operational hazards. Microelectronic devices, computational systems, and cyber systems. The microelectronic devices subcluster focuses on thrust areas and technologies relating to microwave tubes, solid-state electronics, including microelectronic device design and manufacturing. The computational systems subcluster focuses on systems and technologies relating to artificial intelligence, command and control, information and communication security, and many more, to develop defense R&D ecosystem and boost indigenous manufacturing. DRDO is supporting the industry through policy of transfer of technology at minimal or zero cost. Now, industry are working with DRDO as DCPP, PA, DP for development of many critical technologies. As of now, 1,550 TOTs have been handed over to industries by DRDO. DRDO has instituted multiple mechanisms and structures for result-oriented collaboration with academia, industry and think tanks to design and develop next-generation systems. As an ongoing process of creating a DRDO and academia ecosphere, DRDO has established 15 centers of excellence in collaboration with various academia institutes all over the country to develop critical technologies. In addition, DRDO also funds academic research in defense science and technology through mechanisms, schemes like extramural research, research boards, and contract for acquisition of research services. DRDO also funds research under its various grant-in-aid scheme to undertake research in the fields of aeronautics, armaments, naval, and life sciences to strengthen funded research. Technology Development Fund (TDF) scheme is in place to encourage participation of industries, especially MSMEs, startups, to develop new technologies and products, upgrade existing products, systems, and R&D for indigenization of imported components and systems. Till date, 68 projects have been sanctioned under TDF scheme with the commitment of 283 crore. Dare to Dream Innovation Contest to promote innovators and startups are being conducted. 3 versions of contests have been concluded. Potential ideas are funded through TDF for converting to products. DRDO, as the premier technology organization of our country, is working in the pursuit of achieving indigenous development and production of strategic and defense systems, making the nation self-reliant in advanced defense technologies. रक्षा अनुसंधान से आत्मनिर्भर भारत की ओर अग्रसर। जय हिंद। Located on the southwestern coast of India, Kerala is a land with a lush maritime history that dates back to several centuries. Cochin, the thriving port city in Kerala, is the commercial capital of the state and an epitome of Kerala's cultural richness. In 1972, India's maritime aspirations found a new anchor as India's port city. Cochin became the birthplace of Cochin Shipyard Limited. Nestled in Cochin's heart, CSL's sprawling 176-acre facility boasts of world-class shipbuilding and ship repair infrastructure, from state-of-the-art 3D modeling softwares, large dry docks, long waterfront with jetties, machinery and equipment, everything essential for a HSE-compliant one-stop solution for the industry. CSL's portfolio of an extremely wide variety of vessels is a testament to its versatile, adaptive and flexible culture and capabilities. It offers the full spectrum of shipbuilding, ship repair and vessel conversion related solutions. CSL added yet another feature to its cap when it built INS Vikrant, India's first indigenous aircraft carrier, which was commissioned into the Indian Navy in 2022.
यदि लक्ष्य दुरंत है, यात्राएं दिगंत है, समंदर और चुनौतियां अनंत है, भारत का उत्तर है विक्रांत।
CSL's golden flag flutters proudly, celebrating 50 years of maritime excellence. CSL's renewed focus seeks sustainable horizons aided by technological innovations for a cleaner, brighter future. The yacht's clientele footprint spreads across the globe, having delivered numerous vessels to clients in the US, Europe, Middle East, and other countries in the region. CSL's geographical expansion initiatives have resulted in the setting up of ship repair business units in Mumbai, Kolkata, and Port Blair, thereby making CSL the only Indian yard offering direct professional services with dedicated infrastructure on both the east and west coast of India. Wholly owned subsidiaries companies, Udupi Cochin Shipyard Limited on the west coast and Hooghly Cochin Shipyard Limited on the east, have augmented and enhanced the group's capability in shipbuilding, including on the niche and new technology fronts to a great extent. The new large dry dock and the new international ship repair facility established in Kochi as part of the company's long-term strategy roadmap will significantly augment the shipbuilding and repair infrastructure in India. CSL has incorporated the Strategic and Advanced Solutions Division exclusively to handle and maintain its leadership position on the front of new and emerging technologies. CSL takes pride in being one of the global leading yards on the sustainable solutions front, having constructed the world's first zero-emission fully autonomous ferries for Europe, as well as being the vessel builder for world's largest hybrid electric urban water mobility service, the Kochi Water Metro, operating in Kerala, in India. The company lays significant emphasis on skill development and runs Vigyana Sagar, its dedicated and self-contained training facility in Kochi. CSL is India's first shipyard to have obtained the CII Greenco Silver rating for its efforts at energy conservation and environment-friendly initiatives. CSL is also the first Indian shipyard with an integrated management system covering safety, health, and environment certified by DNV. With the ethos of Make in India, Make for the World, CSL has recalibrated its sails and set sights on continuing at the forefront of a brighter, greener future.
We are in the middle of transformation. Electrification, digitalization, connectivity, cloud computing, and machine learning, they're all converging. Sensors are getting smaller, big data is getting bigger. Augmented reality and virtual reality are providing previously unattainable field of use. And all this is providing unprecedented opportunity to create value and increase the sustainability of the shipping. Maritime industry represents approximately 2.5% of the world's greenhouse gas emissions. And that number is set to grow with an increase of the global trade. ABB is committed to reverse the trend to take that number down. We at ABB believe that the next generation of vessels will be electric, digital, and connected. Electric because they are more efficient and sustainable, and digital and connected because that will take the productivity and safety of the vessels to another level.
Personally, I think that the Azipod propulsion system is one of the greatest innovations in maritime history. All big ships need something that moves them forward. Azipod propulsion system combines propeller driving the ship and electric motor driving the propeller and the rudder which is steering the ship. For the Azipod unit designs, the sustainability idea and thinking starts already from the design table, that we consider the materials we use, how much we use it, what kind of materials we are using. There are about 400 Azipod units in operation at the moment. Even though the Azipod propulsion system is mostly known from cruise ships and ice-going vessels, it has been installed into more than 20 different ship types. in my opinion, of course, one day I would like to see that Asipod propulsion system is equipped in all the vessels around the globe.
The electric ships are currently representing about 10% of the world's fleet. And to make the maritime industry more sustainable, that number needs to grow. We at ABB are fully committed to reaching that goal. In fact, we just delivered 2 ships sailing between Sweden and Denmark on full electric power, and we were able to reduce the greenhouse gas emissions.
I think it's important as a company.
Announcement, ladies and gentlemen, the panel discussion 3 is about to begin soon. I request everyone to make their way to Oman Hall. If required, you can bring your tea and refreshments along. Thank you.
Point 1. This vessel we're on today is from 1992, and the other one that we converted is from 1991. But they are state-of-the-art vessels when it comes to the technology. And that's what we're very proud of at 4C, is these vessels are designed in the end of the 80s, but still have the newest technology on board. We have the battery power of equivalent of 60 Tesla cars. We charge on the Swedish side roughly 9 minutes and 5.5 minutes on the Danish side. We have less noise, we have less vibration, but we also have another important thing, is that the people that are working in the company are very proud that we are first mover in the world with this new technology.
ABB has already started to put batteries on vessels, smaller ferries going from A to B, and we have also taken bigger vessels, like the 4C vessels going between Sweden and Denmark, where they run purely on batteries. Yeah, I think we will see a transition in both fuel and technology, so we're taking one step at a time. For larger vessels, we see a good potential to have a hybrid power plant. We can cut down on emissions, or we will probably also see these larger vessels powered by renewable power. It's a good potential to cut down on local emissions that affect people where they're living and local communities. And this technology with electric vessels and hybrid vessels is a technology that are available now and can address these issues now.
I think in general sustainability is important for any industry, and of course ABB wants to be a big part of that with its electric digital connected vision.
I think the industry is going through a big change right now. Being first mover, we can actually show other ship operators that there are possibilities to use the same tonnage as you have today and not going for new builds.
The member states of the IMO, International Maritime Organization, pledged to reduce the greenhouse gases by 50% by 2050. And we at ABB are committed to that goal and to provide innovations and technology to make that possible.
We would like to express our deepest gratitude to all the sponsors of this event, beginning with platinum sponsors.
The panelists are already here. May I kindly request all delegates to return to their seats as we prepare to begin the panel discussion very soon. You may please bring your tea and refreshment inside Oman Hall.
Goa Shipyard Limited, L&T Engineering, Zentech Incorporated USA, Wärtsilä, Napa, Naval Group, Alboa D. Damon, Shiptech Icon, and Mazagon Dock and Shipbuilders Limited. Our event partner is Biz Events and media partner is Maritime Standard.
consistently working on indigenization of defense technologies since its inception in 1958. The motto of DRDO has been Balasya Moolam Vigyana. The source of strength is science. DRDO has been at the forefront of Atmanirbharta in defense, having technical capabilities across the domains of land, air, and sea. Its strong network of 41 laboratories, associated work centers, 5 unique young scientist laboratories are spread across the country.
The panel discussion will begin in 5 minutes. So please come back to a manhole.
Also established state-of-the-art test facilities and infrastructure. The production value of DRDO developed systems inducted or approved for induction stands over rupees 3 lakh crore. Taking forward the thought of Atmanirbhar Bharat, DRDO has been spearheading the indigenization of Indian defense technologies, driving India on the path to pride. DRDO works in 7 different technological clusters, namely naval systems and materials. The cluster provides cutting-edge naval and material solutions for the armed forces. It has developed state-of-the-art underwater sensors and surveillance system, underwater weapons and associated systems, air-independent propulsion systems, protection technologies for marine platforms. High-strength material is also a specialty of this cluster. INS Vikrant is built with the high-strength steel developed by this cluster. Aeronautical systems. This cluster is engaged in the development of state-of-the-art combat aircrafts, unmanned aerial vehicles, aero-gas turbine engine technology, airborne surveillance systems, parachutes, and lighter-than-air systems. Armament and combat engineering systems focuses on research and development of armaments, explosives, land-based combat vehicles, and engineering equipments, including ATACMS, world's longest range artillery gun system, missiles and strategic systems. This cluster is responsible for the design and development of state-of-the-art missiles and strategic systems for the deterrence of the country. Electronics and communication systems, state-of-the-art technologies in the fields of EW systems, radars, sensors, and directed energy weapon systems and communication systems used in various flagship programs and platforms of DRDO. Life sciences, equipping the service with the best. Cutting-edge weapon systems and platforms do not really achieve their intended purpose until the integral human component of the war machine is also optimized in terms of psychological, physiological, and nutritional well-being, with life support systems and protection from all conceivable operational hazards. Microelectronic devices, computational systems, and cyber systems. The microelectronic devices subcluster focuses on thrust areas and technologies relating to microwave tubes, solid-state electronics, including microelectronic device design and manufacturing. The computational systems subcluster focuses on systems and technologies relating to artificial intelligence, command and control, information and communication security, and many more. To develop defense R&D ecosystem and boost indigenous manufacturing, DRDO is supporting the industry through policy of transfer of technology at minimal or zero cost. Now, industry are working with DRDO as DCPP, PA, DP for development of many critical technologies. As of now, 1,550 TOTs have been handed over to industries by DRDO. DRDO has instituted multiple mechanisms and structures for result-oriented collaboration with academia, industry, and think tanks to design and develop next-generation systems.
Good morning. We are going to begin with the panel discussion 3. The panel will be chaired by Mr. Jaykumar S., And joining him as panelists are Mr. Anil Jacob, Head of Fleet Performance Center, Bernard Schulte Ship Management, Mr. Amit Kumar, Team Manager, Vessel Performance Team, Maersk Fleet Management and Technology India, Mr. Shivaram Swami, General Manager, Business Development, Cochin Shipyard Limited, Mr. Ajay Kumar Singh, Head of Section Maritime Advisory, India, DNV, Mr. Mahesh Krishnappa, Senior Vice President, Head of Marine and Ports, ABB, Singapore, Mr. Basant Konat, Senior Director, R&D, Aries Energy. I request the panel chair and panelists of panel discussion 3 to come and take their seats on the stage. Thank you. As we proceed, our first panel discussion for today will focus on Green Horizons, sustainability-driven solution for the marine and offshore sector. With the growing emphasis on environmental responsibility and sustainable practices, this session will explore innovative solutions and strategies aimed at enhancing sustainability in the marine and offshore industries. Questions will be welcomed after the discussion owing to the time that would be available with us. I welcome our esteemed panel chair, Mr. Jayakumar S., General Manager at Sofik Floating Systems, Singapore, to lead this discussion. S. Jayakumar is a seasoned executive with over 4 decades of experience in leading major offshore energy projects and entities across Asia, Europe, Brazil, and the US. His expertise spans oil, gas, waste to energy, and new energy sectors. In his current role as General Manager, Sofik Floating Systems, he is responsible for overseeing Sofik's operation in Singapore and lead the team in transforming and expanding its business interest and regional presence. Handing over to you, sir.
Thank you for those kind words. And good morning to all. I hope everyone is settled so we can start the session in all earnest. We will start the session now. Eighty percent of the living creatures in this planet is actually beneath the sea. So think of it like that. Actually, our biggest stakeholder for the maritime industry is actually the sea itself. And and there have been many initiatives to do it. Many initiatives to take care of that. But on the other hand, 80% of the global trade is happening through shipping, through sea. So there is no way of stopping what we are doing currently. So ultimately, it is about balancing these two opposite requirements. We have to keep going. We cannot stop. At the same time, we have to take care of the environment and make sure that all the maritime, our industries, does not have any negative impact on the environment. And we know global bodies like global bodies like IMO are further tightening the expectations regarding net zero emissions and even making interim milestones clear so that There's no slipping through it. So that it's being tightened, and all for all the right reasons. So that is on one side of it. On the other hand, we are all, at the end of the day, we are all businesses. As businesses, we are answerable to our shareholders and their expectations. And therefore, we need to still continue doing our work and make sure that we are profitable. And that would mean managing the challenges of whatever is coming into our track. So if you look at the industry as a whole, we are now, previously the days are gone when we could just gloss through what is sustainability and provide good-looking reports. Things have been tightened and everything is being measured. So whatever we try to do today is being measured in terms of CO2 emissions and therefore under stricter control. And carbon tax is another reality that's already happening. At least in some countries, it's right out there, and it's being tuned up for achieving the results that the countries are expecting. All that adds to the bottom line, and all that adds to your cost. So in total, we have these different dimensions that we are trying to balance and trying to make sense of it. And that is where we need, typically one other thing is, in most of these things, like when there are new issues or new solutions, new innovations, these are usually started off by the academia and then developed in laboratories or fine-tuned in scientific organizations and such. But the uniqueness about sustainability is that it is actually a practitioner's problem. And as for the reasons I just said, at the end of the day, it's a business that we are trying to carry on. And when there are reasons that we find it difficult to manage, the practitioners have to step in and do what it takes to manage the needs of the hour. So that is what is going on now. And that is why if you look at our panel here, we are all practitioners. And we have, among us, we have chief engineers, we have technologists, we have product developers, and ship builders, and ship designer. So we have this panel which is definitely capable of handling these issues. Let me quickly introduce the people, the panelists, for your benefit. I'll start with Anil Jacob. Anil is head of fleet performance at BSM. He's got many years of sailing experience as a chief engineer, and is right now responsible in BSM Bernard Schulte for managing vessel performance and operations. He will expand on that later. And maybe next I introduce Ajay Kumar Singh. He is from DNV. He is the head of maritime services in India, maritime advisory in India, and he's a regulatory. I found something very unique. He has done his MBA in HSE. So he knows a lot more about these things than most of us do from school. So Ajay will also talk about the regulatory perspectives and challenges in sustainability. If I could move on to Mahesh. Mahesh is from ABB. He is, again, head of maritime advisory. Right now, on paper, he's heading Singapore operations, but I understand he is moving to India, so he'll be heading the maritime advisory in India, on maritime business in India, sorry. And next on to Amit Kumar. He's from Maersk, and he's also, as we all know, Maersk is a leader in this aspect, and he's also responsible for vessel performance and optimizing operations. Am I right, Amit? And so Amit will also bring about the perspective. We all know Maersk is way ahead of the rest in this initiative, so we hope to learn a little more from Amit on this.
I have Shiv after that, Shiv Kumar. Shiv is from Cochin Shipyard, so he's a representative for CSL, and he's a veteran. He's been, he also was a chief engineer, and subsequently he worked for IRS and BV, I understand. So he's covered the class part of it, and he's right now doing business, helping out on the business division at CSL. And last but not least is Basant. Basant is the senior director for R&D affairs in Ares Energy, and therefore he has an entrepreneurial angle to it. And he's essentially coordinating a lot of the technological efforts that Ares is putting into the decarbonization area. So we will get a perspective of how he deals with third-party services in getting the problem sorted out. So that is largely our panel. They will give a bit of them, more introduction of themselves as they speak. Perhaps before we start on the program proper, I could set a bit of expectations and perhaps a bit of house rules on this, how we want to carry out this discussion. I mean, yesterday we saw the panel run as 10 minutes, a full session of 10 minutes each or so talking. We wanted to, in this day and age of TikTok and Reels, we thought information should be given in bite size. And so we decided to segment the time into 3 segments so that we can have focused discussions on that area from each of the panelists. And we should be finishing off. We are conscious of the time, so we'll be finishing off that in about 20-25 minutes at most, and leaving about 5 minutes for Q&A per session. So please do, if you have any pressing questions, we may take 1 or 2 questions within that 5 minutes, and before we move to the next segment, should you have some questions that you did not manage to ask within that time, of course we'll have, depending on the time, at the end of it, we will definitely cover all remaining questions. When we talk about questions, one thing we would like to flag out is sustainability should concern the youngsters more than the people sitting in the front, because you need to take this world for a few more years than us. So please be engaged. Please ask the questions. We expect at least 1 or 2 questions from the students who are attending this. Okay? So we'll move forward. So the first of the segment, as I said, we have 3 segments. The first of it is we will go for our own perspectives. Perspectives on sustainability. Because we represent different stakeholders, different segments, different dimensions, so we wanted to give our individual perspectives. I will set the ball rolling. So my perspective on sustainability, I'll put it in 3 succinct aspects. First is the macro perspective. And since I've been living and working in Singapore for a long time, I took some guidance from the Singapore guidelines for the macro perspective on sustainability. Basically, simply put, what they say is that we owe it to ourselves and the next generation to leave this world a better place after us, And it's a simple statement, but if you think of it, it's a very powerful statement. That means whatever we do, economic activity or personal activities, we shouldn't leave the world worse off for that. That brings on a large commitment on our part to clean up after us, or rather not to dirty it in the first place. The second perspective I wanted to highlight was about energy transition. We talk about energy transition, and there are a lot of bets being placed on it, and which fuel and what would be the rescue fuel, etc. But we must also be realistic and take into account that transition in a commercial and scale and size will take some time to mature.
So there is still a responsibility for us to tide over this period. And that could be 10 years, 15 years, depending. I mean, we are forecasting the future, so there might be a bit of time that we'll have to budget in for that. So, and in the meantime, we again owe it to ourselves to whatever energy needs are there to meet that in a responsible manner. So that we maybe another 15 years before we find the right solutions for all of this to scale. But in those 15 years, we want to get it any worse than what it is today, if possible. So that is the second perspective. And the last perspective is, as a shipbuilder, I feel that while, I mean, we are a heavy industry, and therefore, naturally, we do contribute a lot to these problems. So we need to look at ways and means of doing things much better. I mean, greener products, like I was in the business of building FPSOs, so we look at greener solutions in FPSOs, which is a responsible way of providing, because energy needs cannot be cut off. We cannot just switch it off for now and wait for new solutions to appear. So in the meantime, we need to find a responsible way of doing things and get there and be there when the solutions are nearly ready. So these are the three perspectives I wanted to share. And I will move on to hear from the rest of the panelists. Maybe I'll start with Anil. Would you share your perspective on sustainability with a little bit of introduction about yourself to start?
Yeah, hi. Good morning, everyone. Thank you, Jacob sir. I am Anil Jacob. I am heading the Fleet Performance Center in BSM. We are a company with our software division and the ship management division here in Smart City. So our software company is Mariabs, which is basically a marine solutions company. And we also look into the decarbonization as well as the digitalization part. This means that we also have a team which is looking into the present EU ETS regulations, as well as we are also now into the fuel EU. So this means both the service as well as the product is what we want to sell. That being said, we also believe that sustainability is going to be the future. And I think we are at a stage where shipping is transitioning, but more of challenges is what is being talked about. We also have a separate entity which is looking into emissions management. We just set up that company 2 months back. It's called Ocean Opt, and our basic idea is to ensure that shipping companies they manage their emissions well and have their own sustainability targets. So so my take on sustainability is that going by the definition, whatever it takes to let's say satisfy the needs of the present, but not jeopardizing the needs of the future. I think for that, the realization for what is first needed is what is the present, what is the future. And that needs to be properly defined. What are my operations presently and what I would like to become in the next 10, 15 years. Luckily, we are all sitting here because I believe that IMO had set the targets in 2018. And that's why most of the discussion is happening. So I believe a commitment is something that that word is what I do whenever I think about sustainability, because you need to commit yourself to some plan, some goal, some target. And the second thing which I also believe is collaboration, because in these uncertain times where the regulatory bodies are forcing a lot of things on you, you have to collaborate with people. And that's the realization that I cannot solve the whole thing. I need people with me to solve it, in a combined way, so that, the entire shipping industry, if needs to be decarbonized. And I also believe that innovation and digitalization is also the path of doing it. So we are at a stage, as ship managers, we have a lot of challenges where still the vessels send Excel sheets, needs to be digitalized. So I think from our point of view, setting up a software company like Mariabs, which is on the path of digitalization, is already a step towards that. And, I think that's what sustainability is for me. I think we are also we need to go a lot into sustainable reporting. So I think that's my take on it, if you ask me. Thanks.
Ajay, would you follow up on that? What's your perspective as a regulator or a classification authority, but having your advisory role in this?
Thank you, Mr. Jaykumar. Good morning, ladies and gentlemen. My name is Ajay Kumar Singh. I am head of section for Maritime Advisory India for DNV. Working with DNV since last 9 years now. A little bit about DNV. We are 160 years old company, and we have around 100,000 customers worldwide. We have offices in about 400 countries. 400 offices, sorry, in India, in country. From my perspective for sustainability, I would say we as a DNV emphasizes the importance of decarbonization targets, aligning towards IMO, achieving by 2050, net zero, and of course about India 2070. There are different options to do it. Number one, alternative fuels, of course. We're talking since morning about alternative fuels. Transition for carbon neutral fuels. We have recently published Maritime Forecast 2050 and Energy Transition Outlook 2023, where we have shown different trends in alternative fuels till 2050. However, I would say depending solely on alternative fuels won't be the only option. There has to be a combination of bits and pieces. Second could be technology innovation. There are a lot of things happening from the decarbonization as well as digitalization. Digitalization could be efforts towards reducing the emissions. Again, we cannot solely depend on that. And then, of course, as Anil mentioned about the collaboration. Of course, there is a need of joint industry projects, more industry events such as Dostas. Such as events are required. And of course, mentioned about in the beginning, Mr. Jaykumar, youngsters, we need them. Because I know they are more energetic than at least from sitting on the table. We need more questions. We need to have more innovations from them. So that is thing. Maybe a simple sustainability from my perspective, I would say anything which to perform maritime operations with no damage or minimum damage to ecology and health. That is sustainability for me. Thank you.
Thank you, Ajay. And Mahesh, we have heard the ship manager and the regulator. So what do you, the classification society. So what do you think as a service provider in this industry and someone who has a lot of initiatives going on especially in offshore wind and such? What's ABB's take on it and your take on it? Sorry.
Yeah, thank you, Mr. Jaykumar. Yeah, first of all, a short introduction of myself. I'm Mahesh Krishnappa. I'm responsible for new building business in Singapore and now going to look after India also. So I'm basically an electronics and communication graduate by qualification, and I've been with ABB for almost 29 years, and I had the opportunity to be in different functions, starting as a design, then project management, sales, and then business management. And also a unique opportunity to be working in, I had started in ABB India, then Singapore, and also in Korea for 2 years. So all through I've been in the maritime ecosystem. So at least I can say that I was blessed with this opportunity, I can say. Coming specific to the company, I represent ABB. ABB is a global technology leader in power and automation, addressing specific industry and application requirements. And there are 19 divisions of ABB, and I represent the Marine and Ports division. As the name suggests, it is to the industry we serve for the ports and the marine side. Just going on towards the topic of sustainability. So when maybe I start with the context of as a company, because we are serving different industries. So ABB's sustainability approach is built on 4 main pillars, basically addressing the global challenges and also, key areas as defined by the United Nations Sustainability Development Goals. There are 17 of them. It addresses a certain part of that. So one is enabling a low carbon society. Basically with our customers and partners, we avoid emissions in our own operations. And we have also ambition to be in our own operations to be carbon neutral by in 2030 and zero in terms of greenhouse gas by 2050. So just to get a feel of where have we reached, as in 2023, we have our customers, we call it avoided emissions, which is also a new terminology as per SBTi. So we have avoided almost like 74 million tons in CO2 for the customers when they used our products. The second pillar of our sustainability approach is basically preserving resources. Basically, we are embedding circularity in what we do in our value chain, complete value chain. Basically, you look at reducing waste, increasing recycling and promoting reusability. And another third element which is key is, apart from this, is promoting social progress. So we are committed to create an environment which is a safe, fair and inclusive environment for all our employees. So in that also promoting wherever we are there, we promote social progress and serve the communities in the locations where we are. We have quite extensive programs in the community where we are present. So if you just to take where we are in this, in our, as on 2023 end, almost 21% of our senior management staff are women. And the last element which is important today is, which is a pillar for us, is fostering a culture of transparency and integrity. So bringing accountability in every step, in every value chain, part of the value chain. So that is what we have as ABB as a group. Now coming specific to maritime, I represent marine and ports. I am here because of sustainability. Our purpose, the core purpose of our is we enable sustainability and we drive sustainability and enable decarbonization with our electric, automated and digital solutions. Again, why we are doing this is also we see as a huge opportunity with our stakeholders in the industries. Currently, if you include the ports also, 3 to 4% is the greenhouse gases. If there is no intervention, there is a risk that we might end up in 13% by 2050. So this is also providing an opportunity to the industry, to bring out solutions to address the problem statements. Thank you.
Thank you, Mahesh. Now, Amit, we all know Maersk is a trailblazer when it comes to sustainability and probably showing the way in many areas. So we are all excited to hear your perspective on sustainability.
Yeah, thank you, sir. Yeah, so my name is Amit Kumar. I am from Maersk. I lead a vessel performance team in Mumbai, and we have a different teams who manage who works for the decarbonization goal. And to name a few, we have a voyage execution team, which comprises of the captains from the fleet who manages who try to reduce the waste from the voyage every day. Then we have a vessel performance team for the own and time chartered fleet. We manage the performance of around 700 vessels in the world, out of which 320 belongs to Maersk fleet. Then we have a decarbonization team who provides us the visibility on CO2 emission on a daily basis, and then our team optimize on top of that. Yeah, so first I would like to tell what's my personal take on decarbonization. So like everyone says here, I think there is no alternative to decarbonization. I am very committed to to leave the future little better than what I am living in today for the next generation. And my job actually gives me that opportunity on a daily basis, and that gives me a kick also every day when I go to office and I see that we have emitted less CO2 today than yesterday, then we celebrate it. So that's what I like on a day-to-day basis. As a company, I think everyone knows that Maersk is highly committed to decarbonization and has set an ambitious goal. We have a target to achieve net zero by 2040, which is 10 years earlier than what IMO has. And to achieve that, we have actually aligned our operations, technology, and strategy to achieve that goal. Decarbonization is something not new to us, means we have been working on this for many years. As we all know that we had a vessel, waste heat recovery vessel, which came into operations in 1992, and then it was followed by slow steaming. And then in last few years, we have accelerated the journey by transitioning to the IoT platforms. So till today, around 80% of our fleet is on IoT platforms. So that gives us opportunity to optimize faster. So to sum up, what I would like to say that decarbonization is very important to all of us, and it also requires a lot of innovations. And we are actually progressing very well on that journey, and we would like to be the market leader in this journey. Yes. Thank you, sir.
Thank you very much. Very inspiring. And Shiv, you're the all-rounder, you know. So, and you are also you represent CSL probably, which gives a lot of ideas to the local area and to the state as a whole. And also, you are close enough to our university and probably, a thought leader in this. I'd like to hear your perspectives on it. Shiv.
Yeah, thanks, Jaykumar, and good morning all. First of all, I just echo your definition of sustainability. And I think for me personally, sustainability is all about coexisting with the nature and how you can harness it and give back the planet in a better shape to the future generation. And we are all worried about the global warming and the temperature rise. That's why we are all talking about this sustainability a lot. And coming to professionally with Cochin Shipyard, I was fortunate in a journey which Cochin Shipyard is leading now in this transition phase where we are able to associate with a lot of good initiatives. Understanding this requirement for sustainability and to drive decarbonization and other initiatives, we felt the need for a separate group which can work along with the problems and find solutions. That's how in 2020 we formed a team for sustainability alone, which is called as CSAS, that is Cochin Digital Solutions Group, Strategic and Advanced Solutioning Group. We culled out the best brains out of our team and put them as a group to work towards it. In the meantime, we also were fortunate to work with some of the finest in the industry. In 2017, when these things were all being talked, Cochin itself was witness to a great idea from Cochin Water Metro, whereby they decided to come with a huge project of 78 electric boats to be put into the water for urban mobility space. I think it was much ahead of the times, even compared to some of the developed countries. So I think what drove that organization and what drove this society probably is our culture itself is very much engraved with this sustainability in our way of life. That is the same example what we can talk about the Cochin International Airport. In 2013, when they put up that huge solar power plant, nobody in the world, even the Western world, was not talking about it. So that sustainability is very much there in this society, and that is being reflected in many ways. And again, in 2020, during the COVID time, we were fortunate to get associated with another great program for a Norwegian company, where we built 2 autonomous electric barges. And as a mechanical chief engineer, I was pleasantly surprised to find a vessel where not a single drop of oil was there, because it doesn't have any fuel oil, no lubricating oil, no hydraulic oil, nothing. So ship without oil is something which we never dreamt of, and we could manufacture to such fine products for one of the best Western European country. And I was fortunate to be associated through Cochin Shipyard on that project as well. And besides that, shipyard is aiming to become a green shipyard by 2027. All our operations will be met by green energy sources. So that's something which we are putting. We are already a gold green rated shipyard. So these are all voluntary certifications which we have gone ahead. So we strongly believe in sustainability, and that is reflecting in our actions as well as our interest in such solutions. Presently, we are executing 7 projects of 34 different ships of different types, varied from methanol fuel-ready vessels to hydrogen fuel cell powered vessels to battery hybrid vessels and so on. And I think, as told by other panelists, we definitely are looking at a better world through these initiatives, even though they all started with regulations and policy push. But I think we are all realizing that we need to give back this world in a better shape. Thank you.
Very encouraging to hear that, Shiv. And I would think a large entity like Cochin Shipyard, which also has its reach out to many subsidiaries and SMEs in the region, that would help us to spread this thought and we must felicitate Cochin Shipyard for championing the sustainability efforts in this part of the world. Turning to Basant, Basant, you have a very unique role, so I think you'll give a very interesting perspective to what we hope to hear.
Thank you, Jagamar sir. I am the director for the research and development for Aries. So for the past 8 years, I had been closely following the works of IMO, the works of European Union, and the rules and regulations they had been formulating over time. I had also been in close discussions with a lot of technology providers, providing various technologies, that is, short-term solutions and long-term solutions to the industry in decarbonizing the maritime industry. So, based on the learnings I had done over the past and my observations and the views of the panel, my observation is that we have a good start right now. The observations are based on 2 aspects. Number one is the developments that we have made over the past 8 years on the regulatory aspects. And number 2 is the developments that we have done on the technologies aspects. And it had been an accelerated developments that had been happening over the past 6 to 8 years. Over the past, on the regulatory side, IMO right now have set the targets of net zero by 2050. European Union is also targeting net zero by 2050. So the goals are aligned right now. And on the technological side, there had been a lot of technologies put forward to the industry, providing energy efficiencies from the range of 0.5% to 20% for the short time. And also there had been a lot of research and development and actual production going on the long-term solutions like the green fuels, zero-emission fuels, and near-zero-emission fuels. So basically on putting up together on the regulatory side and on the technological side, given that we had accelerated only after Paris Agreement in 2016, we had made a big progress. So of course, as Mr. Anil and Mahesh said, There had been a lot of we need a lot of collaborative efforts to take it forward. Innovations are required to take it forward. Also, as Mr. Mahesh said, there is a lot of customer pressure, pressurizing everybody to go green. It seems to be very positive, and everybody is gathering together to push it forward. My take is that we have a lot of challenges in front, but we have a way ahead. We have a good way ahead. Certainly, there is a way ahead to move ahead with the decarbonization. And I also want to underline the point that every one of the panel had agreed that we need to leave the world in a better position than we have seen it. Thank you.
Thank you. Thank you, Basant. We have now given our first take on it. We will next move on to opportunities and then subsequently to challenges. But if there are any pressing questions, we would like to take it based on what you have heard so far on this topic. Let's not digress to other things. On the topics that we have discussed this far, if you have any pressing questions, we could give one or two questions at this time. Yes, please.
I'm Pramod Kumar. I just want to get some idea from you that the sustainability we are saying regarding the electric propulsion and all. But if you see, the local efforts are okay. But globally, if you see, the same amount of carbon is burned somewhere. That means pollution is happening somewhere, but we are saying that no pollution in current locality. That's one aspect. Secondly, the electric batteries are, after a few years, its disposal is extremely hazardous from the current point of view. So these two things will abstain us from that sustainability. This is what, so you kind advice is solicited.
I will take a first go at it, but perhaps someone can add better. And like any other public good, I mean, it takes a whole of the world approach to solve sustainability problems. I mean, when we were preparing for this and deliberating among ourselves, we also discussed different nations' attitude and approach and speed. For example, if you're looking at the low-lying countries, they're all in panic because they may not survive another 15 years by the time you find the next fuel. Whereas some other countries are laid back, or some other countries are, put it in quotes, selfish in approaching this. So it takes a whole of the world approach to solve the problems fair and square. But that doesn't mean we give up, I mean, the world is the world and we can't change it overnight. And people will take time to grasp the seriousness and the criticality of this. But meanwhile, the others have to push on. Like, as we always say, we need a Maersk among the owners to toe the line. Maersk, is Amit going to give a further add on that?
Yeah, just one point to add to what you said, sir. So what you are saying that we have a technology on the supply side, it's building up, and we all see that momentum is slowly building up. We are developing a technology which could propel the ship with alternate fuel, alternate source of energy and all. But the demand, I think the momentum on the energy side, it is still slow. But what we in Maersk believe that once we have created a good supply, then there will be momentum at the energy sides also. So it's just a matter of, the few years maybe from now, we might see the momentum is little slow, but eventually it will come. Means we would not have imagined that, that we will be so much thinking about on decarbonization just 10 or 15 years back, right? So now we have started talking about it. Most of the players have started acting on it also. But I think we are a firm believer and very optimistic that in future we'll have the momentum at the energy side as well. Yes.
Maybe one aspect to add is, would IMO or others have an influence on the pace of how things are being moved? Maybe Shiv or somebody else, whoever is more familiar with the IMO initiatives, could give us a perspective on that.
Yeah, basically, many initiatives from these recycling, how this is handled, how those challenges are addressed is also being discussed heavily. And if you really look at it, the goal of IMO by 2050 is the energy required to transport a ton mile of cargo has to come down drastically. So finally, the energy which will be consumed for transporting good will come down drastically. And there are some values which I don't remember, but it's very significant. So finally, we are going to consume less from this Mother Earth and continue our business activities. This is exactly what what IMO is trying to achieve through various goals.
I'll try to answer the second part of the question, what you brought about the batteries. It's actually a serious problem. So now at least what we know, I might not 100% answer the question, but I can share what I know. Companies are looking at circularity. Circularity is looking at finally you don't waste whatever you buy, you don't waste, so there is circularity. And there are concepts coming up, at least in the maritime space, for short sea shipping. They're looking at, reusable batteries, or swappable batteries they call. So it's happening in Japan. Singapore is also looking at with an initiative called Coastal Sustainability Alliance. So it is being addressed indirectly through certain initiatives. Maybe it is not a 100% solution, like what is happening we see in the outcome of the EV on the automobile sector. But I can say on the maritime, though the transformation has come quite slow, but they're already thinking early when they're getting into battery-related technologies.
Vasant, you had your hand up, so maybe you could give a quick and then we move on.
I wanted to address the first part of your question. What I understand is, okay, Canada, developed countries like Canada, USA, and European Union, they are trying for a decarbonization in their own side. And other countries, maybe the African countries, more poor countries, they are burning fuel. So what would be the net effect? That is a real problem that exists in the world. These countries cannot go for decarbonization right now, the poor countries and the developing countries. So their priority is food, shelter and clothing, not decarbonization right now. They have to achieve that. Then they need to achieve the economic development. Then only they will be able to think about decarbonization. So that problem exists. So that is why fuel oil will be prevalent far beyond 2050 to cater those countries and to cater such situations. But there are technologies that can that have the possibility to capture carbon and make a negative effect. So that is why a lot of carbon capture and storage system are being developed in various parts of the world. So there is a network of carbon capture and storage system that can capture carbon even from the atmosphere and deposit it far beyond, in geological formations. So such technologies has to be there to offset the carbon emissions of such poor countries.
In the interest of time, I would like to move on to the second segment, which is, there will be a bit of overlap between what you heard and this. We are talking about specific opportunities that each of these players see in sustainability. So could I start with, maybe I start with Mahesh on that?
Yeah, thank you. So, we see areas which we are covering or opportunities which are there is, with our solutions, we support the customers in the decarbonization journey. And if you look at how do we relate to that is, the marine emissions, maritime emissions are basically result, if you put in simple words, I'm looking at the audience also profile, not going to detail technical terms. Simple terms is a result of the vessel's distance it travels, the energy efficiency, and also on looking at the emission intensity. Three key elements when we look at. And for us, focus areas is basically looking at, how do we really address these three areas? This is where the source of emissions is. One is straightforward, increasing efficiency. Second is we believe in electrifying the maritime plant. Third is shift to cleaner energy. So our focus areas is basically, we have nothing much to do with the fuels. We can interface, work with those engines. We can look at increasing efficiency and electrifying maritime. So now, just to some cases where we are really, being successful is in the cruise segment. So cruise segment, we have a product called Azipod, which is a gearless steerable electric propulsion system, which has got an embedded motor and in a pod installed under a hull. So this has been, installed, maybe the first one was 30 years back. So since then, it has become a sort of a favorite or a product in the cruise industry. So we have more than now 100 vessels with the Azipod propulsion. And to give some data about, it almost with the Azipod propulsion, you can overall increase the efficiency by 20%. So what it means in really carbon is, an Azipod can save up to 10 kilotons of CO2 every year when it is compared to a conventional electrical shaft line propulsion. So that is one area. Then the other area where we have seen quite many opportunities coming up is in the container shipping. Container shipping after the COVID time has increased quite significantly, and there have been a lot of new vessel shift building on that. So we see there, we have been now getting opportunities. We have more than 80 container ships where we are giving something called the shaft generator solutions. The shaft generator solutions helps in overall increasing the efficiency of the vessel performance. So typically, for a very large ship, you can increase the efficiency by 5% when you go for a shaft generator solution. And the third area where we see is also adaptation of hydrogen. Hydrogen as an alternative fuel, though it is maybe at the initial stage. So, at least it's very proud to say that the first coastal vessel for Samskip is being built in Cochin shipyard here. And we are proud to be their partners, for the complete power system on that. So just to get a feel of that, this vessel, when it operates, the two vessels going to be built, we are doing the fuel cell integration also, hydrogen fuel cell. This will save around 25,000 tons of CO2 when it's operational, assuming the port power is also green. So these are the opportunities, and we see it already in action. So that is at least I can sum up, I can go on with this, but looking at the time, I think I want to keep it here.
Thank you, Mahesh. Maybe we have heard how a product can revolutionize. Maybe we should also hear from Anil on how operations and people make a difference to this, and what are the opportunities that you see in that space?
Thank you, sir. So I think to an extent we have been successful in the last few years in making a business out of it. And that's where I see an opportunity, because I believe the more the gap, the more is the opportunity that you have. We as ship managers, we are always having a problem that the owner sees us only as technical managers, means for the safety and security of the vessel. We are always trying to change that perspective of the owner, saying that there's a lot of things happening in shipping, especially on the decarbonization front. So a lot of effort has gone into convincing them on what needs to be done. So we have transformed ourselves as from a pure technical manager to a solutions provider, or let's say a thought partner for the ship owner is what we believe. We have revenue coming in for the services that we do for performance, now for the emissions trading system, for the fuel EU. For this specific regulations, we run end-to-end solutions. with the product that we have, which comes out of our ERP, which is SmartPal, which is the product of MariApps. So I think what the owner is looking for is a holistic solution for which he can find a solution on how to decarbonize his fleet. And for that, data management is another important aspect. The data needs to be covered holistically. So as you're saying, we're talking about scope 1, now we are into scope 3 in a very minimal amount of time. So for us now, we are into measuring the well-to-wake emissions of the entire fleet of our owners and helping them. So I think opportunity on one side is providing solutions to the owners, which I think is a great opportunity. The second opportunity is in training. Because I am from a seafaring background, we talk to a lot of chief engineers and masters. We understand the gap that they have in understanding performance and decarbonization. For them, at the end of the day, they need to make sure that the machinery and the navigation is working perfect and you have a perfect vessel, but that is not the case is what we are trying to tell them. Recently, I had a discussion with the chief engineer where he was saying that I'm doing everything perfect. I said, you're doing everything perfect, but your second mate is not reporting properly at 12 o'clock. And that is the reason on paper your vessel looks not so good as it is. So I think that's where, from our side, I think Bernard Schulte Ship Management is the first ship management company which is running a full-fledged vessel performance and decarbonization course. We've been doing that for the last 1.5 years. Our 100th batch is coming out. It's a mandatory course. That means we believe that the seafarers should have a good knowledge about the decarbonization aspect. And that is also a revenue, added revenue for us. So I'm talking about the opportunity part here. So that has increased the performance of our vessels. Because when we talk about technical efficiency, operational efficiency, that also contributes, although we know that that's a small percentage if we need to achieve the decarbonization goal. So I think that's one opportunity here. And the opportunity of collaboration again. We are in discussion with a lot of vendors and clients, so we get a lot of knowledge base on what's happening around. And that helps in getting into these meetings. I am very optimistic about it, that there's a lot of business opportunity. EU ETS started in 2024 Jan. We ran a EU ETS end-to-end service for our clients, means full data management, emissions management, and also the accounting, because we have a tie-up with brokers in EU. Before the end of Jan of 2024, all our customers were on board with this, because we started the efforts way back in 2023. So I think the agile approach also will create a lot of opportunity, and now with the transition also happening, now we have fuel EU. So answering to Sir's question on this one, I think for sustainability we need to be optimistic, and it's also an attitude that's set in. If you would ask me 5 years back, I would not have the same opinion. I am having this opinion because my company is in the EU, and they have this commitment, and that kind of attitude and that culture sets in slowly, steadily, and then you are also committed. So that's what I would say. Thanks.
Thank you, Anil. Maybe Ajay, from a regulator perspective, and perhaps standardization is also an aspect of this whole discussion.
Thank you for the question. I would say DNV is deeply committed towards sustainability. The first factor, I would say, sustainable supply chain. We need to ensure that every step from the production to the delivery should have minimum environmental impact. That is much prioritized. And then, as Anil mentioned, when the challenges comes, we understand about the opportunities. Similarly, I would say when we hear from the different stakeholders, because we work with all the stakeholders in the global chain, in the maritime sector. So we see that there are requirements for ESG reporting. There is requirement for alternative fuel modeling. There are opportunities for green financing, loans. So we work with all the stakeholders, and we see opportunities are there for all these particular topics. Second thing I would say, there are opportunities talking about in the workforce. Universities need to change their syllabus, need to comply with, we talk about a lot of alternative fuels, hydrogen, methanol, ammonia, but we need to understand, are our workforce ready for it? Can they handle the ship with the modern fuel? So there is opportunity for university to look up and revise their syllabus accordingly, because things are coming up very fast. Then there is opportunity for, I would say, infrastructure side. There are ports, I know they are doing it, a lot of things into it after having initiatives from Government of India, such as Harit Sagar. There are opportunities in the port sector as well, such as shore power. There has to be terminals with different alternative fuels. So there are opportunities in the port side as well. So that is my take on the opportunity.
Thank you. Do you think, Ajay, again to that point, do you think India is not on par with the rest in terms of the sustainability initiatives? Because DNV has a global view and do see and measure many of the performances around the world, I mean in sustainability. Do you see a specific or a very distinct lag in India's initiatives?
I would say if you see BRSR, there are top 1,000 companies need to report ESG. There are about 8 to 10 companies which is in the maritime sector which falls in the top 1,000 companies in India. They are doing it for sure because they have to do it. It's compulsive. What about the rest of the companies which are not in top 10? So if they don't want to do it, they're not doing it. But I would say that they should, because this is something which is for the global community and where I see the lag. I hope it will change for sure, and we are all motivated. So that is something which I would give an answer on.
I hope there are not many maritime companies in that. Moving on, Amit, you have highlighted some of the opportunities, but would you add on to that? Are there new things that you would like to mention?
Yeah, thank you. Yeah, so I believe we have lots of opportunities, and the most important one is opportunities in technology. Why this is important? Because technology, mostly when it comes to my core job, the vessel performance, we need to develop the technology to capture the correct and accurate data. That will give us a visibility to apply the solutions. Like I see many companies are coming up with a lot of solutions, whether if we don't have the data, then we are not able to quantify it. And actually that has helped us in Maersk, because we have seen that there are some solutions which were not viable. The payback time was too long. So it's not a smart idea to go with that solution. And that was only possible with having the IoT platforms. So I believe we have a lot of opportunities there. Also, the opportunity was there in innovation. What do I mean by innovation? Means like it might not be a pure innovation, but also to learn from peers. So just take an example of methanol vessels. We feel very proud to have the first methanol-enabled container vessel in September 23. But that was not something new to the industry. We had a methanol tanker before, which was actually being operated and carrying methanol as well. But we tried that technology in container industry just to build the supply, So that's one example. So when we had a methanol new building, then we started thinking, how can we apply that solution into our existing fleet? Because we have, the long life cycle left in the existing fleet as well. And then we are converting one of the 14K vessels, that class, the whole class of 11 vessels, being converted to methanol-enabled engine now. And just to go on that, we are also going to have ammonia-enabled vessels, and then latest announcement was there for 50 to 60 new vessels. Some of them will be powered by bio-LNG as well. So in Maersk, we are not fixated to one fuel type. We are looking for opportunity everywhere, and we are also not going to increase the capacity of the whole fleet. Eventually, the new vessel will come and the older one will be gone then. Yeah. Then the second thing I believe is we need to create urgency for decarbonization. Container industry is means considered as a fast-moving industry as compared to tanker and bulk carrier. And all we have very less time between the ports. What do we see now that if there is any operational issue on the vessel, then we react very fast because the business will be affected. I believe we need to create that kind of urgency in decarbonization journey as well. Like during the voyage, if we have a problem with one unit which is not firing, then we should strive our best, do our best to make that one operational, because that is going to lead the excess consumption and create more CO2, emit more CO2. So I think that can also be discussed in the challenge as well. But I think as an industry, I think we need to focus more on innovation of technology, innovation of other solutions, and also create urgency towards, decarbonization journey. Thank you.
I mean, lives are involved in this. Lives are at stake. So I hope we have that urgency more than what business takes.
Absolutely.
Shiv, thank you. Shiv, listening to you earlier, you did cover a bit on the opportunities, but are there more areas you would like to highlight? And what do you see in the distant future? You covered past and present. What do you see in the distant future?
Yeah, basically, first of all, I'll say we are seeing only opportunities. Not only as a country, as a shipyard here, all other shipyard, my colleagues also will agree. If you look at the short sea shipping, more than 60 vessels are under construction in India at various shipyards. And the short sea in European Union alone calls for about 3,000 vessels to be replaced over a period of time. About more than 50% of them are more than 25 years old. So it's an aging fleet which can never meet the new regulations. This is the case in all segments. So it's all about opportunity, what is coming, and this transition is really, in a way, and the right moment for the industry, the Indian shipyards to grab it, build the capacity, upskill the workforce, and definitely, I will say it's not just doing business. Of course, business is the case. It's also, as our Prime Minister said when we sent COVID vaccines to 120 countries, it was not just business, it was also helping the world to tide over that crisis. So here we have some sort of a crisis like that, or some sort of an ambition to make the world better. And India being a big country with 140 million people around, it's a huge strength for the world. And I am very sure that all the shipyards in India will look at this opportunity which is available and grab it. And Cochin shipyard is also no exception. And we are looking at multiple opportunities, expanding, upskilling, capacity building, identifying the right products which can also give more value to the society as well as to the bottom line of the company at the end. So it's a very, very exciting time. That's what I'll put it.
Great to hear that you're getting ready for the big one. And Basant, would you like to add to what you had said before?
Yeah, I am seconding Amit and Shiv sir on the opportunity side. There is a sea of opportunities flowing. But when you consider the opportunities in decarbonizing the maritime sector, on the short term, the opportunities would be mostly on the energy efficiency devices sector. There are a lot of technologies like the wind energy technologies, hull air lubrications, waste heat recoveries, hull fittings like propeller, bows cap, fins and other fittings, which gives you efficiencies in different ranges. So in the short term, the energy efficiency fittings and energy efficiency technologies would be having the opportunity. Of course, Maersk is, like companies like Maersk is going ahead with the renewable fuels also. That is, they are taking they are going one step ahead. According to me, considering a fleet of vessels globally, the demand for alternate fuels could be taken up in a slightly delayed way. That is on a long-term basis. On a long-term basis, definitely the zero-emission fuels and near-zero emission fuels will be having great opportunity. And that will be the most impactful technologies when going forward on the long term. So now on a ship owner's perspective, considering a fleet of vessels, it would be, it is matter of taking a strategic step-by-step process in decarbonizing their fleet. The process of adopting the necessary energy efficiency technologies for short-term compliance, phasing out their old vessels with new builds. And when we go for new builds, go for engines that can operate on zero carbon fuels and near zero carbon vessels. That means a dual fuel. It should have the flexibility also for operating on heavy fuel or oil also, because that is in a transition stage. Yeah, that is my take on this.
Thank you all. I would just add on one element, and alluding to what Shiv said a while ago. Reducing consumption is one way of helping sustainability. And in that respect, we come from a land where we say the best way to live your lives is to reduce, recycle, and reuse. And in that sense, ship is another area. Ship is another area where we can repurpose them from one use to another, because they do outlive their lives quite a lot, and recycling does help a lot some shipyards may not like what I say, but it does help a lot in terms of the energy spent in realizing something new. Or like when you take an oil tanker that's almost nearly 10 years old or 15 years old and repurpose that to make it an FPSO, and then you give it another new lease of life for another 20-30 years, and you take away the whole carbon emissions that are associated with building a new hull, which could be quite significant. So we look at reduce, recycle, and reuse as a slogan to achieve sustainability. I want to give more time to challenges and how we overcome those challenges. But if there are any very pressing questions to this segment, we can take it now, or we could wait for the end of it. Are there any questions from the back end? I'm still hoping our student friends will have some questions to raise. Questions? Hello. There's a question here.
Thank you. I just have one question on the shore side. It could be asked to Mr. Jayakumar or to Mr. Shivram. What about the opportunities for improving the situation on the shore side, reducing the emissions? Because you have worked in Keppel Shipyard, and Mr. Shivram, you are working on Cochin Shipyard, and also for DNV, because shipbuilding is not a part of the IMO conventions. So what efforts individually you have taken, because it comes as a part of the emissions on the GHG emissions come as a part of the CDC, right? So from that point of view, do you have any comment on the opportunities on the shipyards to reduce the emissions during the construction? Thank you.
Shiv, may I go first? Of course, it's for us in the shipyard industry, we are we are a heavy engineering industry, and therefore we are a culprit by far in terms of emissions. So we have to really rein in that, and we are very, very, very aware of it. So we take sustainability as a sequel to what we did with safety in the last time. And we are building it with such urgency, because it's also important that we do that, because we are already in the fossil related industry. I mean, we produce offshore oil and gas products, And therefore, we do struggle to find financing and other support in these days. So one way is to show that we are responsible in what we do. You know, we coined the word responsible energy. And that means we look end to end at all our processes and make sure that we do not, first of all, avoid waste, which is considered criminal already, and look at improvements that can help change our processes if required, that helps to save energy or minimize or reduce consumption of energy. So in fact, shipyard is, scope 1 and scope 2, and we also spread the message down to all the supply chain, because scope 3 is being looked at very seriously these days. So we also get our suppliers to look at that and the life cycle consumption with the clients. You know, we work with them to understand what could give that advantage in your total life cycle energy consumption, because these things add up these days. Shiv, maybe you have something to add?
Yeah, as being told, right now the customers are also very demanding. Now, for example, now we are building a few vessels for offshore wind industry. So it's a renewable industry where the end customer is expecting that entire supply chain and the way the activities are done are to the best of its to achieve that sustainable goal of harnessing the wind energy and then converting it into the renewable. So in this process, nowadays, previously we used to get the technical experts who come and do the audits. Then we had an era where we used to get a lot of HSC personnel also coming along with the technical team to come and audit. Nowadays, we have got another group of people who look at the ESG goals. So the customer who is coming, he is not just defining his ESG goals, he is also looking at the ESG goal of the shipyard where he is going to build. So the requirement from the market is demanding something more than what it used to be earlier. And that definitely will drive the shipyards to make their plant and machinery and their operations to achieve the necessary goals of the end customer per se. Without that itself, Cochin Shipyard and many other good shipyards in India as well as abroad, I have understood this. So for you to be relevant, for you to market, for you to serve that class of customers, you have to be ready. That's why by 2027 we are looking at neutrality in our overall energy demands. Right now all our rooftops are solar. That alone may not suffice our requirement. Now we are looking at installing some wind turbines in some other area. India is fortunate that we have got a national grid where we can upload our green power and download it from, so we are going to be net zero by 2027. And that is the way the world is going. Similar is the case with the banks. Nowadays the banks, the financiers, the investors, they also have a lot of huge allocation on investments which are green. So they also have this, looking at the entire chain, how green it is. It is not just the end product and its service what they are looking. They look at the entire supply chain, how it can be green. So really, I believe this is what is sustainability in a better way, if you explain.
I couldn't agree more. The banks are down our throat all the time, and looking at all our processes to make sure that the ship construction itself doesn't add to the misery. I think I'm very conscious of the time and challenges, as I always say, it's from the mistakes and difficulties that you learn a lot. So we want to give more time for challenges and the solutions that we believe would help us overcome those challenges. So let's start on the third segment, challenges. Who would like to go first? Amit, would you go first?
Yes. Yeah, so like opportunities, there are lots of challenges as well. So the first thing which comes to my mind is the cost is a huge challenge. More or less, in Maersk, we are very clear about technology, which path we would like to go, and we have the momentum as well. But there is a big gap between the fossil fuel and alternate fuel. And that's where I think the regulator is going to play a major role to bridge the gap, and how fast it's going to happen, we are still not so clear about it. So that's the first challenge. The second challenge, what Anil mentioned in opportunity, I consider that as a challenge. Like we have a three main important player in the shipping industry. The first one is owner, who owns the asset, and he would like to build the asset at a very reasonable price. Then we have an operator who operates the fleet, and he would like to have the top-notch reliability of the fleet at low cost. Then we have a technical manager who manages the crew. He would like to have at low cost and also manage the DRC to as low as possible. Now, all three of them playing three different roles, there is very less coordination, collaboration between them. I think there is a need of, need of a system which can actually bind them together. We all need to think about, decarbonization. It's not someone's individual goal. So that's the second challenge I see. And the third one I see is maybe we should bring some change in the whole ecosystem. I would like to go at a very initial stage, like in the education of the new guys who is more interested in coming to the shipping industry. We might have to come up with some curriculum which is focused more on the decarbonization or sustainability. This should have been a part of opportunity, but I think there we have. So these are the challenge what we see in Maersk, and that's.
Ajay, as a regulator, would you be able to add something to this?
From DNV perspective, I would say stakeholders in the maritime space are facing increasing demands for following the regulations. As we all know about EU's CBRS and then CBAM, which you have to show your performance, how much money you are putting into the sustainability improvements and all. So that is again, is becoming stricter and stricter, I would say. And then system integrators, ABB, Siemens, Kongsberg, Wärtsilä, I believe they are doing pretty good job. But then existing technology is already there. You have to put the new technologies integration. It's sometimes challenging in terms of they could be very expensive. It could be time consuming as well. So that is one of the challenge I see from the system integration side. And then, of course, the infrastructure. That is also, it's not that much that the industry requires at the moment. So these are the challenges. Apart from that, I would say sustainable supply chains as well, again in that terms, because we are talking about the whole perspective, but then when we see the individual steps, we have to see the sustainability in that terms as well. So that is also one of the challenges there, which we need to work out on it. So so that is from my side, I would say.
Anil, would you take it forward?
Yeah, I would say we faced the challenges the most because as ship managers, we have to listen to most of what the owners say. But I think on a macro level, if you look at it, these regulations, which are kind of localized, we don't have still an IMO midterm measure, which we have been thinking about for some time. So we're still waiting till 2027 where we think that there would be a carbon levy and all the countries will contribute to it. I come back to the same commitment principle. where I think, when we talk about sustainability, we've told about the environmental compliance aspect. So environment, obviously, you are, let's say, looting the environment, whatever say, and it's mostly anthropogenic where the man-made is there. But we're still missing the social and the governance aspect, where how much a company is contributing to the social causes as well as the governance, which also includes leadership, the commitment. So I think that's important, because if you browse through a sustainability report of a company, you'll really know how much they are committed. Or an annual report of a company, how much elaborate the section on sustainability is the commitment of that company. We read that a lot for all the companies that we go to, and that's where we pitch in our services. So we know that they've committed, they want to commit, we just need to show them how much it is. So that's a big challenge. And if you see, a lot of companies have committed into these technologies, but very less committed to bringing up their workforce to a level where they can also envisage these things. So I think the dearth of talent in the industry is also something that we are facing. We want people, and especially the future generation, to come into this. We have a lot of naval architects in the team who basically had envisioned where they want to just look into design, but now are the analytics team for us, who are running the numbers to show the owners that this is what you want to achieve. So I think these are the challenges, but I'm an optimist at the end of the day, and I think we will achieve it. It's just that it will take some time, but I think this could be the challenges, apart from what Anamit was saying. Thanks.
Mahesh.
Yeah, there are commonalities in the challenges. What we see is one area what I see is, which can affect the city we are living, the ports, the short sea shipping segment, which gives a good opportunity to, to address, decarbonize that. It affects the people living in the port and the city. So, but the challenge there is, if you look at the ecosystem there, the shipping companies are normally family-run businesses. Typically their assets are like 5 ships or maximum 3, some of them even 2-3 ships operating. And for them, the cost of initial investment, to transition to decarbonize for their existing vessels or go for a new vessel is quite huge. The technology cost is quite huge. It's posing a challenge. So then, how can this be, maybe I can suggest as some solution is, how can we overcome this challenge? So one is, okay, you're always there, you can always look towards the government policies and government financial support, but that may not be the right answer. There is also a movement of more funding into this segment. So one good example can be in Japan. Japan, there was 2023, they started this climate bonds. And climate bonds, it doesn't only address shipping, it addresses other segments also, like offshore wind, but it incentivizes shipyards to go into new technologies, into green technologies. So the shipyards inside. And then this is not limited only to Japan. They're inviting partners from outside. Shipyards from outside can also go into these bonds and then support the whole ecosystem. That is one area. The other area I see is also IMO and EU are developing, the new strategies and also measures, rules to avoid greenhouse gases emissions. There are some rules, where EU is ahead of maybe IMO. And it is also seen that, there are companies, EU-based companies may be able to handle. But some ship countries which are not part of EU, they have a challenge to address these needs. Sometimes are not clear and they end up paying penalty and all that. We have seen some cases. Here, I would say maybe there is uniform recommendations are required, to address these rules. Then there is a one direction what these shipping companies, can address that. And third, I would just bring about, this availability of this low carbon fuels. There is a wish list, but it's not really available because there is not the demand as such for this. And second is also the cost of these such fuels. So, and again, you cannot say this will be the future fuel for the world, marine fuel. What I believe is each country will drive its own need, you know, and that ecosystem will say, this is my marine fuel. It will not be that there is a global fuel or what you say, one fit solution for all the systems. So we need to accept the fact that it will be localized, you know, to specific regions and country. The availability of the resources will decide what fuel will be running in that country. So at least I just wanted to highlight these three areas. Yeah.
Thank you. Thank you, Mahesh. Shiv, would you like to elaborate on the challenges that we see as shipbuilders?
Yeah, basically, when we talk about these new technologies and alternative solutions, as all this economics do not work. So everybody is coming with a deficit, and they're in front of you to find a solution. So the shipbuilder starts negotiating with a customer who is already under pressure with respect to technology, with respect to commercials. So you do not have, if you are interested to participate in such programs, then you should be ready to address those challenges as well. So most of the projects where we work, we are working with very minimum margins, because we understand that at the end of the day, the customer is also going through a very difficult phase. So this is one challenge which we hope over a period of time, with the technology maturing and volumes increasing, there could be some better. And same thing happens to our suppliers like ABB also. We start squeezing them, so they also have to collaborate. So this collaboration is very important. Finally, at the end of the day, from the customer to the shipyard to the regulators to the OEMs. So this only makes it happen. And coming to other challenges, is as you said, always every project is unique. So this standardization doesn't work. So we end up with creating a solution custom-made, tailor-made for that particular project. For example, we are doing this feeder container vessel for Samskip along with ABB. So this product, this feeder container vessel, is a hydrogen fuel cell powered vessel, custom built to operate between Oslo to Rotterdam. That's it. Both port terminals have agreed to provide green hydrogen. That's the motivation for them to order a vessel like this with the capacity optimized for this voyage. Like this, next repeat vessel which they are talking to us is for another set of ports with a different configuration. So there is nothing like you can design a vessel and keep building it in numbers. So this is one big challenge which takes a lot of capacity of the shipyard. And we spend a lot of time. And if you really look whether we can recover all these overheads of our investments, of our engineering costs, impossible. So this is one big challenge we are feeling, which is going ahead. As we look at this opportunity, this challenge is there. Next is the skill development and the knowledge. If you look at it, even the regulators, even the classification societies, they are also learning. They do not have enough and more experience. They do not have any validated information. So they also are very cautious in their approach and time consuming, lot of change management during the process, and we envisage something, but at the end of the project, we end up with something different. So there is nothing like a specification which is written and you build that vessel at the end of the day. Even though we call a shipbuilding contract with fixed price, fixed time, we have to manage this change management. This is a big challenge for us, which is being faced day in and day out. Then comes our own skill sets of the people. We are dealing with different systems, different equipments, different fuels, and that creates a lot of stress on the people who are handling, and that is something which again puts a lot of pressure on us. And again, here the collaboration comes, where the OEMs and other experts are very much essential to work together along with the shipyard to make it. Because at the end of the day, shipyard is the one which is, they got a baby. As soon as they sign the contract, they got a baby in their lap. We can't drop it. Others can walk away, probably, if it did not go well. But as a yard, you are married to it, and that your infrastructure is locked up. You have invested in that product to the extent, and that money can be easily encashed through the bank guarantees in case that project did not go well by the end customer. So we are taking a lot of risks, and these risks are huge. So it is only the collaboration that can work, and good companies really believe in it, and that only makes such projects successful also. Then another is the infrastructure also. We also sometimes underestimate when we get into a project whether we can do it. Even simple things like when we took this KMRL, it's a small battery hybrid boat. We never thought we need to create the fast charging infrastructure in our yard itself. We thought we can do the slow charging with the normal shore power, and we can do the trials, and we can then deliver the vessel, and they are anyway going to install the fast charging facility in their terminals. So we can go there and we can do the fast charging. And that's how we envisaged, and we never thought of putting money for creating that infrastructure in that project or otherwise, and we never did it. But at the end of the day, when we were trying to do this, we found the difficulties which we were facing. So it took long time for us to, go to their facility and do that tests and then make it happen. So the infrastructure is also something which, when with the technology changing, with the fuels, one vessel maybe with methanol, one vessel maybe with hydrogen fuel cell like this, it's quite demanding, and that is another challenge which we are seeing. So each project is unique, and that comes with different challenges.
Ask a shipbuilder about troubles and he can never stop. Same with me. We have a tagline. Our shipyard is called Can Do. That's the tagline of the yard. That means everything can do. Okay, there's no cannot do. So because that's the only way to keep up with the market, and we pose ourselves as a solution provider rather than a shipyard. So you come with any problems, I am a solution provider and I can do. That's it. So that's life for a shipbuilder. Basant, we have covered quite a lot, but I'm sure you have other points that you might feel like raising. What do you think?
Yeah, in short term, I believe the challenges would be on the regulatory side and on the training side. A global regulation is not in place, but if EU can do, IMO also can do. So that will be in place. That's a confidence. And on the training side, when you have a lot of technologies coming in, it's a big challenge to have this training schedule introduced. One technology that could be adopted could be to digitalize the training scheme. Prepare modules in an audio-visual way and put it in the HR library. It can be reused and reused as long as you want, and add sufficient modules whenever the revision comes. So that will make the training more consistent. In the long term, the challenges would be on the infrastructure. Infrastructure means that is on the scalability of the product, scalability of the fuels, the actual infrastructure for transportations, storage and bunkering of fuels. Then, as part of the infrastructure, it comes a market demand for the fuel also. So this, as discussed, as pointed out by the panel, the collaboration would be the key. Collaboration between different stakeholders. More and more collaborations will push the market, make a demand, and it will create its own mechanism. So until that, we need to initiate the first movers coalition systems. A lot of first movers has to come up to create that market and push the market forward. So I have two more points to add on addressing the challenges. One of the challenges is unavailability of fuels in the long term. So even if you even if you adopt the green fuels, the energy efficiency technologies also have an important role to play. So on a long term, the green fuels will be costing more, and it is our responsibility to save the fuel for the others to use. So even if you are zero polluting, it is your responsibility to save the fuel by using certain energy efficiency mechanisms and keep the efficiency of your ships to the maximum. One more point that could accelerate our journey towards decarbonization is, and it will reduce the challenges, is research and development on other renewable sources like the nuclear energies, geothermal energies, the white hydrogens. Such research and developments has to happen, and we need to push them to reality. So that's my addition towards.
Thank you. There's a lot on our plate, obviously, and it may sound daunting, but like they say, there's always an opportunity in every crisis. Humanity has never given up. We have faced COVID, we have faced wars, we have faced many challenging situations in the past, and we have overcome all of them, and we have become stronger and wiser for it. So I'm sure even with all these challenges, we heard a lot, and as we said, there are operational challenges, there are manning challenges, there is technology challenges, and there are people challenges. So it's a long list. Money challenges, commercial challenges, operability and profitability challenges. But at the end of it all, we have come through many of these cycles, and the market will also readjust to it, because the need for vessels and the need for energy will never go away. So the world as a whole will readjust to the realities of the world. And one good thing is, 5 years ago or 8 years ago, we didn't clearly understand sustainability and what it meant and how are we going to overcome. There was a lot of concepts, but we really need not get the root of it. But today, we have a lot more clarity. There's a lot more measure. We know exactly where we stand in the line and how far we are yet to go. And there are many people attempting to get ahead of each other and provide new solutions to it. So it's not all gloom and doom, and certainly there are a lot of opportunities that will open up from the challenges itself. If there are any last remarks to add, please feel free to do that before I open the question answer floor. Are we good with that? Okay. If there are any final questions, we have another 5 minutes or so, maybe 10 minutes at most. Please.
Hello, sir. This is Ankit Srivastava from Cambridge Propellers. So my question is to Mr. Ajay. As Mr. Amit has mentioned, that the three stakeholders, the ship owners, the ship management companies, and the shipyards, So they will have their own sustainability objectives because everybody would like to be cost effective. But do you think that class will have a more significant role to play in including these sustainability initiatives within the class rules? Why I'm saying so, because that like for any equipment supplier, so class gives the works approval before they start manufacturing any equipment under any particular class. So such sustainability initiatives could be included as a part of works approval process itself, so that it becomes mandatory to a certain extent, and it becomes much easier to, or it becomes much mandatory for all the stakeholders to follow these initiatives. Yeah.
Yeah. Ajay?
Thank you. Thank you, Mr. Srivastava, for the question. Certainly, yes, I would say. We are working with stakeholders in India and globally, of course, and we invest 5% of our revenue in the research and development for all the sustainability-related goals. We will definitely revise our guidelines, standards, based on the recent regulations coming up from the IMO and the EU. So, yes, of course, I agree with you, and you will see the changes as well.
Right. Okay, thanks.
Good afternoon, I'm Captain Shekhar Deshpande, Captain Naval Design from the Directorate of Naval Design, New Delhi. I thought this entire thing will pass off without the mention of the nuclear part of it. Just towards the end, Basan just brought it in picture. I want to know, first of all, there was recently an article, I believe from Lloyd's Register regarding usage of nuclear fuel in the shipping industry. So, is it practicable as of now, how we see it, or the question can be to Basant only, that is there any research which is going on which genuinely looks forward to usage of nuclear power, which will be probably the cleanest form of energy for shipping, in the shipping industry?
Yeah. The biggest challenge in adopting nuclear power to shipping industry, that would be two things. One is the regulations, and another is the public perspective. First I address the regulations. The regulations will be very complex nuclear power had been traditionally used only for naval ships and only for a few commercial ships, but not widely used. The regulations are right now taken care of by the Atomic Agency, not by the class and classification societies. Of course, there are rules for carrying nuclear products, but not for using as a propulsion method. So that sort of regulations has to come in place before we use this nuclear technology into shipping. So the feasible option would be to prepare small modular reactors, SMRs, and that will have two advantages. One is it will give it will de-risk the risk of big nuclear plants, and another one is that when it is adopted to the industry, when multiple projects, similar such projects are introduced to the industry, it will create a market of its own and push the industry forward. So to address the regulations, probably a good way is to de-link the regulatory part and the ship operation part. So the regulatory part can be taken care of by the Atomic Agency, and the ship operation part can be taken care of by the ship operation, so that the tradition follows and the regulation can be taken care of by the Atomic Agency. And of course, public awareness has to be improved as well, because there had been a lot of improvements in the nuclear technology. The fuel being used, the technologies being used to protect the fuel, that there had been much improvements. So those education has to go into the public, And that process will take time, and I believe the government will take necessary policies to introduce this and to educate the public.
Amit, I believe Maersk has a lot of experience in this, so would you share some?
Yeah, so there was a article recently, I think maybe a day or 2 days back, that Maersk has agreed to study this, because means we were not sure whether we would like to adopt this technology or not. But at the same time, we don't want to leave any opportunities. So yes, we are partnering with Lloyds, I believe, and then we'll study it and see how it goes. But it's really unsure at this moment. But I think there is a good opportunity in that field as well. Yes.
One last question. I believe the President has a question for us.
Okay. Thank you. I mean, sustainability is very challenging, as you all mentioned. And many countries and many organizations are setting their standard. For example, India said 2070, IMO said 2050. And many of the shipping companies, the major shipping companies in Japan have set the target for to achieve zero carbon by 2040. The Maersk is also set the target in 2040. But 2040 is just 16 years away. And to achieve net zero on the ships may be easy. But what do you think about the supply chain? So for example, the entire supply chain has to be net zero by 2040 to achieve the goal, especially the fuel, when you are considering from well to wake. So how do you plan to attain that net zero by 2040? Any thoughts on that?
Yeah. So the first thing what we have done, the major change in our business that, and it's done 2 or 3 years back, that we are no longer a shipping company only. We love to be called logistic company, because we have integrated all our business, inland transportation, and then shipping, ocean business, plus warehousing. And there is a vision towards this. Of course, it's also going to help decarbonization. That we would like to, collaborate more with the customers, their needs. So at the moment, only 3% of our top 200 customers, they opt for eco-delivery. Eco-delivery is a service where the cargo is, transported by green fuel. We would like to, increase this going forward. And again, I mentioned that the main challenge is the cost right now. There is no dearth of technology. The second thing what we are doing, that we also have a target of reducing 50% of our emission by 2030. For that, we are already doing a lot of changes in our ocean business, taking delivery. We are not adding any tonnage to our fleet. We are just replacing them with the new technology. So that's the second thing. Third, the big question is, how do you motivate the customers? So we have also aligned our target with the science-based target, which almost 200 of our customers, they follow that. So when we both have a same target, then I think the journey will become smoother as well. And in the terminal business, most of our terminals, they are changing very fast. We are having a renewable source of power that kind of change is being done. We are also doing a lot of changes in trucking business. So we have many trucks in Europe which are powered by batteries now. So there is a challenge as well. So right now most of the trucks, they have a heavy battery, and it takes long time to charge. So we would like to partner with someone who can develop a fast charging technology for that. So these are some of the major initiatives which we have taken recently. And I'm quite sure means we are very ambitious, and we would be becoming net zero by 2040. That's the target. Yeah.
Okay. Thank you.
Yes, Shiv. We may have to limit it to another 1 or 2 minutes. Please.
Just to add, definitely this challenge is what is forcing for this market-based measures from IMO. So when you look at the overall transition up to 2050, I think the estimated amount required is almost $2 trillion plus for this transition to happen. And out of which about 85% is for the shore-based infrastructure. So when you look at the new technology, when you look at the new ships and other efficiency improvement measure, they are all very minor when you compare about the overall investment that is required for this transition. So this is what forced European Union as well as the IMO now, and this MEPC 82 will be deliberating on how to bring this market-based measures so that this carbon tax can be collected and it can be divided and given to the various stakeholders, and that can develop the shore infrastructure innovations and other facilities. In addition to this, every country has got its own policies. For example, when we talk about India, we have got the solar mission, which we are leading the world, and we are also talking about the hydrogen mission. When we talk about hydrogen mission, by 2030, the 25% of the green hydrogen will be built in India. So that is the amount of investments that the government is trying to push, and all the major private companies, you name it, let it be Adani Green or let it be L&T or let it be Tata, all of them are investing in huge. And there is a PLA scheme which is working on it for making these electrolyzers, and the goal of Reliance is less than $2, they will make 1 kg of hydrogen available in India. They have published it. This is the amount of commitment the companies are showing on regional basis. It's happening all around the world. So definitely the infrastructure will get developed. So this chicken egg situation will continue for some more time, but the clarity is slowly emerging. And I think with this IMO, if it's able to bring this incentivizing the greener ships and disincentivizing the polluting ships, if it happens and if they are able to bring this tax and distribute it equitably, definitely this may be a reality.
Yes, Anil.
Just like to add one point, what we have understood in the last 2 years is that we had the CII regulation. But when it came to financial implication only, we saw a commitment from the teams. So CII is not penalizing. You can have a E or a D rated vessel for 1 year and 3 years respectively. So there's still not that commitment. But when it comes to financial responsibility and liability where you have to pay money, that's where you get commitment. So I'm just saying that, I echo the words of what Sir said, that, we must have something to actually encourage them to commit to decarbonization. So I think that's...
Of course, money talks. I thought Mr. Rahim's question had a supply chain angle to it. The shipyards are getting up to speed, but are the supply chains doing? I wish Mahesh had the time to answer as a representative of supply chain. Mahesh, if you can make it really quick.
Quick ones. See, like you mentioned, for us to meet the targets, we need to see our whole value chain. So it is all scope 1, scope 2, scope 3 emissions. Right now, already we are on scope 1 and 2 reached around 60% target. So scope 3 is something we're working, because it is not, it's indirect emissions. So it's not only our supply chain, but also our customers also. It affects how they're using our products also, it matters. But there is at least a focused approach, which is making the whole business process more complex. But at the same time, we are going towards that. Our ambition is not 2040, but 2050.
Thank
you.
So,
yeah, but really, scope 3 has put a lot of focus on what happens before you and what happens after you. And we are all answerable for that as well.
it's unfair, I would say, as a shipbuilder, but that's the world. So thank you all. I think we have overrun a little bit in time, and please excuse us for that. But if I could hand over the mic to the organizers.
Thank you to our panelists for such a detailed discussion with so many initiatives, ideas. The green horizons don't seem that far now. With that being done, I would now like to invite our panel chair, Mr. Jay Kumar S., to kindly present mementos to our esteemed panelists as a token of our appreciation. Ajay Kumar Singh, Head of Section, Maritime Advisory, DNV. Anil Jacob, Head of Fleet Performance Center, Bernard Schulte Ship Management. Mahesh Krishnappa, Senior Vice President, Head of Marine and Port, ABB, Singapore. Amit Kumar, Team Manager, Vessel Performance Team, Maersk Fleet Management and Technology, India. Shivaram Swami, General Manager, Business Development, Cochin Shipyard Limited. Basant Konard, Senior Director, R&D, Aries Energy. Following that, I would also like to invite Mr. Sachin Kulkarni, Head of Marine Business Sales for South Asia at Wärtsilä, to present a memento to Mr. Jay Kumar S. as a token of our gratitude. To commemorate this special session, I invite everyone to come ahead for a group photo. Thank you. Sir, you all may be kindly seated below. Special announcement. Don't miss out opportunity for capturing your moment at our event. Scan the QR code on the banner outside Oman Hall towards your left. Register with your name and mobile number and take a selfie. Our facial recognition technology will send your event photo to your WhatsApp. A Samsung M33 phone has gone missing. If you have any information or have found the phone, please reach out to the stage committee. I'm sure you all enjoyed the panel discussion. It's now time for lunch. You may please proceed to the lunch area in M Part 2. Enjoy your meal and take this opportunity to connect and network with fellow marine enthusiasts. Everyone should know that after the lunch, we will reconvene at 2 p.m. for our second panel discussion on the topic, Impact of Technologies in Maritime Domain through Innovation, Disruption and Indigenization, where we will explore how emerging technologies and innovative practices are transforming the marine industry, focusing on both global changes and local advancement. We look forward to your participation in what promises to be another engaging and informative discussion. Till then, bon appetit. Thank you.
Express our deepest gratitude to all the sponsors of this event, beginning with platinum sponsors, DRDO and Cochin Shipyard Limited, our gold sponsors, ABB, and the silver sponsors, Indian Register of Shipping and Catmatic. We also thank Aries Energy, registration area sponsor, and Class NK, the delegate kit sponsor. Great Waters, delegate badge sponsor. We also thank our associate sponsors, GRSE, Goa Shipyard Limited, L&T Engineering, Zentech Incorporated USA, Warsila, Napa, Naval Group, Alboa D. Damon, ShipTech Icon, and Mazagon Dock and Shipbuilders Limited. Our event partner is Biz Events and media partner is Maritime Standard.
Consistently working on indigenization of defense technologies since its inception in 1958, the motto of DRDO has been Balasya Moolam Vigyana. The source of strength is science. DRDO has been at the forefront of Atmanirbharta in defense, having technical capabilities across the domains of land, air, and sea. Its strong network of 41 laboratories, associated work centers, 5 unique young scientist laboratories are spread across the country. DRDO has developed wide range of strategic and tactical weapon systems, platforms, equipment, technologies, sensors, and has also established state-of-the-art test facilities and infrastructure. The production value of DRDO developed systems inducted or approved for induction stands over rupees 3 lakh crore. Taking forward the thought of Atmanirbhar Bharat, DRDO has been spearheading the indigenization of Indian defense technologies, driving India on the path to pride. DRDO works in 7 different technological clusters, namely naval systems and materials. The cluster provides cutting-edge naval and material solutions for the armed forces. It has developed state-of-the-art underwater sensors and surveillance system, underwater weapons and associated systems, air-independent propulsion systems, protection technologies for marine platforms. High-strength material is also a speciality of this cluster. INS Vikrant is built with the high-strength steel developed by this cluster. Aeronautical systems. This cluster is engaged in the development of state-of-the-art combat aircrafts, unmanned aerial vehicles, aero gas turbine engine technology, airborne surveillance systems, parachutes, and lighter-than-air systems. Armament and combat engineering systems focuses on research and development of armaments, explosives, land-based combat vehicles, and engineering equipments, including ATACMS, world's longest range artillery gun system, missiles and strategic systems. This cluster is responsible for the design and development of state-of-the-art missiles and strategic systems for the deterrence of the country. Electronics and communication systems, state-of-the-art technologies in the fields of EW systems, radars, sensors and directed energy weapon systems and communication systems used in various flagship programs and platforms of DRDO. Life Sciences, equipping the service with the best cutting-edge weapon systems and platforms do not really achieve their intended purpose until the integral human component of the war machine is also optimized in terms of psychological, physiological and nutritional well-being, with life support systems and protection from all conceivable operational hazards. Microelectronic devices, computational systems and cyber systems. The microelectronic devices subcluster focuses on thrust areas and technologies relating to microwave tubes, solid-state electronics, including microelectronic device design and manufacturing. The computational systems subcluster focuses on systems and technologies relating to artificial intelligence, command and control, information and communication security, and many more. To develop defense R&D ecosystem and boost indigenous manufacturing, DRDO is supporting the industry through policy of transfer of technology at minimal or zero cost. Now, industry are working with DRDO as DCPP, PA, DP for development of many critical technologies. As of now, 1550 TOTs have been handed over to industries by DRDO. DRDO has instituted multiple mechanisms and structures for result-oriented collaboration with academia, industry and think tanks to design and develop next-generation systems. As an ongoing process of creating a DRDO and academia ecosphere, DRDO has established 15 centers of excellence in collaboration with various academia institutes all over the country to develop critical technologies. In addition, DRDO also funds academic research in defense science and technology through mechanisms, schemes like extramural research, research boards, and contract for acquisition of research services. DRDO also funds research under its various grant-in-aid scheme to undertake research in the fields of aeronautics, armaments, naval, and life sciences to strengthen funded research. Technology Development Fund TDF scheme is in place to encourage participation of industries, especially MSMEs, startups, to develop new technologies and products, upgrade existing products, systems, and R&D for indigenization of imported components and systems. Till date, 68 projects have been sanctioned under TDF scheme with the commitment of 283 crore. Dare to Dream Innovation Contest to promote innovators and startups are being conducted. 3 versions of contests have been concluded. Potential ideas are funded through TDF for converting to products. DRDO, as the premier technology organization of our country, is working in the pursuit of achieving indigenous development and production of strategic and defense systems, making the nation self-reliant in advanced defense technologies. Raksha Anusandhan se आत्मनिर्भर भारत की ओर अग्रसर। जय हिंद। Located on the southwestern coast of India, Kerala is a land with a lush maritime history that dates back to several centuries. Cochin, the thriving port city in Kerala, is the commercial capital of the state and an epitome of Kerala's cultural richness. In 1972, India's maritime aspirations found a new anchor as India's port city. Cochin became the birthplace of Cochin Shipyard Limited. Nestled in Cochin's heart, CSL's sprawling 176-acre facility boasts of world-class shipbuilding and ship repair infrastructure, from state-of-the-art 3D modeling softwares, large dry docks, long waterfront with jetties, machinery and equipment, everything essential for an HSE-compliant one-stop solution for the industry. CSL's portfolio of an extremely wide variety of vessels is a testament to its versatile, adaptive and flexible culture and capabilities. It offers the full spectrum of shipbuilding, ship repair and vessel conversion related solutions. CSL added yet another feature to its cap when it built INS Vikrant, India's first indigenous aircraft carrier, which was commissioned into the Indian Navy in 2022.
यदि लक्ष्य दुरंत है, यात्राएं जिगंध है, समंदर और चुनौतियां अनंत है, भारत का उत्तर है विक्रांत।
CSL's golden flag flutters proudly, celebrating 50 years of maritime excellence. CSL's renewed focus seeks sustainable horizons aided by technological innovations for a cleaner, brighter future. The yacht's clientele footprint spreads across the globe, having delivered numerous vessels to clients in the US, Europe, Middle East, and other countries in the region. CSL's geographical expansion initiatives have resulted in the setting up of ship repair business units in Mumbai, Kolkata, and Port Blair, thereby making CSL the only Indian yard offering direct professional services with dedicated infrastructure on both the east and west coast of India. Wholly owned subsidiaries companies, Udupi Cochin Shipyard Limited on the west coast and Hooghly Cochin Shipyard Limited on the east, have augmented and enhanced the group's capability in shipbuilding, including on the niche and new technology fronts to a great extent. The new large dry dock and the new international ship repair facility established in Cochin as part of the company's long-term strategy roadmap will significantly augment the shipbuilding and repair infrastructure in India. CSL has incorporated the Strategic and Advanced Solutions Division exclusively to handle and maintain its leadership position on the front of new and emerging technologies. CSL takes pride in being one of the global leading yachts on the sustainable solutions front, having constructed the world's first zero-emission fully autonomous ferries for Europe, as well as being the vessel builder for world's largest hybrid electric urban water mobility service, the Kochi Water Metro, operating in Kerala, in India. The company lays significant emphasis on skill development and runs Vigyana Sagar, its dedicated and self-contained training facility in Kochi. CSL is India's first shipyard to have obtained the CII Greenco Silver rating for its efforts at energy conservation and environment-friendly initiatives. CSL is also the first Indian shipyard with an integrated management system covering safety, health, and environment certified by DNV. With the ethos of Make in India, Make for the World, CSL has recalibrated its sails and set sights on continuing at the forefront of a brighter, greener future.
We are in the middle of transformation. Electrification, digitalization, connectivity, cloud computing, machine learning, and all converging. Sensors are getting smaller, big data is getting bigger. Augmented reality and virtual reality are providing previously unattainable field of use. And all this is providing unprecedented opportunity to create value and increase the sustainability of the shipping. maritime industry represents approximately 2.5% of the world's greenhouse gas emissions. And that number is set to grow with an increase of the global trade. ABB is committed to reverse the trend to take that number down. We at ABB believe that the next generation of vessels will be electric, digital, and connected. Electric because they are more efficient and sustainable, and digital and connected because that will take the productivity and safety of the vessels to another level.
Personally, I think that the Azipod propulsion system is one of the greatest innovations in maritime history. All big ships need something that moves them forward. Azipod propulsion system combines propeller driving the ship and electric motor driving the propeller and the rudder which is steering the ship. For the Azipod unit designs, the sustainability idea and thinking starts already from the design table, that we consider the materials we use, how much we use it, what kind of materials we are using. There are about 400 Azipod units in operation at the moment. Even though the Azipod propulsion system is mostly known from cruise ships and ice-going vessels, it has been installed into more than 20 different ship types. In my opinion, of course, one day I would like to see that Azipod propulsion system is equipped in all the vessels around the globe.
The electric ships are currently representing about 10% of the world's fleet. And to make the maritime industry more sustainable, that number needs to grow. We at ABB are fully committed to reaching that goal. In fact, we just delivered 2 ships sailing between Sweden and Denmark on full electric power, and we were able to reduce the greenhouse gas emissions.
I think it's important as a company to be modern. And to be modern is that you think about the whole economy. And economy is also how much you pollute. Traditional ferries have been fueled by bunker oil. But since 2015, in this area of the world, we have a low sulfur emission called 0.1. This vessel we're on today is from 1992. And the other one that we converted is from 1991. But they are state-of-the-art vessels when it comes to the technology. And that's what we're very proud of at 4C, is these vessels are designed in the end of the 80s, but still have the newest technology on board. We have the battery power or equivalent of 60 Tesla cars. We charge on the Swedish side roughly 9 minutes and 5.5 minutes on the Danish side. We have less noise, we have less vibration, but we also have another important thing, is that the people that are working in the company are very proud that we are first mover in the world with this new technology.
ABB has already started to put batteries on vessels, smaller ferries going from A to B, and we have also taken bigger vessels, like the 4C vessels going between Sweden and Denmark, where they run purely on batteries. Yeah. I think we will see a transition in both fuel and technology, so we're taking one step at a time. For larger vessels, we see a good potential to have a hybrid power plant. We can cut down on emissions, or we will probably also see these larger vessels powered by renewable power. It's a good potential to cut down on local emissions that affect people where they're living and local communities. And this technology with electric vessels and hybrid vessels is a technology that are available now and can address these issues now.
I think in general sustainability is important for any industry, and of course ABB wants to be a big part of that with its electric, digital, connected vision.
I think the industry is going through a big change right now. Being first mover, we can actually show other ship operators that there are possibilities to use the same tonnage as you have today and not going for new builds.
The member states of the IMO, International Maritime Organization, pledged to reduce the greenhouse gases by 50% by 2050. And we at ABB are committed to that goal and to provide innovations and technology to make that possible.
We would like to express our deepest gratitude to all the sponsors of this event, beginning with platinum sponsors, DRDO and Cochin Shipyard Limited, our gold sponsors, ABB, and the silver sponsors, Indian Register of Shipping and Catmatic. We also thank Ares Energy, registration area sponsor, and Class NK, the delegate kit sponsor. Great Waters, delegate badge sponsor. We also thank our associate sponsors, GRSE, Goa Shipyard Limited, L&T Engineering, Zentech Incorporated USA, Wärtsilä, Napa, Naval Group, Alboa D. Damon, Shiptech Icon, and Mazagon Dock and Shipbuilders Limited. Our event partner is Biz Events, and media partner is Maritime Standard.
Consistently working on indigenization of defense technologies since its inception in 1958. The motto of DRDO has been Balasya Moolam Vigyana. The source of strength is science. DRDO has been at the forefront of Atmanirbharta in defense, having technical capabilities across the domains of land, air, and sea. Its strong network of 41 laboratories, associated work centers, 5 unique young scientist laboratories are spread across the country. DRDO has developed a wide range of strategic and tactical weapon systems, platforms, equipment, technologies, sensors, and has also established state-of-the-art test facilities and infrastructure. The production value of DRDO developed systems inducted or approved for induction stands over rupees 3 lakh crore. Taking forward the thought of Atmanirbhar Bharat, DRDO has been spearheading the indigenization of Indian defense technologies, driving India on the path to pride. DRDO works in 7 different technological clusters, namely naval systems and materials. The cluster provides cutting-edge naval and material solutions for the armed forces. It has developed state-of-the-art underwater sensors and surveillance system, underwater weapons and associated systems, air-independent propulsion systems, protection technologies for marine platforms. High-strength material is also a speciality of this cluster. INS Vikrant is built with the high-strength steel developed by this cluster. Aeronautical systems. This cluster is engaged in the development of state-of-the-art combat aircrafts, unmanned aerial vehicles, aero gas turbine engine technology, airborne surveillance systems, parachutes, and lighter-than-air systems. Armament and combat engineering systems focuses on research and development of armaments, explosives, land-based combat vehicles, and engineering equipments, including ATACMS, world's longest range artillery gun system, missiles and strategic systems. This cluster is responsible for the design and development of state-of-the-art missiles and strategic systems for the deterrence of the country. Electronics and communication systems, state-of-the-art technologies in the fields of EW systems, radars, sensors, and directed energy weapon systems and communication systems used in various flagship programs and platforms of DRDO. Life sciences, equipping the service with the best. Cutting-edge weapon systems and platforms do not really achieve their intended purpose until the integral human component of the war machine is also optimized in terms of psychological, physiological, and nutritional well-being, with life support systems and protection from all conceivable operational hazards. Microelectronic devices, computational systems, and cyber systems. The microelectronic devices subcluster focuses on thrust areas and technologies relating to microwave tubes, solid-state electronics, including microelectronic device design and manufacturing. The computational systems subcluster focuses on systems and technologies relating to artificial intelligence, command and control, information and communication security, and many more. To develop defense R&D ecosystem and boost indigenous manufacturing, DRDO is supporting the industry through policy of transfer of technology at minimal or zero cost. Now, industry are working with DRDO as DCPP, PA, DP for development of many critical technologies. As of now, 1550 TOTs have been handed over to industries by DRDO. DRDO has instituted multiple mechanisms and structures for result-oriented collaboration with academia, industry, and think tanks to design and develop next-generation systems. As an ongoing process of creating a DRDO and academia ecosphere, DRDO has established 15 centers of excellence in collaboration with various academia institutes all over the country to develop critical technologies. In addition, DRDO also funds academic research in defense science and technology through mechanisms, schemes like extramural research, research boards, and contract for acquisition of research services. DRDO also funds research under its various grant and aid scheme to undertake research in the fields of aeronautics, armaments, naval, and life sciences to strengthen funded research. Technology Development Fund TDF scheme is in place to encourage participation of industries, especially MSMEs, startups, to develop new technologies and products, upgrade existing products, systems, and R&D for indigenization of imported components and systems. Till date, 68 projects have been sanctioned under TDF scheme with the commitment of 283 crore. Dare to Dream Innovation Contest to promote innovators and startups are being conducted. 3 versions of contests have been concluded. Potential ideas are funded through TDF for converting to products. DRDO, as the premier technology organization of our country, is working in the pursuit of achieving indigenous development and production of strategic and defense systems, making the nation self-reliant in advanced defense technologies. Raksha Anusandhan se Atmanirbhar Bharat ki or aggrasar. Jai Hind. Located on the southwestern coast of India, Kerala is a land with a lush maritime history that dates back to several centuries. Cochin, the thriving port city in Kerala, is the commercial capital of the state and an epitome of Kerala's cultural richness. In 1972, India's maritime aspirations found a new anchor as India's port city. Cochin became the birthplace of Cochin Shipyard Limited. Nestled in Cochin's heart, CSL's sprawling 176-acre facility boasts of world-class shipbuilding and ship repair infrastructure, from state-of-the-art 3D modeling softwares, large dry docks, long waterfront with jetties, machinery and equipment, everything essential for a HSE-compliant one-stop solution for the industry. CSL's portfolio of an extremely wide variety of vessels is a testament to its versatile, adaptive and flexible culture and capabilities. It offers the full spectrum of shipbuilding, ship repair and vessel conversion related solutions. CSL added yet another feature to its cap when it built INS Vikrant, India's first indigenous aircraft carrier, which was commissioned into the Indian Navy in 2022.
यदि लक्ष्य दुरंत है, यात्राएं दिगंत है, समंदर और चुनौतियां अनंत है, भारत का उत्तर है विक्रांत.
CSL's golden flag flutters proudly, celebrating 50 years of maritime excellence. CSL's renewed focus seeks sustainable horizons aided by technological innovations for a cleaner, brighter future. The yacht's clientele footprint spreads across the globe, having delivered numerous vessels to clients in the US, Europe, Middle East, and other countries in the region. CSL's geographical expansion initiatives have resulted in the setting up of ship repair business units in Mumbai, Kolkata, and Port Blair, thereby making CSL the only Indian yard offering direct professional services with dedicated infrastructure on both the east and west coast of India. Wholly owned subsidiaries companies, Udupi Cochin Shipyard Limited on the west coast and Hooghly Cochin Shipyard Limited on the east, have augmented and enhanced the group's capability in shipbuilding, including on the niche and new technology fronts to a great extent. The new large dry dock and the new international ship repair facility established in Cochin as part of the company's long-term strategy roadmap will significantly augment the shipbuilding and repair infrastructure in India. CSL has incorporated the Strategic and Advanced Solutions Division exclusively to handle and maintain its leadership position on the front of new and emerging technologies. CSL takes pride in being one of the global leading yachts on the sustainable solutions front, having constructed the world's first zero-emission, fully autonomous ferries for Europe, as well as being the...
Announcement, ladies and gentlemen, we are going to begin the panel discussion in next 15 minutes. Till that time, please enjoy your lunch and have engaging conversations. Thank you.
The company lays significant emphasis on skill development and runs Vigyana Sana, its dedicated and self-contained training facility in Cochin. CSL is India's first shipyard to have obtained the CII Greenco Silver rating for its efforts at energy conservation and environment-friendly initiatives. CSL is also the first Indian shipyard with an integrated management system covering safety, health, and environment certified by DNV. With the ethos of Make in India, Make for the World, CSL has recalibrated its sails and set sights on continuing at the forefront of a brighter, greener future.
We are in the middle of transformation. Electrification, digitalization, connectivity, cloud computing, machine learning. Sensors are getting smaller, big data is getting bigger. Augmented reality and virtual reality are providing previously unattainable capabilities. And all this is providing unprecedented opportunity to create value and increase the sustainability of the ship. Maritime industry represents approximately 2.5% of the world's greenhouse gas emissions. And that number is set to grow with an increase in the global trade. ABB is committed to reverse the trend to take that number down. We at ABB believe that the next generation of vessels will be electric, digital, and connected. Electric because they are more efficient and sustainable, and digital and connected because that will take the productivity and safety of the vessels.
Personally, I think that the Azipod propulsion system is one of the greatest innovations in maritime history. All big ships need something that moves them forward. Azipod propulsion system combines propeller driving the ship and electric motor driving the propeller and the rudder which is steering the ship. For the Azipod unit designs, the sustainability idea and thinking starts already from the design table, that we consider the materials we use, how much we use it, what kind of materials we are using. There are about 400 Azipod units in operation at the moment. Even though the Asipod propulsion system is mostly known from cruise ships and ice-going vessels. It has been installed into more than 20 different ship types. In my opinion, of course, one day I would like to see that Asipod propulsion system is equipped in all the vessels around the globe.
The electric ships are currently representing about 10% of the world's fleet. And to make the maritime industry more sustainable, that number has to grow. We at ABB are fully committed to reaching that goal. In fact, we just delivered 2 ships sailing between Sweden and Denmark on full electric power, and we were able to reduce the greenhouse gas emissions.
I think it's important as a company to be modern. And to be modern is that you think about the whole economy. And economy is also how much we fuel. Traditional ferries have been fueled by bunker oil since 2015 in this area of the world. We have a low sulfur emission of 8.1. This vessel we're on today is from 1992. And the other one that we converted is from 1921. But they are state-of-the-art vessels when it comes to the technology. And that's what we're very proud of at 4C. These vessels are designed in the end of the 80s, but still have the newest technology on board. We have the battery power of equivalent of 60 Tesla cars. We charge on the Swedish side roughly 9 minutes and 5.5 minutes on the Danish side. We have less noise, less vibration. But we also have another important thing, is that the people that are working in the company are very proud that we are first mover in the world with this new technology.
ABB has already started to put batteries on vessels, smaller ferries going from A to B, and we have also taken bigger vessels, like the 4C vessels going between Sweden and Denmark, where it's run purely on batteries. I think we will see a transition in both fuel and technology, so we're taking one step at a time. For larger vessels, we see a good potential to a hybrid power plant. We can cut down on emissions, or we will probably also see these larger vessels powered by renewable power. There's a good potential to cut down on local emissions that affect people where they're living and local communities. And this technology with electric vessels and hybrid vessels is a technology that are available now and can address these issues now.
I think in general sustainability is important for any industry. And of course ABB wants to be a big part of that with its electric, digital, connected vision.
I think the industry is going through a big change right now. Being first mover, we can actually show other ship operators that there are possibilities to use the same tonnage that they have today and not going to new builds.
The member states of the IMO, International Maritime Organization, pledged to reduce the greenhouse gases by 50% by 2050. And we at ABB are committed to that goal and to provide innovations and technology to make that possible.
We would like to express our deepest gratitude to all the sponsors of this event, beginning with platinum sponsors, DRDO and Cochin Shipyard Limited, our gold sponsors, ABB, and the silver sponsors, Indian Register of Shipping and Catmatic. We also thank Aries Energy, registration area sponsor, and Class NK, the delegate kit sponsor. Great Waters, delegate badge sponsor. We also thank our associate sponsors, GRSE, Goa Shipyard Limited, L&T Engineering, Zentech Incorporated USA, Wasilla, Napa, Naval Group, Alwar D. Talon, Shiptech Icon, and Mazagon Dock and Shipbuilders Limited. Our event partner is Biz Events, and media partner is Maritime
consistently working on indigenization of defense technologies. Since its inception in 1958, the motto of DRDO has been Balasya Moolam Vigyana. The source of strength is science. DRDO has been at the forefront of Atmanirbharta in defense, having technical capabilities across the domains of land, air, and sea. Its strong network of 41 laboratories, associated work centers, 5 unique young scientist laboratories are spread across the country. DRDO has developed
പാണ്ഡെ. ഞാനിപ്പോൾ കോപ്പി ചെയ്തത് ഓക്കെ. പാനൽ 4 ഇതാണോ? ഇതാണ് ഞാൻ ഇപ്പോൾ കോപ്പി ചെയ്തത്.
അല്ല അല്ല വേണ്ട, നമുക്ക്
Good afternoon, everyone. I hope you had a nice break. The panel discussion 4 is about to begin really soon, so I request everyone to make their way towards Aman Hall. Also, a slight request. It is preferred if you are seating ahead of the hall. Thank you.
Okay. Explain.
May I have your attention, ladies and gentlemen? The panelists are already here. I request all the delegates outside to please make their way to Aman Hall. Thank you.
Our deepest gratitude to all the sponsors of this event, beginning with platinum sponsors, DRDO and Cochin Shipyard Limited. Our gold sponsors, ABB, and the silver sponsors, Indian Register of Shipping and Catmatic. We also thank Aries Energy, registration area sponsor, and Class N.
Ladies and gentlemen, we are going to begin with panel discussion 4 now. I hope all of you use this break well for networking opportunities. So, the panel is to be chaired by Mr. N.T. Anil Das, CEO and MD of Conceptua Software Technologies. Joining him are our esteemed panelists, Mr. Agatish Murthy, Manager, Marine Sale and Business Development, India and Southeast Asia at Cadmatic, Dr. VBS Iyengar, Scientist F and Secretary at NRB DRDO, Mr. Anil Kumar PK, Principal Surveyor and Business Development Manager, South Asia at Lloyd's Register, Mrs. Sapna Deepbu, Additional General Manager, FDG, Contingent and Marketing at MDL, Captain Sujit Pade, Head of Voyage Optimization, Digital Desk at Synergy Maritime Private Limited, Mr. Anthony Jacob Ashish, Lead of Products and Research at Planis Technologies. I request the learned experts on the stage, please. The topic for our second panel discussion is Impact of Technologies in the Maritime Domain through Innovation, Disruption, and Indigenization. This session will examine how cutting-edge technologies and innovative practices are reshaping the maritime industry. We will discuss the role of technological advancements, the influence of global bodies, and the importance of indigenization in driving progress and enhancing capabilities within the maritime sector. As we prepare for our panel discussion, I am pleased to introduce our distinguished panel chair, Mr. N.T. Anil Das. Mr. Anil Das is a graduate in Naval Architecture and Shipbuilding from Cochin University of Science and Technology, 1985 batch, and postgraduate in Naval Construction from IIT Delhi. He served the Indian Navy for 16 years before embarking on an entrepreneurial career. His tenure in the Indian Navy saw him overseeing the construction of 2 submarines at Mazgon Dock Limited and also being part of India's ambitious program to design and construct its own submarines. As an entrepreneur, he found Conceptual Software Technologies Private Limited and developed it into a much decorated company, currently designated as CEO and MD of Conceptual Software Technologies. Handing over to you, sir.
Is it okay? So for PPT, this is next slide. This I don't. Good afternoon, everybody. My name is Anil Das. I belong to the 6th batch of naval architects from the University of Cochin. Extremely glad to be here, and I am thankful to the organizing committee of DIMS 2024 for giving me this opportunity to chair this panel and to drive home the point of emerging technologies. Today's panel discussion, we are 6 panelists, as you can see. And the earlier panel, I would say the way it was conducted was very impressive. Jayakumar did it like more of a fireside chat. But in this, we have presentations, and the panelists would come here and speak. So that is the change that we are having in this panel discussion. We have about 10 to 12 minutes per panelist, which will see us going over to about 3:30, including the question and answer session. Welcome to this panel discussion, Impact of Technologies in Maritime Domain through Innovation, Disruption, and Indigenization. This topic, I am narrowing it down to show digitalization as the main technology that we want to speak about, and with special emphasis on digital twins. So we will be displaying the indigenous content and the disruptive nature of digital twins and what lies in store for the shipping industry through this process of the digitalization journey. With this, I also intend it to align with the seminar theme of navigating the maritime future of India. How the shipping industry can benefit from it, how the efficiencies can be brought in, and what are the kinds of applications where this kind of the digitalization will bring in the necessary returns. As you all know, skill development is of topmost importance. Profitability of companies is next in line, and risk avoidance. In the earlier discussion, we also heard the panelists speaking about for the same product, for different routes, separate solutions have to be made. We'll also see whether simulation-based design can avoid such additional unnecessary expenditures, if it's a possibility. We're just wondering. The digital twin concept is not new because we all know about 10 years at least we have been practicing the digitalization journey. Of course, it has been very slow. My memories are of the old steer bear system in Cochin shipyard. From there, we moved on to virtual prototyping and then on to simulation-based design. And today, we are talking about the digital twins. This topic has been selected in this digitalization for two important things. One is, in the maritime industry, lags behind the other industries in digitalization and reaping its benefits. That's number one. Number two, the returns are in large quantities or in percentages so that you cannot ignore it. We have to go to that level. DT concepts, digital twin concepts, have been estimated to fetch up to 40% reduction in operating expenditures. So we have that kind of earnings there. We have the operations expert to talk more on that. Up to 30% reduction in ports operations time, which means you can handle more ships and get the revenue for that. You all know what is a digital twin. A digital twin is a virtual representation of a physical object. We have a bidirectional circuit of information flowing from the actual object onto the virtual representation in the form of data, and actionable information goes back to the object. So this is a lifelong activity. It encompasses conceptual to the cradle or the decommissioning stage of the vessel. So it's a very continuous kind of nature of operations. Several technologies enable this, such as the IoT, AI, ML, augmented reality, virtual reality, and blockchain technology. So these enabling technologies are able to give us the benefits of this. Now, since I said about the continuous monitoring operations, it is like the cortisol hormones being monitored by the body. And this hormone is responsible for maintaining our stress levels, the fight or flee instincts that we get. More or less, a digital twin continuously monitors the activities of the vessel and looks for variations in data. And it could be improved data, it could be emergency situations. So, cortisol, I have taken that word to introduce my panelists in that order. We are 6, so cortis. Class, operator, research and development, technology, industry, and startup. These are the 6 panelists from today to be discussing with you on these initiatives. I will request the panelists to come one by one here and speak if they have presentations, or else they'll be sitting on their seats and talking about the points that they have to make. So this is the order in which this panel discussion is being progressed. First of all, I would request the panel members from class Mr. Anil Kumar PK to start the first presentation. And he would, if he wants to come here, he can do that. And I take this opportunity, please give a big round of applause to the panelists. Over to Anil Kumar.
They're going to operate the clicker. Okay. Good afternoon. Thank you, Chairman, for setting the scene so very well. And first of all, on behalf of Lloyd's Register, I would like to express my sincere gratitude to the organizers, Dostas, and the session chairman, Anil Das, for this opportunity to speak to you. From classification perspective, I got a very short presentation, and I'll cover a thought leadership report which we produced jointly with an industry stakeholder on autonomy, autonomous ships, and AI. And then I will take you through how the regulatory framework is developing in the technology space, both in terms of how IMO is going about developing the regulatory framework as well as classification societies, and touch upon digital twins, its application in ship designs and ship constructions. So autonomous ships, as we speak today, is no more a topic of discussion. It's really happening in the current scenario, current world we are living in. Dr. Manu Kuruvala yesterday alluded to how DRDO has been supporting or developing the autonomous systems and autonomous vessels, and which the wider industry can take advantage of it. And wider stakeholders, Indian Navy working along with the leading shipyards in India, are embarked on that journey of autonomous shipping. So way back in 2060, and one of the world's largest ship management and technology solution provider called Synergy Maritime, they are based here out of Cochin. We did an innovative project with them that was one of the world's first cyber-enabled ships. We don't call it digital ship in 2016. It was a cyber-enabled ship. That ship vessel built in Hanjin shipyard in Korea achieved certain autonomy level notations in cargo systems and machinery systems. Yeah. So classification societies has been working along with the wider industry stakeholders and providing the technology solutions and also providing the much required assurance. The chairman talked about the risk associated with the technology, so we need to provide that assurance so that we have a safe, digital, and sustainable and an efficient maritime industry going forward. Presentation coming up. All right. So first thing I wish to share with you a thought leadership report we produced along with Thetis, and Thetis is an innovation company in the maritime domain. And so Thetius did an interview of Lloyd's Register autonomy specialist and AI specialist, and this report is an outcome of that interactions. This is called out-of-the-box report. So the code there is from ChatGPT-4, has given a forward to this report. It's not from the people who produce the report. It says, the ChatGPT-4 says, as a forward to this report, accepting, assuring, and implementing AI and ship autonomy play a critical role in this journey. And as we explore these new technologies and their potential applications, striking a balance is between embracing the technology and upholding a comprehensive safety procedure is critical. So we couldn't agree more with the ChatGPT, and this is ChatGPT telling us that, okay, you got the technology, but you need to strike the balance. These technologies are safe for the ship operations. Yeah. So there is a lot of technologies out there, and what we need to ensure the safety, which is a paramount importance. So Chairman, as classification society, and we are not just sitting in the fence, and we are a vigilant gatekeeper, balancing the gateway to innovations with the responsibility of ensuring safety. So this report further says, this was produced in 2013, the artificial intelligence and the autonomy market and is going to converge, or it is converging. And there's a market worth of USD 3.36 billion, and these two domains overlap about 11%. And there is a significant growth from now 2023 to 2028. This overlap part of the business of AI and autonomy is going to grow as much as USD 5.01 billion. So, and both the segment, the AI on a CAGR for the next 5 years is going to grow at 22%. 19%, and the autonomy is going to grow at 22%. And both AI and autonomous markets have got relatively very similar proportion of startups and scale-ups. And for AI, 61% are from small, medium, and medium enterprises. And for autonomous, 44% are from SME business, and 21% is coming from the corporate business. So what we are seeing is that the innovation in autonomy and AI predominantly come from SME business. So that is exposing us to a risk, because the SME business are entrepreneurs, and they are younger innovators and younger minds. And so we need to ensure that we have a responsibility to ensure that these technologies which SME sectors are developing is safe for the ship operations. And this slide shows an autonomous shipping market growth from 2025, the inner circle there, inner pie, to 2020 to 2025. And in different segments, like there are 8 segments: workboards, supporting technology, decision support system, defense, surface drones, unmanned merchant ships, vessel construction and design factors. We can see the defense in 2020 taken a lion's share of this automation and AI. And this is going to be the same scenario in 2025 as well. But if you look at from 2020 to 2025, the merchant ship, the commercial ship market, technology uptake on the market is also growing from a mere 0.5% to 2.4%. So this is by unmanned merchant ships. So going forward, it's not going to be just defense alone, because as Dr. Kurula mentioned yesterday, that there are technologies being developed by DRDOs and defense, so which is growing its maturity now. So the wider merchant shipping can adopt those technologies and work on that. So this is an example of some of the real projects and Class Societies has been doing. And these are autonomous systems and unmanned autonomous vessels, remotely controlled. And I'm not going through the detail of those individual projects. If you're interested, I can share that later on. They are vessels less than 24 meters, mostly 12 to 18 meters, and they are absolutely remote control autonomous systems or the vessels. So now looking at the regulatory roadmap and what IMO has drawn out. So by May 2025, IMO will finalize and adopt a non-mandatory maritime autonomous surface ship code. It's called MASS MAS code, and the work started in 2023 last year, and in first half of 2026. And IMO will also develop a framework for experience building phase once this code is developed in 2025. And in 2028, IMO will commence development of a mandatory MAS code, and based on this non-mandatory code in 2025. And there will be a consideration to amend SOLAS, inclusion of a new chapter in SOLAS for adoption of this code. And by 1st July 2030, adoption of mandatory MAS code is going to come in force by 1st January 2032. So this code is going to be a goal-based standard. That means there is going to be a goal and a high-level functional objectives. And this code is going to be independent of technology bias. And there won't be any mention about the technologies. And there is no ways defined to assure and verify the technology aspects. So that is left to the member state, classification societies, and wider industry to resolve those. So in short, the MAS code is going to provide an enabling framework for certification, and the responsibility for the technology options, selection of the emerging technology, assurance and verifications, aligns with the flag state and class societies and the wider industry stakeholders. That's about IMO. Now, moving from IMO to what class societies are doing, I've taken Lloyd's Register as an example. All class societies are working on this field. Lloyd's Register, we started this journey way back in 2016. And to support the early adapters on the technology innovations and working along with the wider stakeholders, the ship owners, administrations, and autonomous system manufacturers. And the purpose is to assure safety for these technologies. And in 2016, Lloyd's Register published the first procedure for cyber-enabled ships. This is for defining the autonomy levels. And the 9-6 key risk areas have been identified while writing these procedures. And areas like the human interactions, data quality, system architecture, hardware and software, and communication and network, and system integration, configuration management, and cybersecurity. All these aspects have been considered to identify the risk while drafting this guidance note. And in 2017, ELA published a code for unmanned maritime systems, mainly applicable for vessel less than 24 meters. In 2018, the first assurance framework for digital twins and AI was published. And in 2019, and the first update on the autonomy levels has been published. And in 2020, there's further publication on updates on cybersecurity notations. And all these standards have been developed, or guidance note has been developed, the code has been developed, working in collaboration with academia and the wider industry. Just to give you an overview of what that autonomy levels are. So the vessels have been classified in 5 different autonomy levels, starting with AL1, the electromechanical ships what we have today with very minor autonomy on board the ships, autonomous system on board the ships, all the way up to AL5, which is a fully autonomous vessels. And so the project which I just mentioned, what we work along with Synergy Maritime, the first cyber-enabled ships, that's the one on the top left on the screen, which is an LPG carrier. Subsequently, there have been a few other vessels built in China, the cellular container vessels. They have been assigned with these autonomy levels, and most of them has achieved an autonomy level from AL2 to AL3, and some of them AL4. Not the entire ships, not the entire systems, but some of the systems on board the ship. Yeah. Now moving on, the title here is Latin, which says what get measured improves. And we did look at the technologies that can measure and manage the health of a component and systems, which our chairman mentioned in his opening remarks. You know, how do we do manage the health of the hull, the machineries and propulsion systems and components on board the ship, and by using the data and carrying out the data analytic. And we named it as a digital health management system, DHM technologies in abbreviation. And for example, traditionally on the screen, we can see a hull structure, a failure, a crack on a weld joint. So traditionally, a hull structure survey is done by a close-up surveys and supported by thickness measurement. And then surveyors recommend a ship owner renew the steel plates, for example. And with having strain gauges fit with the digital health management systems, we get a real-time scenario of the shear force bending moment acting on the ship and hot spots and heavily stressed areas on the ship, and we can do a real-time assessment of the asset actually. And same way we can have sensors fitted on machineries and equipments on the ship. And traditionally, the machineries are overall based on the running hours. So we can actually carry out or open up a machinery for overall based on if the condition warrants it. And we don't need to open up once in 5 years as required by Class Society's continuous machinery survey cycle. So the digital health management. So we applied that to a digital twins, and as again chairman defined that digital twin is a data-driven representation of a physical asset, and which is residing on a cloud. And so when we have the data streamed from the ship, the hull and machinery and electrical equipments and systems on board the ship, from the physical asset to the cloud, and by pairing the both physical and digital asset, so we can actually carry out a complex data analytic. As there was a report run by McKinsey quite some time ago, which says on board the ships we have lots of equipments, and all the equipments and machineries have got sensors, but then the data we capture from this equipment and machineries could be 1% of all the data available on the ship. And even if the rest of the data are captured, entered in the logbook on board the ship, and it retains there, and we don't really use those data. Now imagine a scenario where we got digital twins, strain gauges on the hull, sensors fitted on the equipment and machinery. We get a continuous flow of data, and those data can be used for making judgment decisions, obviously using the big data and analytic technologies. Yeah. And so based on this digital health framework and digital twins, as a Class Society, we drawn out a digital compliance framework, and how do we digitally class a ship. And we have 4 levels of approval, and the first level, the DHM provider, and the digital twin ready is for actually the digital twin firm, the process and the procedures being audited and certified. And digital twin approved is when the firm developed a particular digital model of an asset, of an equipment, machinery, or a hull. So Class Societies approves that, and then moving on from there, digital twin commission and digital twin live. And the commission is happening when the ship is built, and digital twin live is when the ship is in service. So mapping that onto a ship design and a shipbuilding scenario. So digital twin ready is more at a concept design stage. Digital twin approved is more when we do the plan approval process. And digital twin commissioned is all the way from construction, outfitting, commissioning, and delivery of the ship. And digital twin live is when the vessel is delivered and enter in service. Yeah. In conclusion, a sustainable digital maritime future isn't just about technology. Technologies are out there. They will evolve continuously. And the pivotal factor lies is a comprehensive development of an ecosystem addressing establishment of a robust assurance framework, the assurance of data quality, data security, and at the same time fostering the necessary skill required for managing such platforms. So the challenges are not a solitary obstacle, and they are very well interconnected, so which necessitate a collective effort from all stakeholders, and for moving towards a sustainable digital maritime and offshore scenario. That's my presentation. Thank you very much. Yeah.
Thank you very much, Anil Kumar, for the very illuminating presentation. Our next presenter is from the operations side, Mr. Sujit Padye.
So we'll be needing the pointer right now. Yeah. I can use the keyboard. Can you change the slides?
You want to change the slide, you can use using space. What I want to do is, no, the thing is,
Good afternoon, everyone. I'm Captain Sujit Padye, working for Synergy Maritime Private Limited for their digital desk. So thank you, DOSA's team for inviting me here. And thank you, Anil sir. He had very good ideas about getting everyone together and preparing this event. So we started the theme with digital twin. There are already some senior members of the team who have focused on digital twin. So I'll spend little less time on digital twin discussion and move on to the operations part. However, as a ship operator, what we would expect is a virtual image of a vessel when you're operating or monitoring that vessel from the office. What is exactly he is going to expect from the digital twin is it should serve as a comprehensive model that would exactly replicate what is happening on the board, on the ship. So remain, say, continuously contact with the physical asset and relay all the information to the office or the operation center, and continuously learn, create, say, dynamic simulations and provide guidance to the operation team. So this life cycle should actually begin in the design phase itself, or while we actually decide to construct a vessel, so that the feasibility studies can be carried out, facilitate, say, virtual commissioning of different parts, machineries, and enable integration before testing, before construction or installing of that equipment. During the operation phase, it should be continuously learning, integrating all the data received from the ship or the vessel, and monitor the performance and integrity of the vessel. And so the efficiency of the vessel can be monitored and continuously improved upon. And the last stage would be the decommissioning stage, where in the decommissioning stage, it should serve as an independent platform providing all the information associated with that vessel, so that the documentation is easy, all the labor issues or handling of any hazardous materials can be easily carried out. There are several benefits associated with this digital twin concept. However, it remains an evolving stage, especially for the maritime industry. Like Anil sir showcased, our expected growth, especially for the merchant marine segment, is about 2.4% in next coming years. So It's still in a conceptual, or I would say in a growing stage, not yet completely implemented. Looking at the benefits, there are several benefits, and there are several other supporting components as well, or different technologies which are actually being a part of digital twin requirements. Those are already in place. So what all places it can help us? There are several. I'm just limiting them to three. Say structural monitoring, operational parameters, that is during the operational period, and monitoring the navigational systems. On the other hand, there are several challenges also. Initial cost. So any new technology that we bring in, shipping is a very cost-sensitive business. And ship owners or any other investor would think several times before investing into these new concepts. Next thing, what is going to look at is the return on investment. So whatever new technology we are implementing, is it really going to help us in improving the cost efficiency? And third is industry readiness, or we can call it as change management. Any new technology or the members associated in this implementation of the technology, they have to be ready to take those challenges. And these three remain significant, say, challenges while implementing this technology. There are several applications. Like I said earlier, there are different technologies which are going to be contributory to the digital twin. One of them is connectivity. We should have good bandwidth, satellite network. So all the information flow has to remain continuous. Then the integration of IoT devices, real-time data collection, they will actually enhance the digital twin functionality, followed by CCTV or image recognition technologies on board to improve the safety of operations, shipboard staff, and tracking of the vessels, such as AIS or Inmarsat-C position polling, followed by data monitoring and AI technologies to analyze the performance of the vessel and learning how we can continue to improve on the operations, followed by predictive maintenance and the inventory management on board. So some of the use cases which are already in place, there are several say businesses or service providers who have already implemented or who are providing these services in the industry. So one of them is vessel performance monitoring. By using IoT technology, we can actually closely monitor vessels, say power usage or energy consumption during different phases of the life cycle of the vessel. So whether it is out at sea, whether it is in port, during maneuvering, while the vessel is in calm seawater conditions, once the vessel interacts with, say, rougher weather conditions, how the vessel's performance deteriorates. So all these different aspects can be taken into consideration to develop different consumption parameters or curves for the vessels using AI technology. So next is emission and environmental compliance. So real-time insights from engine performance and fuel efficiency, they actually allow for optimizing the engine use. So we can continue monitoring and improve upon the emissions and the environmental compliance. And the operational profile monitoring of the vessel. So over the period of the, say, 1 or 2 years, vessel's performance will continue deteriorating due to, say, external hull fouling and, say, condition barnacles developing on the hull. So how this performance or the consumption graph is going down, we can actually monitor if we are able to take or if we are continuously recording vessels' day-to-day parameters in our system. And here you can see actually once the vessel has undergone hull cleaning, the power consumption has significantly come down. The next a very important part is about, which is linked with voyage optimization and maritime industry, is the scarcity of the weather observations. So out at sea, there are very limited sensors or say ocean buoys which are actually relaying the weather data to the global ocean models. Now, if we have good IoT technology which can relay the live weather data which is being observed on board, that can be relayed to the global weather models to improve upon the weather forecast. Okay. So not only say improving day-to-day weather observations, but these details can help in improving the accuracy of the weather forecast over the period of next, say, 6 to 8 days. Nowadays, weather forecasts are available for 15 days. However, their accuracy remains, say, 3 to 4 days. Beyond that, it continues deteriorating. And one of the reasons is local observations or on-site observations. This can further help to derive or create, say, seasonal weather patterns. Those will be affecting the different routes taken by the vessels, especially during the heavy weather period, say northern winter or southern winter. Another aspect of the ship's performance is vessel motions when the ships are exposed to these hazardous weather conditions or adverse weather conditions. Now, with the IoT technology, if we are able to implement the actual vessel motions those the ships are experiencing, we can continue to improve upon vessel modeling, and quite a few times, say, there are different routes taken by the ship masters based on their actual experience and the conditions they are experiencing at that time, or certain, say, weather thresholds they may be setting up for their own safe navigation purpose. But if we are able to monitor this using the new technology, there can be rationalizing of these, say, damaging weather conditions, which can further improve upon route guidance provided to the ships. So, in real time, we can continue to improve upon routing efficiency or optimizing the vessel passages, ensuring those passages remain safe, avoiding any, say, damaging weather conditions, and ensuring the scheduling, which remains another important part for the successful passages. So vessel remains on schedule while maintaining the economy of the passage. Okay. Next is maintenance with predictive analysis. Again, using IoT technology and real-time monitoring of the vessels, constant data collection, any unexpected stoppages or downtimes can be avoided. So by providing predictive analysis of any machinery, we can carry out advanced maintenance and forecasting of any equipment that is expected to, say, come to a halt or malfunction. So overall, if we are able to implement the digital twin technology, some of the parts are already in place. If you're able to implement it successfully, this can help us in improving the longevity of the vessel and extending the life, including the efficiency of the vessel. And the last is, like Anil sir was explaining, regulatory framework. So digital twin is definitely going to help us in complying with different regulations in future, as there will be different regulations coming up with the huge amount of data available on the shore side. It will definitely help us in complying with those regulations. It will also help us in environmental monitoring. And as the industry demands transparency, it will also help us in reporting. So EU ETS or CII reporting, followed by the autonomous technology, which is the future of this industry. Definitely digital twin is going to help us or take us to this autonomous technology for successful implementation. Thank you. Thank you.
Thank you, Mr. Sujit Padye, for that wonderful presentation. The next speaker is from the DRDO. I request Mr. Iyengar to give his talk. He doesn't have a presentation, but he'll be articulating the topic.
Thank you. Perhaps in this panel, thanks to Dostas for allowing me to speak on this particular topic, technology in maritime domain through innovation, disruption, and indigenization. And thanks to the chair for choosing me in this panel. Already two of my panelists have spoken about different aspects. I bring in as to what is the indigenous R&D that is taking place in this general domain of technology development, as well as in particular references to digital twins and digitalization and artificial intelligence. When it comes to that technology drivers, I mean, usually we just talk, I mean, what drives the technology we have been hearing for the past 2 days. Basically all these rules regarding our climate and COPT, that is one technology driver. And the other primary technology driver is basically as a derivative of is the performance improvements themselves. For example, a few years back, there was a lot of research on energy saving devices in ships. So that we're able to reduce, save a lot. The motivation might have been from different factors, whether it is acoustic performance, whether it is just simple saving of power. But a lot of energy saving devices were researched upon, and that was one technology which was there. The third technology driver, which is what is basically happening in R&D sector, is a plain inquisitive. What happens if we do some things? In this, what was happening in the past was the various elements which finally went to the digital twin, whether we used to call as numerical towing tanks or FEA models or fluid structure interaction models. These were all in places in different platforms. And when digital twins, as my previous panelists have already spoken, suddenly sprung. It didn't suddenly spring 5 or 6 years before, but it sort of suddenly, I mean, coalesced into these different things like numerical towing tanks or the FEA models, all and the CAD-CAM developments. These three technologies which are going on for years suddenly became an integrated platform which primarily made the digital twin possible. So once these digital twins were possible, then for newer ships, certainly they were all very good. But for existing ships, where say particularly 15-year-old ships, we found that the CAD models were all probably built, or even say older ships of 25-year-old ships where there were practically no CAD models, only 2D CAD models were there. There were some pilot projects, particularly in say defense R&D, particularly in one of the labs, defense R&D labs, where they decided that one old ship of maybe a 20-year vintage, they decided to do the complete digital twin of an engine room. This is along with an academic institution. So that which means both the 3D measurements had to be taken and laser measurements had to be taken. And all the machinery also had to be modeled, whether it's the pumps, the weather, it's the engines, all they have to be modeled. On one hand, you're having the performance model, on the other hand, you have got the geometric model, both integrated. The work is still on. That is because of the realization that digital twins are going to offer huge benefits, and to actually sell this concept also, we needed to develop the R&D sector also has to put in their this thing and do the works. And this is the work which is on at Indian Maritime University, the complete digital twin of an engine room, both in terms of its performance as well as in terms of its geometry. As we are talking about that, we are also seeing what are all the latest technology drivers in this particular thing. When it comes to digital twin, what it offers is a prediction, certainly at design stage. Sometimes it offers a prediction which is undesirable, then we always go back to the design cycle and correct. This is the usual, whether you use the spiral model, whether it's a V model, we always do that in systems engineering. And the third thing is the pleasant surprises are always offered. I mean, what you don't, when you do the trials, it is not predicted, but there are some pleasant surprises during trials. They go back to the digital twin models, and our model, if it is coupled with an AI model, becomes a self-learning part. But what is more of a concern, and what the digital twin offers as an advantage is, previously if you're, say maybe vary the parameters, maybe your parameter space was say 5 parameters and 525 times you have varied. Now digital twin offers us the ability to vary a lot more parameters, or a lot more points to be studied or in the parametric space. Previously, if you in that matrix you studied maybe 5 points or 10 design options. Now it allows you to study maybe much more design options, which will bring out those failure points much early in the design, which was not previously available before these digital twins are available. That's a very powerful tool. And that is the reason why we also thought that we should all go for digital twin even for existing ships. Because as the ships grow older, the chances of failure is also higher. And so a digital twin will sort of help us to find those faults which are otherwise not even examined because my design parameter space or my operation parameter space previously didn't have the tool to study, even though I may know that such a space may exist. Having said that, now I'll just go back to the other thing, basically the importance of digital twins. We were just seeing the recent report on technology. It is about what are the technologies which are there in the maritime domain which is going to go for the next few. And all of us have talked about it, my co-panelists have also talked about it. It's about artificial intelligence and machine learning, autonomy, and energy transition and decarbonization. In one sector, I already talked about the ESD in terms of electric propulsion and hull grooming systems. In all these areas, what we call in DRDO is that we go by the technology readiness levels, where when we talk about very low technology readiness levels, there are just concepts which may just end up in an academic paper and nothing more than that. And really very few of those concepts will actually go forward into a prototype, and a few of that prototypes will actually go into product. So when we talk about the operations of the industry or the full ship, you're talking about the product. But you're also talking about projects at very low technology levels which may just end up in academic papers, but still give us a great physical insight. And that comes to the AI, where when we talk about modeling for digital twin, we can either completely go on a physics-based models where we go by the fundamentals. And now with cloud computing available all throughout, and this is very heartening to know that none of us are constrained by my own computational infrastructure at my lab, which is basically having a certain number of cores. I can always hire any number of cores which I want. Of course, it costs money, but the infrastructure is available for me to hire any number of cores in the cloud and do the sort of computations which were previously a constraint for me as an infrastructure. The other interesting thing is a purely AI-based model. One of the projects which was done in collaboration with the Indian Navy and an academic institution, NIT Trichinopalli, what they did was the previous data, not a very relevant current data because they wanted to build an AI model. The previous data, which can be probably in public domain also, they simply scanned the logbooks, maintenance logbooks of a certain period, say 3-year period. All the maintenance logbooks did a natural language processing and found out what are the repairs which were reported and what are the requirements in terms of its machinery replacement parts or whatever. And with that, they built a logistics machinery replacement model. And another benefit of it was because they were completely scanning the logbooks and made this into an AI-based learning tools. And this is not a physics-based model. This is a pure data-driven model based on scanning of logbooks. The technology was again natural language processing. And which means why I'm telling this is this was not done by a naval actor, it was done by a computer engineer whose expertise is in natural language processing. This is what we call as a collaboration of technologies where, I mean, he didn't understand anything about ships, but all that he did is did natural language. You have to replace this particular bolts according to your maintenance schedule, supposed to replace every 3 months. Now you're supposed to replace every 1 month, something is wrong there, sort of thing. So this was a very effective model, which is then Navy updated it with the recent data and still using it. Of course, being Navy, the recent data is confidential, but it was a self-learning model. So this is what I tried to tell, that when it comes to AI technologies, it's collaboration between computer scientists and this thing, and sometimes even the physics-based guy may not be required in sometimes. And the best thing is actually a hybrid model where we combine these two things. Of course, just to, even though I talked about digital, just to cover some of the other technologies which are actually happening in the R&D sector, just to conclude, is, for example, we are in material technologies, particularly when biofouling becomes very important. A lot of nanoparticle dopings are being tried in paints so that how we can prevent biofouling, and acoustics, propulsion, and sensors. All these things are getting combined. And since my other panelists are talking about the system integration or how we integrate all these things, I'll just leave and end my talk. So thank you.
Thank you. That was very interesting. We have the next speaker that is from the technology side, that is Agatish Murthy.
So, good evening, everyone, and thank you, Dostas, for giving me this opportunity to be a part of this honorable panel, and thank you, Anil sir, for introducing me. And without further delay, I'll just start the discussion on this. My point is, like as my co-panelist said, like digital twin is a a virtual representation of the physical asset, and like how it is optimized is when there's a bidirectional data from the physical floor, and you're able to reflect that in the digital model. And also it is very important that you have your informations better integrated for the viewing purpose. And also, as the surveys which we can see is like there's a McKinsey survey, like as even Anil sir said, that we are on a slow pace of improving this digital twin or implementing front. What was the survey results was? It was a very small percentage of entire digitalization projects are successful, and the reasons are 31% of the survey result was of there was a lack of expertise and knowledge about this, and then the remaining 31% was the focus on cost reduction rather than implementing. And there are, of course, that is true also, because when you have to digitalize it, your the previous way of doing it, of course, it is going to cost. And this is a survey I would like to quote. And so I have a solution, or we can say what we would propose from where I come from is, so it is like, of course, digital twins are normally IoT based. So here we have a platform, which is, I would say it's an unified platform for having a digital twin. And why do we need this kind of platforms is, like example, unlike a traditional PLM, of course, a 3D model, needs data, operational data, experience data, and a PLM data for that matter. And then why do we need a API architecture like this? First of all, what is this API? These APIs are software components which allows to, exchange information between two softwares. So that's a simple saying for API. And why do we need a architecture platform like this is, unlike an typical PLM, where we actually extract the data, keep it centralized, and we, present it as we desire. So that cost your, the cost front is increasing, because you need to have different UIs to be developed with the PLM. And of course, having this modern shipbuilding, we have multiple domain-specific softwares which are in the need to have an user interface with PLMs. So these architecture platforms are actually minimizing or eliminating the need of the UI, because these architecture platforms are configured in a way that it could actually get the data from the source originating software itself. Actually, that is the role of this API, and so your UI expense is coming down. And then the one more best thing is, of course, we know, being from a CAD and a CAE background, so it is morely focused on the configuration of the project, right? But now when we move on to the production side, what happens, there's a growing number of tasks with that, and a lot of information that are generated, and quite that are not integrated as well. It's all fragmented information, and we can see that here. And what happens is, these platforms generally refers a contextual relationships. It could be between a CAD model and an Excel sheet or any third-party systems, and it develops a contextual relationships, and it allows you to bring this fragmented data to the actual mother data column. That is one usage which I'm seeing. Then of course there are principal capabilities of this, and actually I'll just tell you what are we seeing. So if you can see, there are URL APIs, REST APIs, and .NET APIs, which are the software components I'm saying. So what this does is, this URL API allows you to view, examine, and do whatever you see on the desktop kind of thing I'm saying. Then there is this REST API which allows you to have active synchronization. That's what we expect in terms of a bidirectional data exchange. Then when you come to this .NET adapter, what you're seeing here, this adapter is morely for having integrations with the software. It is an inbuilt, it's the functionality of that API. And then it allows you to connect to your external databases and systems as well. It could be your PLM, whatever we have right now. And then this is the normal platform for this. I call it as a unified platform for digital twin. And then, as I said, there are some principal capabilities for this, and you are seeing that on the screen, which is accessing information in the context and hierarchical breakdowns. Like, it is not only just a platform for your digital twin to be, but it has got some inbuilt capabilities. Example, you can see in the first accessing information picture, I hope it is clearly visible, you have a 3D model. Normally, a digital twin can be a 3D model at the center point, or even a 2D, with a GIS on it. So we can make digital twin on it. So there's a 3D model here, for example, and you have that links, okay, that are hyperlinks which are generated by that kind of platforms, and that will take you to the external application. And then it also have the related informations like documents and drawings you can see. This is one inbuilt capability that has got. And the next one is hierarchical breakdown. This is nothing but how we normally, have stored our project is how we create it. But this allows you to have your own categorizations and, the way you get presented, because there are much more capabilities attached to it. So you can create your own categories on, your scheduling date or block-wise, or even from a third-party system which you are willing to access. You can create that. And then there is capturing observations and initiating change. This is about you have a markup, and that markup becomes more live when you keep adding feedback to that particular place, and you're trying to get it back to the digital loop, so nothing gets missed. And there is this visualization and synchronization picture. So this is about, you're seeing 3 pictures there. The first thing is about the blue and the green, is about showing the information about various thicknesses. And the middle one is about your synchronization with non-nested and nested plates. That enhances the synchronization part. And then the third one you're seeing about the data consistency. You are getting highlighted data consistencies there from a 3D sketch. So these are the inbuilt capabilities, I would say. And then when we speak about the implementation part, how easy it is, because implementation also costs, because it incurs a lot of man hours and specialists to do that. So the thing is, the implementation is very rapid in this case, because we are adopting to this low code and no code approach, because we have inbuilt plugins and adapters to have this activity. So we are reducing this specialist requirement over there. And then the beauty here is the adoption factor. You need not implement it right away, but rather it can be specification built. How much you want, only that much you build, and that will be depending on your requirement and how well your organization adapts it. So then the third point is no penalty to create any projects, or you can have your own demo environment and create your new workflows and with external systems and test and trial it. And then establishing new project, as we do in CAD, it is very possible to replicate that kind of approach here, where you can take the configuration from the previous project and come along with it for the new one. But the thing is, you need to have a common naming patterns and things little bit standardized. That's what here we can see. And then so coming to the future point of this, so what does the future hold for this? Like how are we seeing it? So since there are AI interventions, and we are speaking about multiple databases to be handled with this, because we are trying to minimize centralization and extraction of data. So what we can see is we are seeing this natural language workflow, which is and RAG, which I would like to explain. Like, what is this RAG? This is a prototype. So how it is this working? So it's called Retrievable Augmented Generative AI, which is for improved data management. So what it does is, maybe once you give a query, and this query goes to the vector database, which is a complex database, and what it does is it collects all the relevant information regarding your query. It augments the answer, and through a larger language model, it gives you the answer. So what it does is more natural questions, and you get a more natural answers. So the better you understand. And then when you speak about this integrated AI for specialist devices, this is, I would like to emphasize here on the the role of proprietary tools in the modern shipbuilding. Of course, you all would have come across this, that there are many softwares and proprietary data are there, then you need to have your people also ready for that. So in that case, this AI is already pre-fed with that proprietary data, and now we are actually trying this with the HoloLens and augmented realities for production reviews and surveys. So this AI will guide you to go through that devices with this proprietary data. So and apart from that, there are many implements that we are looking forward. So that is also a possible example when you speak about the CAD point of view, where you wanted to have a faster modeling, then generating macros is a bigger thing, where at least a small macro will cost you around 50 to 200 lines of coding. So what this does is this kind of implementing AI or embedding AI to these tools will allow you to communicate naturally, and you get the macros as well, and then you can start working. So this is how we see this human-centric digital twins. And finally, what I would like to say is, like, this digital twin, if we embrace it without a massive disruption in our workflow, and it will be really very supportive, and we can grow at a very faster rate. So that's how I put my point, and thank you.
Thank you very much, Agatish. The next speaker is from the industry. May I request Sapna Deepu to speak on that.
Thank you, sir. And a warm good evening to all of you. If you look at the shipbuilding industry, there are more than 15 niche technologies which has emerged as relevant to the industry. And the session chair has narrowed down our today's discussion to digitalization with an emphasis on the digital twin. So I'll be talking about a little bit on the virtual reality, augmented reality, or mixed reality, which I touch upon the digital twin. Before getting into this, I would like to have a notice on this. What are the key drivers for the digitalization? So if I look at 6 in numbers, the first one is the shipyards has to handle and process a huge set of data. Then we need to have a seamless information flow to ensure that we are buoyant in this disruptive technology contest to be reliable and efficient. Then there is a need for reduction in the cost to be competitive against our global competitors. Then comes, yesterday also the panelists were talking about collaboration between the shipyards. So there is a requirement for data sharing with data transparency. Then comes how we are going to compete with each other and compete with the global marketing. So it's all requires to adoption of the technologies. So as a shipyard, we have gone from 3 generations of digital transformation. That is from the paperless procedures to the digital procedures and now to the smart procedures. So what is the pressure on the shipyards to actually adapt the technologies? One is we need to optimize our designs, then we need to connect our data, and third, we need to have an automation in our processes and to have the shipyard to configure all of this into making into a success. So as a shipyard, we need to talk about impact on the technologies in design, planning, production, and then the inspections, and then these trials. So we cannot forget the supply chain also. So the design part of it, when I look at MDL, having spent almost 30 years in the yard, I have seen the transformation of this shipyard, the way how it has transformed digitally throughout these 30 years. If you look at the 3D modeling or procurement or production to a certain extent through a digitalized format, it's going on for years. Now, in 2011, we have implemented a virtual reality lab in our yard, which is first in the shipbuilding industry, to have an immersive visualization of the design, to take care of accessibility, then operability, and the maintenance space check. Then we need to good look into the ergonomics and human factor engineering. So when you really look at a destroyer class vessel, we are looking to almost 37 kilometers of pipes, maybe another 6 kilometers of ventilation trunks, 450 kilometers of cables, almost 14,000 equipment to be fitted on board, and 600 compartments to be checked. So this virtual reality actually helped us in reducing the timelines for design optimization. The line-out inspections used to happen with the compartment layouts being marked on board, and with this VR lab, we are just seeing the collision checks and all the operability part in the lab, and this actually makes it easier and faster. So the completion time for the optimization of the compartments reduced from maybe 82 months for the 600 compartment to 36 months. That means in 8 to 10 line-out inspections used to happen in the earlier times. Now it's almost 32 in a month. Now the next thing is that design we have covered. Next is the planning part of it. So there is already the PDM and PLM solutions are already there in the shipyard to take care of the entire life of the vessel and how we plan the production also. Then comes the supply chain. There are innovative products are available. Since we are talking into digitalization, I'm not getting into that. And even the automation in the production process also, I'm not getting into detail. Now comes the inspection part of it. So MDL is now graduating into an augmented reality, or rather a mixed reality inspection procedure, where the digital and the physical components are superimposed on each other on a one-to-one scale, where we can visualize the design on board the ship in a compartment, the reporting, the review, and all, making it very easier and faster. So with all these things in mind, I would like to end stating that as on today, we know what are the technologies available for us to adapt. But the change we require is our typical Indian mentality of kuch to jugaad karte hai. We cannot do that now because we are competing against the global shipyards, and our clients already know the benchmarks. So it's time for us to really look into and invest our time and money to adopt the technology solutions to suit our shipyard requirement. Because shipbuilding is not like the automotive industry where you can do the batch production. The technological solutions has to be customized to individual shipyards to suit the clients and the shipyard requirements. With this, I'm giving thank you.
Thank you very much, Sapna. So the last speaker is from a startup. May I request Ashish to give his talk? Please introduce yourself.
Thank you, sir. Thank you, Chair, Mr. Anil, sir, for giving us this wonderful opportunity. We are truly honored to be here along with my co-panelists, all prolific individuals in their own domains. And a very good afternoon to one and all of you as well here. My name is Anthony Jacob, and I lead products and research at Planis. Today, I present a slightly different perspective, still relevant under the digitization, the disruption, and the digital twin domain. So the perspectives given, I just have a few highlights. from my co-panelists, the life cycle, which is as important as, all the way from design to all the way to the compliance, the regulations, that what are the other drivers of embracing this digitalization and digital twin. And like Deepu ma'am mentioned, how well can inspection be integrated into these systems? So let me add a little bit into how Planus as a startup is building technologies, talking to shipbuilders, talking to yards, and a lot of other players in both the government and the defense segment, and building and catering to products and solutions towards them. Can we go to the next slide, please? So, Planus today has been performing inspections. So fundamentally, two things are what we do today. One is inspection solutions. We use marine robots, both autonomous, remote control, to collect data which was, first of all, otherwise difficult or impossible in certain cases. And typically, to name out a few, storage tanks, SBMs, ports, dams, pipelines, these are key areas where we could use our niche technology, especially in the Indian market, where the adoption of these new technologies was slow. Now, and when we spoke to clients, when we spoke to the end users of who actually are maintaining and are responsible for maintaining these assets, this is what we understood. The data which is given conventionally, when you inspect a large asset, you have hundreds of hours of data given to the end user. And it is up to the user or the manager to sift through all this information and pick out, my problem is there. How can I give a solution to that? So that was one of the key problems we understood in adoption of these new technologies. The second important factor was even when people accept quantitative NDT solutions, one of the key challenges is, you've given out documents and documents of data, at this point on my ship, at this hull location, I have defects. And it becomes hard for the end user to figure out and create actionable solutions. So this is where we understood our technology can bring in aid. So, so this is where, can we go to the next slide, please? You'll have to click on it. So this is one such digitization solution. I'll just let the video play for a moment. So what you see here is the first step, right? Digitization and the disruption. How can the end user take these volumes and volumes of data, which have different assets inspected historically over the years, periodically inspected? How can all this data be compressed? How can the user gain quick, valid, and data-driven decisions can be made? So this is one such example wherein a large storage tank has been inspected, and what you can see here is various different inspection techniques have been combined. The data has been taken and assimilated into the drawings of the user's structure itself, and you have the end user now not requiring to go through loads and loads of information, and exactly what is needed is pinpointed. So this is the first step we've understood. We've figured out that the value add for the user and embracing the digitization tech from all these different parameters can be brought in together. So that is the first step. Now once you have done that, now you have been given a lot of other arsenal, a lot of weapons. And first one, like our co-panelists mentioned, is the analysis. Now you now can build in all these physics-based models. Now you can use all these technology to actually derive, predict, and generate all your maintenance regimes around your systems. So that is the first step which I should talk about. Now, the next step is, of course, once you have these data now coming in. So fundamentally, Planis does two types of data acquisition devices. One, you periodically go to the site, use your devices, your sonars, your NDT inspection to periodically collect data. But on the other side, what we also understood is you can permanently or semi-permanently mount sensors on your hardware. Whether it is your ship hulls, whether it is your engines, your pipelines, and in this case, what you see here are storage tanks. So gas sensors, pressures, remote control systems, and all these now can be connected together, where now it makes, coalesces, like Sir mentioned, into this digital twin system. What I'm about to show you is an example where this system has been applied to a storage tank farm. And this same technology and the same system still applies to, maritime assets, especially the ship building and maintenance of it. Can we go to the next slide, please? The next slide, please. So I'll just let it play for a moment again. So what you see here is, so fundamentally, there is real-time data coming from the asset which you want to maintain, where you are the end user. You have several sites in several different countries, and you want to know which is performing how, and you want to have a centralized control system wherein both real-time data is coming, say for example your cameras, your strain gauges, your other pressure sensors, say for example, and you also have certain inspection techniques which have to be done periodically as per your regulations. So these are all overlaid over your actual one-to-one scale of your asset. And what you see here is a complete data wherein you're interacting with the asset. You have a central command station where you can control, take emergency actions. So these are how, overall what we saw here, I would, close this short note by saying, this is, we have moved on with technology, like Sir rightly mentioned, and are in the right place to use all these technologies to the fullest extent. Especially more, there is a lot of push I see from both industrial as well as defense segments. Thank you.
Thank you, Ashish. Now that all the panelists have spoken and brought out the clear nature of the innovative, disruptive, and indigenous technologies that are being put to use in our shipping ecosystem, it's very clear that there is a clear advantage of digitalization and the benefits to be reaped. As the organizers have told me that there is no time for question and answer session, we will conclude the session here. I take this opportunity to thank all the panelists for bringing out very clearly their respective areas of expertise. Thank you. Thank you very much.
Thank you, esteemed panel members. With so much development coming up in the field of artificial intelligence, disruption, and digitalization that we are yet to explore, the future really seems exciting for us naval architect. I thank all the panel members in discussion to sensitize us of the topic. Now, I invite panel chair, Mr. N.T. Anil Das, to kindly present mementos to our esteemed panelists as a token of appreciation. First, I invite Mr. Agatish Murthy, Manager, Marine Sales and Business Development, India and Southeast Asia, Cadmatic. Next, I request Ms. Sapna Deepu, Additional General Manager, FDG, Control and Marketing, Mazagon Dock Limited. Mr. Anil Kumar PK, Principal Surveyor, Business Development Manager, South Asia, Lloyd's Register. Dr. VBS Angar, Scientist F, Secretary, NRB, DRDO. Captain Sujit Padhyay, Head of Voyage Optimization, Digital Desk, Synergy Maritime Private Limited. Mr. Anthony Jacob Ashish, Lead of Products and Research, Planes Technologies. Following this, I would also like to invite Mr. Pyarelal Candy, Managing Partner and Director of Operations, Great Waters Maritime LLC, Dubai, to present a memento to Mr. N.T. Anil Das as a token of our appreciation. To commemorate this special session, I invite all the dignitaries on stage to please come ahead for a group photograph. Thank you once again to our esteemed panelists for their valuable insights during this discussion. Now, time for a short break. Refreshment and beverages will be available at the designated areas at both the sites. Look forward to joining you all for some light chats. Thank you. Before I leave, may I mention that after the break at 4 p.m. we'll have 3 combined technical paper presentations which will cover the following topics: alternative fuel pathways and IMO revised GHG strategy, numerical methods for propeller cavitation and noise, how to model your alternative fuels in future. Thank you.
We would like to express our deepest gratitude to all the sponsors of this event, beginning with platinum sponsors, DRDO and Cochin Shipyard Limited, our gold sponsors, ABB, and the silver sponsors, Indian Register of Shipping and Catmatic. We also thank Aries Energy, registration area sponsor, and Class NK, the delegate kit sponsor. Great Waters, delegate badge sponsor. We also thank our associate sponsors, GRSE, Goa Shipyard Limited, L&T Engineering, Zentech Incorporated USA, Warsila, Napa, Naval Group, Alboa D. Damon, ShipTech Icon, and Mazagon Dock and Shipbuilders Limited. Our event partner is Biz Events and media partner is Maritime Standard.
Consistently working on indigenization of defense technologies since its inception in 1958. The motto of DRDO has been Balasya Moolam Vigyana, The source of strength is science. DRDO has been at the forefront of Atmanirbharta in defense, having technical capabilities across the domains of land, air, and sea. Its strong network of 41 laboratories, associated work centers, 5 unique young scientist laboratories are spread across the country. DRDO has developed wide range of strategic and tactical weapon systems, platforms, equipment, technologies, sensors, and has also established state-of-the-art test facilities and infrastructure. The production value of DRDO developed systems inducted or approved for induction stands over rupees 3 lakh crore. Taking forward the thought of Atmanirbhar Bharat, DRDO has been spearheading the indigenization of Indian defense technologies, driving India on the path to pride. DRDO works in 7 different technological clusters, namely naval systems and materials. The cluster provides cutting-edge naval and material solutions for the armed forces. It has developed state-of-the-art underwater sensors and surveillance system, underwater weapons and associated systems, air-independent propulsion systems, protection technologies for marine platforms. High-strength material is also a speciality of this cluster. INS Vikrant is built with the high-strength steel developed by this cluster. Aeronautical systems. This cluster is engaged in the development of state-of-the-art combat aircrafts, unmanned aerial vehicles, aero-gas turbine engine technology, airborne surveillance systems, parachutes, and lighter-than-air systems. Armament and combat engineering systems focuses on research and development of armaments, explosives, land-based combat vehicles, and engineering equipments, including ATACMS, world's longest range artillery gun system, missiles and strategic systems. This cluster is responsible for the design and development of state-of-the-art missiles and strategic systems for the deterrence of the country. Electronics and communication systems, state-of-the-art technologies in the fields of EW systems, radars, sensors, and directed energy weapon systems and communication systems used in various flagship programs and platforms of DRDO. Life sciences, equipping the service with the best. Cutting-edge weapon systems and platforms do not really achieve their intended purpose until the integral human component of the war machine is also optimized in terms of psychological, physiological, and nutritional well-being, with life support systems and protection from all conceivable operational hazards. Microelectronic devices, computational systems, and cyber systems. The microelectronic devices subcluster focuses on thrust areas and technologies relating to microwave tubes, solid-state electronics, including microelectronic device design and manufacturing. The computational systems subcluster focuses on systems and technologies relating to artificial intelligence, command and control, information and communication security, and many more. To develop defense R&D ecosystem and boost indigenous manufacturing, DRDO is supporting the industry through policy of transfer of technology at minimal or zero cost. Now, industry are working with DRDO as DCPP, PA, DP for development of many critical technologies. As of now, 1,550 TOTs have been handed over to industries by DRDO. DRDO has instituted multiple mechanisms and structures for result-oriented collaboration with academia, industry, and think tanks to design and develop next-generation systems. As an ongoing process of creating a DRDO and academia ecosphere, DRDO has established 15 centers of excellence in collaboration with various academia institutes all over the country to develop critical technologies. In addition, DRDO also funds academic research in defense science and technology through mechanisms, schemes like extramural research, research boards, and contract for acquisition of research services. DRDO also funds research under its various grant and aid scheme to undertake research in the fields of aeronautics, armaments, naval and life sciences to strengthen funded research. Technology Development Fund TDF scheme is in place to encourage participation of industries, especially MSMEs, startups, to develop new technologies and products, upgrade existing products, systems, and R&D for indigenization of imported components and systems. To date, 68 projects have been sanctioned under TDF scheme with the commitment of 283 crore. Dare to Dream Innovation Contest to promote innovators and startups are being conducted. 3 versions of contests have been concluded. Potential ideas are funded through TDF for converting to products. DRDO, as the premier technology organization of our country, is working in the pursuit of achieving indigenous development and production of strategic and defense systems, making the nation self-reliant in advanced defense technologies. रक्षा अनुसंधान से आत्मनिर्भर भारत की ओर अग्रसर। जय हिंद। Located on the southwestern coast of India, Kerala is a land with a lush maritime history that dates back to several centuries. Cochin, the thriving port city in Kerala, is the commercial capital of the state and an epitome of Kerala's cultural richness. In 1972, India's maritime aspirations found a new anchor as India's port city. Cochin became the birthplace of Cochin Shipyard Limited. Nestled in Cochin's heart, CSL's sprawling 176-acre facility boasts of world-class shipbuilding and ship repair infrastructure, from state-of-the-art 3D modeling softwares, large dry docks, long waterfront with jetties, machinery and equipment, everything essential for a HSE-compliant one-stop solution for the industry. CSL's portfolio of an extremely wide variety of vessels is a testament to its versatile, adaptive and flexible culture and capabilities. It offers the full spectrum of shipbuilding, ship repair and vessel conversion related solutions. CSL added yet another feature to its cap when it built INS Vikrant, India's first indigenous aircraft carrier, which was commissioned into the Indian Navy in 2022.
यदि लक्ष्य दुरंत है, यात्राएं दिगंत है, समंदर और चुनौतियां अनंत है, भारत का उत्तर है विक्रांत।
CSL's golden flag flutters proudly, celebrating 50 years of maritime excellence. CSL's renewed focus seeks sustainable horizons aided by technological innovations for a cleaner, brighter future. The yacht's clientele footprint spreads across the globe, having delivered numerous vessels to clients in the US, Europe, Middle East, and other countries in the region. CSL's geographical expansion initiatives have resulted in the setting up of ship repair business units in Mumbai, Kolkata, and Port Blair, thereby making CSL the only Indian yard offering direct professional services with dedicated infrastructure on both the east and west coast of India. Wholly owned subsidiaries companies, Udupi Cochin Shipyard Limited on the west coast and Hooghly Cochin Shipyard Limited on the east have augmented and enhanced the group's capability in shipbuilding, including on the niche and new technology fronts to a great extent. The new large dry dock and the new international ship repair facility established in Kochi as part of the company's long-term strategy roadmap will significantly augment the shipbuilding and repair infrastructure in India. CSL has incorporated the Strategic and Advanced Solutions Division exclusively to handle and maintain its leadership position on the front of new and emerging technologies. CSL takes pride in being one of the global leading yachts on the sustainable solutions front, having constructed the world's first zero-emission fully autonomous ferries for Europe. as well as being the vessel builder for world's largest hybrid electric urban water mobility service, the Cochin Water Metro, operating in Kerala, in India. The company lays significant emphasis on skill development and runs Vigyana Sagar, its dedicated and self-contained training facility in Cochin. CSL is India's first shipyard to have obtained the CII Greenco Silver rating for its efforts at energy conservation and environment-friendly initiatives. CSL is also the first Indian shipyard with an integrated management system covering safety, health, and environment certified by DNV. With the ethos of Make in India, Make for the World, CSL has recalibrated its sails and set sights on continuing at the forefront of a brighter, greener future.
We are in the middle of transformation. Electrification, digitalization, connectivity, cloud computing, machine learning, and artificial intelligence. Sensors are getting smaller, big data is getting bigger. Augmented reality and virtual reality are providing previously unattainable field of use. And all this is providing unprecedented opportunity to create value and increase the sustainability of the shipyard. Maritime industry represents approximately 2.5% of the world's greenhouse gas emissions. And that number is set to grow with an increase of the global trade. ABB is committed to reverse the trend to take that number down. We at ABB believe that the next generation of vessels will be electric, digital, and connected. Electric because they are more efficient and sustainable, and digital and connected because that will take the productivity and safety of the vessels to another level.
Personally, I think that the Azipod propulsion system is one of the greatest innovations in maritime history. All big ships need something that moves them forward. Azipod propulsion system combines propeller driving the ship and electric motor driving the propeller and a rudder which is steering the ship. For the Azipod unit designs, the sustainability idea and thinking starts already from the design table, that we consider the materials we use, how much we use it, what kind of materials we are using. There are about 400 Azipod units in operation at the moment. Even though the Azipod propulsion system is mostly known from cruise ships and ice-going vessels, it has been installed into more than 20 different ship types. In my opinion, of course, one day I would like to see that Azipod propulsion system is equipped in all the vessels around the globe.
The electric ships are currently representing about 10% of the world's fleet. And to make the maritime industry more sustainable, that number needs to grow. We at ABB are fully committed to reaching that goal. In fact, we just delivered 2 ships sailing between Sweden and Denmark on full electric power, and we were able to reduce the greenhouse gas emissions.
I think it's important as a company to be modern. And to be modern is that you think about the whole economy. And economy is also how much you pollute. Traditional ferries have been fueled by bunker oil. Since 2015, in this area of the world, we have a low sulfur emission called 0.1. This vessel we're on today is from 1992. And the other one that we converted is from 1991. But they are state-of-the-art vessels when it comes to the technology. And And that's what we're very proud of at 4C, is these vessels are designed in the end of the 80s, but still have the newest technology on board. We have the battery power equivalent of 60 Tesla cars. We charge on the Swedish side roughly 9 minutes and 5.5 minutes on the Danish side. We have less noise, we have less vibration, but we also have another important thing, is that the people that are working in the company are very proud that we are first mover in the world with this new technology.
ABB has already started to put batteries on vessels, smaller ferries going from A to B, and we have also taken bigger vessels, like the 4C vessels going between Sweden and Denmark, where they run purely on batteries. I think we will see a transition in both fuel and technology, so we're taking one step at a time. For larger vessels, we see a good potential to have a hybrid power plant. We can cut down on emissions, or we will probably also see these larger vessels powered by renewable power. It's a good potential to cut down on local emissions that affect people where they're living and local communities. And this technology with electric vessels and hybrid vessels is a technology that are available now and can address these issues now.
I think in general sustainability is important for any industry, and of course ABB wants to be big part of that with its electric, digital, connected vision.
I think the industry is going through a big change right now. Being first mover, we can actually show other ship operators that there are possibilities to use the same tonnage as we have today and not going for new builds.
The member states of the IMO, International Maritime Organization, pledged to reduce...
The technical presentation will begin in 5 minutes. Thank you.
We at ABB are committed to that goal and to provide innovations and technology to make that possible.
We would like to express our deepest gratitude to all the sponsors of this event, beginning with platinum sponsors, DRDO and Cochin Shipyard Limited, our gold sponsors, ABB, and the silver sponsors, Indian Register of Shipping and Catmatic. We also thank Aries Energy, registration area sponsor, and Class NK, the delegate kit sponsor. Great Waters, delegate badge sponsor. We also thank our associate sponsors, GRSE, Goa Shipyard Limited, L&T Engineering, Zentech Incorporated USA, Wärtsilä, Napa, Naval Group, Alboa D. Tamman, Shiptech Icon, and Mazagon Dock and Shipbuilders Limited. Our event partner is Biz Events, and media partner is Maritime Standard.
Consistently working on indigenization of defense technologies since its inception in 1958, the motto of DRDO has been Balasya Moolam Vigyana. The source of strength is science. DRDO has been at the forefront of Atmanirbharta in defense, having technical capabilities across the domains of land, air, and sea. Its strong network of 41 laboratories, associated work centers, 5 unique young scientist laboratories are spread across the country. DRDO has developed a wide range of strategic and tactical weapon systems, platforms, equipment, technologies, sensors, and has also established state-of-the-art test facilities and infrastructure. The production value of DRDO developed systems inducted or approved for induction stands over Rs 3 lakh crore. Taking forward the thought of Atmanirbhar Bharat, DRDO has been spearheading the indigenization of Indian defense technologies, driving India on the path to pride. DRDO works in 7 different technological clusters, namely naval systems and materials. The cluster provides cutting-edge naval and material solutions for the armed forces. It has developed state-of-the-art underwater sensors and surveillance system, underwater weapons and associated systems, air-independent propulsion systems, protection technologies for marine platforms, High-strength material is also a specialty of this cluster. INS Vikrant is built with the high-strength steel developed by this cluster. Aeronautical systems. This cluster is engaged in the development of state-of-the-art combat aircrafts, unmanned aerial vehicles, aero gas turbine engine technology, airborne surveillance systems, parachutes, and lighter-than-air systems. Armament and combat engineering systems focuses on research and development of armaments, explosives, land-based combat vehicles, and engineering equipments, including ATACMS, world's longest range artillery gun system, missiles and strategic systems. This cluster is responsible for the design and development of state-of-the-art missiles and strategic systems for the deterrence of the country. Electronics and communication systems, state-of-the-art technologies in the fields of EW systems, radars, sensors, and directed energy weapon systems and communication systems used in various flagship programs and platforms of DRDO. Life sciences, equipping the service with the best cutting-edge weapon systems and platforms do not really achieve their intended purpose until the integral human component of the war machine is also optimized in terms of psychological, physiological, and nutritional well-being, with life support systems and protection from all conceivable operational hazards. Microelectronic devices, computational systems, and cyber systems. The microelectronic devices subcluster focuses on thrust areas and technologies relating to microwave tubes, solid-state electronics, including microelectronic device design and manufacturing. The computational systems subcluster focuses on systems and technologies relating to artificial intelligence, command and control, information and communication security, and many more. To develop defense R&D ecosystem and boost indigenous manufacturing, DRDO is supporting the industry through policy of transfer of technology at minimal or zero cost. Now, industry are working with DRDO as DCPP.
Our deepest gratitude to all the sponsors of this event, beginning with platinum sponsors, DRDO and Cochin Shipyard Limited. Our gold sponsors, ABB, and the silver sponsors, Indian Register of Shipping and Catmatic. We also thank Aries Energy, registration area sponsor, and Class NK, the delegate kit sponsor. Great Waters, delegate badge sponsor. We also thank our associate sponsors, GRSE, Goa Shipyard Limited, L&T Engineering, Zentech Incorporated USA, Wasilla, Napa, Mineral Group, Alboa D. Damon, Shiptech Icon, and Mezagon Dock and Ship Limited. Our Indian partner is Biz Events, and media partner is Maritime Standard.
A small announcement. As we are about to begin technical presentation, I request all delegates to come back to a manhole. Thank you.
Okay, nice. Working.
Ladies and gentlemen, I hope you all have enjoyed the tea break and had a chance to connect with others. As we are about to resume, I kindly request everyone to please return to your seats. We will now move on to our technical presentations. I invite our presenters to please take their seats on stage. The final event of our seminar is surely going to be really interesting. Now we begin the first round of technical presentation. Each speaker will present for about 15 minutes, followed by 5 minutes Q&A session. Warning bell will be rung to cue the speaker at 13th, 15th, and the 20th minute. Our first presentation is Alternative Fuel Pathways and IMO Revised GHG Strategy by Dr. Abdul Rahim, Chairman of NAPA Group and Advisor to Class NK. Over to you, sir.
Can I start? Yes. So the last session, you all may be a little tired, so I won't take much of your time. Let's go ahead. Today I'll be talking about alternative fuels and what is aimed for and where we are now. If you look at the IMO, in 2023, they have cleared the EXA and CAA regulations. And then in July, they have revised the new IMO greenhouse gas strategy, and also they started developing LCA guidelines. And by end of this decade, we'll be having midterm measures in place. If you look at the revised IMO GHG strategy, if you look at the red lettered ones, these are the revisions. In 2030, compared to 2028, we have to reduce the total annual GHG emissions by at least 20%, striving for 30%. And there's an intermediary stage at 2040 to reduce the total annual GHG emissions by at least 70% and striving for 80%. And by 2050, we have to reach net zero GHG emission by or around 2050. Now, let's look at the timeline for specifying, for the adoption of specific midterm measures. There are two types of measures. I'll come to it in the next slide. That's technical elements as well as economic elements. And a comprehensive impact assessment is also to be made. And this is the timeline. In autumn of this year, the comprehensive impact assessment will be completed, and the midterm measures will be approved early next year, and end of next year, the midterm measures will be adopted, and within 2 years, by 2027, they will be implemented. And these are the two types of measures, economic measures and technical measures. And economic measures are mainly about carbon taxes. There are different proposals. So Japan is proposing fee-based, and Marshall Islands and Solomon Islands are proposing GHG levy, and the International Chamber of Shipping is proposing funding and reward. And coming to technical matters, it's mainly the EU countries, Norway and European Commission. They are going for the GHG fuel standard, and China is proposing International Maritime Sustainable Fuel and Fund. So conversation is ongoing, and by 2025, we know which will be implemented. Now, coming to LCA guidelines, the main difference here is from well to wake. Previously, it was tank to wake, but now the whole scenario is changing. It's from well to wake. And the LCA guidelines are to be developed as freestanding guidelines, and it should refrain from suggesting amendments to existing IMO regulations such as CII in developing LCA guidelines, because CII developers, there are a lot of problem. So the new guideline should not interfere in that one. In case CII is calculated based on well to wake, then a separate discussion will be necessary at IMO to implement this. Now look at the number of alternative vessels we currently have. As of last month, end of July, according to Clarkson's data, 1.3% of the vessels run on alternative fuels. It's a very minuscule percentage. But if you look at the order book, as of today, about 22% are ordered to run on alternative fuels. That is, it's picking up. A moment when it's picking up, still not enough. Now let me go into a little bit detail about the new revised strategy. As you can see, it is net zero by 2050 and well to wake, as I already mentioned, that's the entire life cycle GHG emission is considered. Then by 2030 and 2040, there are 2 checkpoints, at least 20% and at least 70%. And then the uptake of zero or near zero GHG emission technologies, at least 5%. By 2030, striving for 10%. So now you may ask, what does this actually, these numbers, what is their physical significance? So what are the allowable emissions in terms of numbers, and to what extent zero emission fuel and zero emission ships we need to have? So Klassen has carried out a detailed study, and in October 2023 we issued a white paper answering all these questions, and you can download it from our website, so I'm not going into details, but I will just update some of the results. So here, they mentioned before, these are the indicative checkpoints. So we have calculated the allowable GHG emissions to achieve the 2030 and 2040 checkpoints, and also zero emission fuels, the amount required, as well as the number of ships needed to achieve these targets. And here we have made assumptions of ships about 5,000 gross tonnage and above in international voyage. And we are assuming that the marine transport volume will increase by 25% by 2030 and 39% by 2040. And the carbon intensity is also will also improve to 23% and 30%. So here you can see this is the estimated upper limit of allowable life cycle GHG emissions in international shipping to achieve it. As you can see here in 2021, the latest, the GHG emission is 798. Whereas in 2008 base year, it's 731. So instead of going down, we already went up. So the percentage decrease from hereafter till 2030 and 2040 is much higher. So that means to achieve the 2030 indicative checkpoint, we need to, if you're assuming 20% reduction, it should be 585. And by 2040, it should be 219. So that means if you look at the 2031, instead of 20%, we need to have 27% reduction compared to 2008 to achieve the IMO targets. Now, if you look at the zero emission fuels and ships needed, as you can see, if you're assuming the 5% fuel emission level, we need, if it is green methanol, we need 21 million tons per year. And if it's green ammonia, we need 23 million tons per year. But if you look at the far right, the current rate of production is maybe 20,000 tons. So instead of 21 millions, currently they are producing only a fraction of that 20,000, both green methanol and green ammonia. And if you're coming to the zero emission ships, the total amount required to consume this much green fuel is 72 million gross tonnage. And if you look at 2026, the order book is just 12 million gross tonnage. That is the number of ships that can run on alternative fuels. That means from 27 to 2030, we need 15 million gross tonnage per year of zero emission ships to come out. So at this current rate, it is difficult to achieve that. So that means only a 5% introduction of zero carbon fuel in 2030 makes it difficult to achieve the indicative checkpoint. Now, let's compare against the 2030 and 2040 indicative checkpoints. If you look at the 2030 indicative checkpoints, we need 25% of green methanol and 106 million tons of green methanol and 114 million tons of green ammonia. Again, the current production level is only 20,000 tons each. So we are finding it very difficult. So that means to achieve the numerical targets, a substantial amount of zero emission fuel is required. That is, prompt investment promotion is necessary, and early adoption and implementation of a regulatory framework will be required to enforce this. Otherwise, the IMO, the checkpoints cannot be completed. So that means we also need to secure new building and retrofit capacity. So new building ships with alternative fuels and also retrofit the ships with alternative fuels. So that means a collective effort of all the parties involved is necessary. Now let me briefly go into the alternative fuels that we are considering. There are different pathways, and so I'm taking up 5 of them: hydrogen, ammonia, then E and biomethane, methanol, and diesel oil. The pros and cons are there, and hydrogen and ammonia, we can expand the supply somewhat easily. And methanol and diesel oil, it is easy to handle because it's liquid at room temperature. And the cons are, for hydrogen, you need a large tank volume, maybe 4 to 5 times that of heavy fuel oil. And for ammonia, of course, toxicity and low flammability. These are some of the things that we have to deal with. And methanol and diesel oil, the supply will be low because if all the ships are being converted, you don't have enough fuel to supply. Now let me go into some of the projects that is ongoing in Japan. This is the first ammonia-fueled, directly injected ammonia-fueled tugboat in the world. And it will be delivered next week in Japan, and it will be plying in the port of Yokohama. And the participants are the IHI Power Systems. They will be developing the 4-stroke main engine. And the ship design and building will be done by NVK. Operation will also be done by NVK. And Class NK will be doing all the safety assessment and fundamental research to produce the guidelines. And as I mentioned, this tugboat will be delivered next week. The next one is the ammonia-fueled gas carrier. It's in collaboration with the NVK Line, Nihon Shipyard, Japan Engine Corporation, IHI Power Systems, and NK. And the land-based 2-stroke ammonia engine test has been ongoing since May. It's almost completed. And you can see the test setup on the far right. And here, the Japan Engine Corporation will do the main engine. It's a 2-stroke main engine, and IHI Power System will be developing the auxiliary engine. And ship design and building will be done by Nihon Shipyard, and NVK will operate it. We expect the delivery to be in 2026. And now the work is ongoing. The next one is ammonia-fueled bulk carrier. Here the partners are Itochu Corporation, Nihon Shipyard, Mitsui, K-Line, and NS United Kaiun. And the basic design of a 200,000 deadweight bulk carrier has been developed. It's again looking for delivery in 2026. Here, this is mainly funded by the Green Innovation Fund in Japan. So somebody before mentioned that in Japan there is a massive funding available for green projects as part of their commitment to be net zero the whole country by 2040. So Itochu Corporation and Nihon Shipyard, they are partnering in shipbuilding, and the shipping will also be done by Itochu in collaboration with K-Line and NS United Kaiun. And the entire bunkering operation will be done by Itochu. Mainly they'll be sourcing from Japan, sourcing from elsewhere, and the bunkering ports will be Japan and Singapore, and also some other ports they will gradually expand. The next one is the hydrogen-fueled ship. This is again hydrogen direct injection, not hydrogen fuel cell, and the engines are currently being developed. The Kawasaki Heavy Industries is developing a 4-stroke middle-speed hydrogen-fueled engine. It's a 2,000 to 3,000 kilowatt engine. It will be the auxiliary power generation for the liquefied hydrogen carrier. And this liquefied hydrogen carrier is a 160,000 cubic meter ship being done by Kawasaki Heavy Industries. It will be coming out in maybe 2 to 3 years. Yeah, as you know, the first prototype of liquid hydrogen carrier was delivered 3 years ago, and that is currently running, and we are collecting data on that. And that will be going into this one. This is again, that one was the first in the world, and this is possibly going to be the second in the world. Then Myanmar is making a 4-stroke high-medium speed hydrogen-fueled engine. This will be used for the auxiliary power generation of a coastal tanker. And the Japan Engine Corporation, they're developing a 2-stroke low-speed hydrogen-fueled engine. It is for to use on a small bulk carrier. So a lot of parties are developing simultaneously different types of engines for different use. Now, in the morning also, we were discussing about carbon capture, because the majority of the ships delivered today run on fuel oil, low sulfur or heavy fuel oil. So they have to run for at least 20 years. So even to meet the 2040 targets, it is almost impossible. So that means many of the ship owners might be opting for carbon capture. So this is the world's first carbon capture device that we have tested about, I think, 3 years ago in collaboration with Mitsubishi and K-Line. So on the photo shows the test setup at the aft of the accommodation area. So we have set up, and we have completed the feasibility study. So technically, it is feasible. As of now, economically, it's not viable. So this we have to sort out. But currently, quite a number of companies are coming up with new devices that is using carbon capture technology. Maybe in the near future, the technology will be mature enough to use on board ships. Because on the land, for power plants and all, we have been using it for maybe decades. So the technology is okay. Only thing is that you reduce the scale and put it on board the ship. And like other societies, Klassen is also offering transition support services. So if you have anything related to alternative fuel support, energy efficiency improvement, onboard CCS support, we have the systems to do that. And there are quite a number of guidelines available in our website. So if you want, you can go and download it. So that means what I want to tell you is, to achieve this 2050 target by IMO, at the current rate, it is impossible. So that means all parties have to collaborate, the governments, the classification societies, the shippers, shipbuilders, engine manufacturers, suppliers, ship owners, financiers. Everybody has to come together and pull together to make this happen. Then only it will happen. Then only we can achieve the goals set by International Maritime Organization. So with this, I would like to conclude my presentation. Thank you very much.
It is now time for the Q&A session for our technical presentation. Please feel free to ask any question you may have about the presentation.
We know we are falling far short of some of the targets, as you mentioned, especially the interim targets that IMO has set. Are there any probability studies done based on where we are today and what we are doing today as to what is realistically achievable by then? Are there any broadly? Yes or no answer would do for now. We can look into what the details are later.
Yes. Feasibility study has been carried out, but I don't think it is in the open domain as of now, because it will be contrary to the IMO's guidelines. So feasibility study has been done, and we know up to a certain extent what to be done to mitigate the delays.
Okay. Good afternoon. My name is Mohammad Abrar Saifuddin,
And from my small understanding, I understand that not only maritime industry, the whole wide industries like heavy industries, aviation, everyone is going towards decarbonization. So, will there be any supply chain shortage for the fuels? Let's say an owner is trying to change into LNG or ammonia right now, and down the line, if all other industries are going towards these fuels, will there be any shortage of supply for the fuels? And do we have considered this type of matters right now?
That's a very good question, because the whole amount of fuel available is for the entire industry. So maritime industry will get only a small percentage of that. So if you come to methanol, the priority to give it to maritime industry is very low. So unless the shipping companies, say for example Maersk, they have arrangements with 4 or 5 makers around the world to produce and supply. Unless that kind of arrangement is done, it will be very difficult for the maritime industry to get enough fuel. That is also one of the problems, yes.
Yeah.
We have time for one more question.
Mahesh here from ABB. So in your slide, you mentioned about the new vessels which is built on hydrogen-based engines, and I am assuming that's a ICE engines technology. So, but when you see ICE engine, when hydrogen fuel cells are available, ICE engines at low speeds, the efficiency is quite poor. So, what is the driver to go for the conventional technology when hydrogen fuel cell technology is available?
The simple answer is scale. Hydrogen fuel cells are applicable for smaller vessels on short sea routes, so they frequently charge the fuel cells. Whereas when it comes to the big vessels, hydrogen fuel cells are not sufficient to propel them. So that's why we are using the engines where we can directly use hydrogen to produce enough power. That is the reason for this development.
Okay, because we are also working on hydrogen fuel cells. The base module may be 200 kW, but there is a possibility to scale up to 3 megawatt. But I saw it's a bigger power. That's why, yeah.
Yes. Here the auxiliary is may need about 1,000 to 2,000 kilowatt, even the auxiliary. So main engine, for a bigger ship, it can be much higher. So the fuel cells, if you put it in the ship, that takes a lot of volume, plus the energy density coming out won't be sufficient enough to propel that one. That's the reason.
Yeah, thank you, sir.
We will conclude the Q&A session now. Please feel free to continue discussion with Dr. Abdul Rahim during the breaks. Thank you, sir, for charting a course through complex landscape of alternative pathways and IMO regulations. We are grateful for your participation and expertise in today's presentation. Our second presentation is Numerical Methods for Propeller Cavitation and Noise by Mr. J. Ramkumar, Senior Surveyor at IR class. Just a minute. Over to you, sir.
So hello, good evening everyone. I'm Ram Kumar from Indian Register of Shipping. So today I'm going to talk about numerical methods that are available for modeling propeller cavitation, and I'll give a brief introduction about noise, both near field and far field noise estimation. So the topics that I'll be covering are introduction to noise, and what are the various sources of noise in the context of vessel. Okay. In the context of vessel operation, and then I'll be talking about propeller noise sources and what is the importance of numerical estimation of propeller noise in the design phase and how cavitation plays a role in that. And then I'll be covering mostly about types of cavitation in propeller. And then we will be talking about a validation study that we have performed to numerically estimate propeller open water characteristics as well as numerically model cavitation. So, and then I'll be covering about the near field noise, which the workshop talks about, and then I'll be talking about the far field noise estimation methods. So coming to the noise sources, this is a vessel wherein the initial noise that we see is the flow noise. This is mostly due to the turbulent flow surrounding the vessel. The turbulent pressure fluctuations act as a noise source. And the secondary noise is the splash noise. Because of the wave breaking, the bubbles are generated, and these bubbles, when they pulsate, generate a noise, and then they implode. This lead to a noise source. These two are generally the high frequency noise sources. And coming to the low frequency noise sources, mainly due to the CMM, that is the critical machinery coming from main engine, the noise transmits. The main sources of noise are the CMM machinery, and then my topic of interest here is the propeller noise. How the propeller noise is critical in the overall sound signature of a vessel. So coming to the broad sound spectrum, here we can see noise spectrum, I can say. So the propeller noise is broadly classified as tonal noise, which is a function of the RPM as well as the number of blades. This is mainly due to the interaction of the propeller blades in the wake field, wherein the periodic flow is coming onto the propeller. And the secondary noise source, which is of importance, is the broadband noise. This is mainly because of the incoming, this is because the interaction of the propeller with the flow. So it would be mostly the tip vortex cavitation, tip vortex noise, and the resulting turbulent noise that we can say. So here we can see this is so this is what we can see. This is a tonal noise. It is a function of blade pass frequency, and this is the radiating broadband noise. So let us take the case of cavitation. In the cavitation also, we will see these two types of noise. One is a tonal and the broadband noise. The broadband noise in cavitation is mostly because of the cavitation bubbles, which try to implode and pulsate, and resulting in a higher frequency noise. So we are going to talk about how we numerically model propeller noise as such. So this is a typical propeller, wherein this is where the tip vortex cavitation happens, wherein the pressure inside the tip vortex, if it drops below the vapor pressure of the liquid, so leads to cavitation at the tip. And this is a Boss cavitation because of the low pressure zone at the Boss hub, which would be leading to a loss in pressure, negative pressures behind the hub, which, if they drop below the vapor pressure, would lead to cavitation. The major source of cavitation in a propeller is due to the sheet cavitation, which we can see here. So this is because of the high angle of attack that the propeller leading edge would be facing. And the cloud cavitation, this forms at the collapse of the sheet cavitation. And here, when this bubble cloud implodes, which would create damage to the propeller, and this kind of cavitation leads to loss in thrust. And the final one, which is the root cavitation, which is highlighted at the blade root. This is mainly due to the flow recirculations and formation of negative pressure at the root. So coming to the available numerical methods which are there for us are the higher order method, that is a Rayleigh-Placid model. This is a Rayleigh-Placid model. This is a second order model wherein R double dot or R, the radius of the bubble with variation in time can be calculated using this formulation. Here in this model, the major considerations are the fluid viscosity, kinematic viscosity, and the surface tension. The major assumption also is the bubble modeling is performed. The bubble modeling is considered as, bubble is assumed to be spherical. And coming to the lower order model, which is the Schorner's-Orr model, this is the first order model, wherein the major assumption is the higher order R double dot is neglected, whereas the kinematic viscosity is neglected and the surface tension is neglected to find the radius of the bubble. So here what we consider is, rather than a single bubble, we consider it as a distributed bubble. So this model is widely used in the industry to estimate cavitation, and it is computationally inexpensive when compared to Rayleigh-Plesset model. So what we did here was we considered the case of SVA post-stamp test case propeller. The objective of this workshop was to estimate propeller open water characteristic, like thrust coefficient for this propeller, wherein it is inclined at end shaft axis of 12 degrees. And the objective here was to numerically to experimentally model cavitation in the cavitation tunnel. And the secondary objective here was to estimate the pressure pulses. So the pressure probes are created above the propeller here, wherein the time history of pressure pulses are computed in experiments. So this is just a top view of this workshop wherein the propeller is shown here. So the pressures are measured at probes highlighted here. So this is the inflow velocity, this is the suction side, and this is the pressure side. Here open water simulations are performed. So what we try to do is we try to numerically model the same propeller, wherein the diameter of the propeller is 250 mm. So this is how the propeller looks like. So in the numerical assessment, we used a sliding mesh interface technique, wherein we have exactly replicated the cavitation tunnel. Here we can see the blue color, which is indicating the stationary domain, and the rotation of the propeller is given at this interface. We have used a sliding mesh interface technique for modeling the propeller rotation here. So this is how the propeller would look like. So we have created some mesh refinement zones where our area of interest is to find the pressure pulses here. And we wanted to numerically model the tip vortex formation. So we have created refinements at the tip vortex. So this is a typical sectional view wherein we can see how the tip vortex refinements have been performed. So coming to the results, this is how the animation would look like, the shedding of the tip vortex. So this we have performed using a DES simulation. So this is a test case wherein initial assessments we have performed using a RANS model, wherein the thrust coefficient is compared with experiments. With using a RANS model, we have an the accuracy close to 2%, wherein using a higher order model, that is the detached eddy simulation model, which is a combination of RANS in the near field near to the propeller, whereas in the zone above, away from the propeller where these eddies are dominant. So these eddies are, rather than modeling, we have tried to resolve these models. This is a higher order model and it is computationally very intensive. So we just tried with this case to see how these DES models are faring with the RANS simulations. So using a DES, we could get a result close to 0.7%, which is under 1%. So in this workshop, there are other participants from Chalmers University and University of Texas Austin and SSPA. So our results were very close. Our results of DES, in fact, were very close with experiments, whereas our results from RANS are next to Chalmers. So this is the case for non-cavitating, wherein thrust coefficient is estimated. So the next, I'll be talking about the cavitating case, how we are getting how we are close to the loss in thrust due to cavitation using the numerical methods. So this is an animation which indicates the sheet cavitation, the highlighted blue zone. So this is how our results are. We tried here 3 different methods. One is using RANS, wherein our deviation was around 25% with experiments. And we tried with the DES as well, which was also deviating by around 23%. We tried with a highly complex model of LES, wherein the near wall physics is resolved, whereas even at the far away from the wall, the eddies are numerically resolved. So this took almost 2 weeks time to just solve for 5 propeller revolutions. Still, we find the results are deviating by around 20%, even after using LES model. So the model that was used for cavitation in this case is a Schorner-Sauer model, which is an lower order model, wherein the bubbles modeling is being assumed as not there. Instead of bubble modeling, we model it as sheet. The bubbles are modeled as sheets. So this is how we can see the sheet cavitation on the propeller blade. So when compared with the results for the other participants of the workshop, our results were close to Chalmers, wherein they are also in a deviation of around 17%. So even what we observed was all the participant results were deviating by around 20%. This is the reason behind is the modeling of cavitation using the Schorner-Sauer model. So we are on the task of using the Rayleigh-Placet model, which is an highly nonlinear and a complex model, wherein the surface tension effects are also to be considered. This model we are trying, but we are facing issues of convergence while running for the Rayleigh-Placet model. So the next stage of this workshop was to estimate the near field pressures. So near field sound pressure. So what they have done, we are showing the results of the pressure probe 2, wherein the time history of the pressures are converted to sound pressure levels. This is an experimental plot, how the sound pressure would look like. So the peak pressure was occurring at a frequency of around 100 hertz, of an intensity of 163 dB. So our results of RANs were deviating by around 14%, whereas with DES, our results were close to around under 2%. So now coming to the case of near field pressure fluctuations for case of cavitation. So this is how the experimental results were. And our RANs results were deviating by around 15%. DES and LES, which we tried upon, were close under 1%. So coming to the conclusions with regards to cavitation. So the cavitation phenomena as such, if it is our interest to model, then we can verify using the Schorner-Sauer model, which is a lower order model. Even with RANs, we would be able to find out whether the propeller is cavitating or not. So sheet cavitation can be modeled using the Schorner model. The other types of cavitation like bubble and tip vortex cavitation and face or root cavitation are not modeled using this Schorner model. If our area of interest is to find out what is the loss in thrust precisely, then we have to use the higher order model. So coming to the sound pressure levels, LES and DES models are more appropriate to calculate the fluctuating pressures. If fluctuating pressure is our interest, so then in that case, RANS model would not stand good. So we have to at least use a DES model. So coming to the alternate methods, so here whatever methods I have with regards to noise, I have talked about the near field sound pressures. If our area of interest, generally the noise is measured at far field and it is converted back to 1 meter distance. So the available methods for modeling the far field noise are the famous FWH method, the Fox-Williams-Hawkins method, wherein the sound generating source, let us take the case of a propeller. Here the sound generating source is a surface. So the sound is radiated in two terms, that is loading as well as thickness. In loading, the sound is radiated in terms of a dipole, wherein it is mainly due to the force distribution on the propeller surface. Whereas thickness is a monopole term, the sound would be radiating in terms of a monopole. This is mainly due to the flow disturbances caused because of the rotation of the propeller. So the other term, the quadruple term, which is a volumetric term, wherein in the quadruple term, the sound is generated, the sound sources are inside the quadruple volume. This is mainly applicable for high-speed flows, wherein mostly for jet noise, wherein the Mach number is higher. So coming to the alternate methods, there is another method called boundary element method. So what we do here, the fluctuating pressures that are calculated using CFD are mapped onto a surface model. So here what we did, the fluctuating pressures on propeller as well as hull. These are the two radiating sound surfaces. So we have mapped those pressures and we have tried to radiate this sound, these pressures to far field. So typical example, typical results which we are showing here are, these are the blade pass frequencies. We can clearly see using a BEM model, we can easily calculate the 3 peaks of BPFs and the broadband noise as well. The decay of the noise also we could see here. I have just overlapped a machinery noise in this case just to amplify like how the propeller noise is critical even at low frequencies as well as at higher frequencies. So here I have considered machinery noise as well as propeller and hull as a radiating surface. So this is a typical plot of sound radiating to far field. On your right is hull and propeller as radiating surfaces. On your left, it is only propeller being a sound radiating surface. At a frequency of around 25 hertz, I have created an animation to just to visualize how the sound would be radiating to far field. In the case of propeller being a noise source, and in the case being hull being a noise source. We can see an animation, another animation for higher frequencies, say around 50 hertz. So here we can see propeller being a dominant noise source, and here we can see propeller as well as the hull. So some sound is radiating from the hull as well. So just I try to cover on what are the various sound, numerical analysis procedures that are available to us. So that's it from my end.
It is now time for Q&A. Please feel free to ask any question.
I'm Dr. Ebenezer from the Department of Ship Technology. How many million cells did you use in your RANs and in your DES, LES? And what's your YWAL plus?
Sir, in RANs, for the propeller, open water simulations, our mesh count was somewhere around 3 million, I can say, for RANs. For DES also, we haven't quite changed the mesh as such, because the near field, the near wall modeling has been done using RANs. Only the ADs that are resolved away from the propeller are being modeled to the scale of the grid.
And what's the software that you used?
We have used Star CCM for this, and we have done some simulations in OpenFOAM as well.
Okay.
We have time for one more question.
Commander Makar here. This was regarding the non-cavitating propeller. You had shown RANs and DES comparison, and there was a reduction to 0.7% error. In your experience, do you feel that to go for an advanced simulation like DES is worth it when RANs is giving a fairly single-digit error?
Yeah, the main objective of my presentation was to emphasize on this part. Thank you for that question. So, if our interest is only to estimate thrust coefficients or torque coefficients, RANs is good to go. We can see our results were fairly under 2%. Whereas if our interest is to find out sound pressure fluctuations, so for that, at least a DES model should be used.
Understood. Yeah. And is there a possibility, the next slide, you had an error of around 17%. Of 20, of the order of 20.
For cavitating case.
Yes. So is there a possibility of probably tweaking your turbulence model in RANs and bringing this error down, or that was it flattened out?
Yeah, for the case in experiments, what we could see here, the major, one of the major source of cavitation was bubble cavitation as well, and the tip vortex cavitation, which was the major source for reduction in thrust. So that is where our results were deviating. So the answer is we are working on Rayleigh Plesset model, which is an higher order model wherein the bubble modeling is done, as well as the fluid kinematic viscosity is also considered in modeling bubble dynamics. So that is where we will be able to match our results, or we will be coming close to the experiments. So the work is ongoing. It is highly complex and non-linear. So we are facing the what you call convergence issues with that. We are working on that.
Thank you.
We will conclude the Q&A session now. Please feel free to continue discussions with Mr. J. Ram Kumar during the breaks. Thank you, sir, for diving into the complex world of propeller cavitation and noise. Your presentation was a valuable contribution to our understanding of cavitation and noise estimation methods. Our third presentation is How to Model Your Alternative Fuels in Future by Mr. Manoj Kumar Sanjana, Associate Vice President at NAPA. Over to you, sir.
I hope everybody can hear now. Good evening. Being the last presentation, I don't want to take longer time. Okay, my name is Manoj. Manoj Kumar, I'm working in Napa, India as an Associate Vice President. And today's topic is about how to model your alternate fuels. Okay, there are so many alternate fuels we are discussing today, and in this presentation I have also my co-authors who are sitting in Finland, Janne and then Joachim. They have supported me during this simulation process. But let's get into the presentation. First of all, thanks to Dostas and then also Dr. Rahim, because he made my presentation a bit lighter, because he gave some intro on the IMO regulation, which we are going to discuss on this part. As earlier discussed, IMO has revised its regulation part, and net zero is what we are talking in 2050. And this becomes very critical for the shipping industry. There are also other parts which needs to be considered. The supply chains, and then fuel not available in the bunkers. All those things are there. Challenges are there. But considering the existing cases, we are now discussing this presentation. So what happens in the future is there won't be any changes in AD regulation, but there will be changes in EXI and then CI and then SEAM regulations. And there will be midterm measures which will be taken into consideration and which will come into force in 2027. That is the plan. And there are also, apart from IMO regulations, there are also EU regulations which are going to come into play, and also country-specific regulations. Okay, and there was a bit of uncertainty based on these emissions to make some decisions, but I think with the newer regulations, as you can see, these are becoming more clearer now. I'll be discussing a couple of alternate fuels, mostly available in the market, and there are what kind of pros and cons what we have at the moment. We have LNG, which is being used in the industry in the midterm and then short term. But as you can see, there is also methane slip problems, where which can cause also GHG emissions problems more than your CO2. There are engines being developed, MAN and then Wärtsilä, and then of course we have also seen from Dr. Rahim's presentation that other engines are also being developed to reduce this methane slip part. Then from DNV alternate fuel insight, it is clearly evident that there are a lot of LNG fuels which are ordered. At the moment, as you can see, there are 1,058 confirmed LNG fuel ships. And in the global rating, as you can see at the left bottom, there is the current situation and then and the future operation, what will happen here. Then the next case which we are discussing is about methanol. Of course, it will have a considerable effect if you can produce it from renewable energy. But and then NOx emissions are also reduced by 30%. And during our discussions, I also learned that Maersk has ordered around 25 vessels on this methanol-based fuel. Of course, there are challenges again when we are talking about tanks and also ship design considerations. The density, because of the density, it needs around 2.4 times more volume than the regular fuel. And then, of course, expensive than LNG. Then this is the current scenario from, again, alternate fuel case for methanol from DNV. And this is the current order at the moment. Currently, there are 18 confirmed methanol orders at the moment. Then we have ammonia, which is again a favorite thing, looks like, because a lot of vessels are being ordered in this case. Of course, there are also challenges in this case. But before that, if we discuss, ammonia is already used in the agricultural part. So it is the transportation and then storage system is already available. So that's an added advantage. Of course, precautions needs to be taken because when it burns at a lower loads, nitrogen NOx emissions are higher, and then it can also cause issues. And of course, e-ammonia needs a refrigeration, which will also reduce your cargo space further. These are your, again, orders, what you have at the moment. Then we have hydrogen. There is no carbon dioxide emission. Of course, there is no SOx emissions, but there are NOx. And then, but again, there is a challenge here because of the temperatures which needs to be maintained, cryogenic temperatures. And then again, the volume constraints are really high when it comes to the design constraint, because you're also losing your cargo here to accommodate these huge fuel oil tanks. Again, this is highly flammable, so some kind of precautions needs to be taken on board, and then transportation and storage and other things needs to be in place. They are still in development. Hydrogen fuel cell vessels are already there. A couple of vessels are already there in the market, but as a hydrogen with the internal combustion engines, we have approximately 10 vessels. Right. So overall, if we look at the current scenario, 99% of the conventional ships are running on the fossil fuels. Okay, and the future order, if you look at it, then it is around 82% will be running on the fossil fuels, and then 18% are the alternate fuel ships. Right. And what we did as a team in Finland from Napa, is we considered few of the fuels on a demo vessel, and then we did a simulation by considering different fuels, and then we checked how much fuel we can save, and then what are the CO2 emissions, what are the CI ratings in this case. Okay. This simulation involves one bulk carrier, which is of around 230 meters length, and then we considered 3 different vessels, low sulfur fuel, and then methanol, which is of 50% gray methanol, and then 50% green, and then ammonia as well as a fuel. And we did 21 times simulation back and forth, and the vessel is going from Goa and then Turkey. The trade is happening from there for the ore carrier. This is an assumption, by the way, and then by considering the real sea conditions, what we did there, right? And in the previous slide, just want to let you know that there are the weather condition is considered for 1 full year. So it is considering from 1st of January 2023 to 1st of January 2024. So all the sea conditions, so you have your weather data, you have wind, swell, okay, all the directions is considered during this simulation process. So what we have learned in the previous cases or the slides, what I've explained is once you are changing your fuel, then you're also compromising your cargo capacity. That means you need higher fuel tanks. So for a low sulfur fuel oil, it is lesser, and then slowly it's gradually increasing from methane and then ammonia. And then yearly carbon dioxide emissions, if you look at it, of course, the low sulfur oil is emitting higher compared, and then followed by methanol and then ammonia, this case. And then when we calculated for 2035 yearly OPEX calculations, then of course the fuel oil consumption for a low sulfur fuel would be somewhere around 7.5 million euros, and then there is ETS cost, and then fuel EU cost, all those things are there. And then the next one comes to be methanol, and then which is yearly consumption is around 26 million, and then the next one is 43 million for ammonia. And when we consider the CI ratings, remember if you remember, we were considering methanol 50% gray and then 50% green methanol, right? And then ammonia, and then the third one is low sulfur fuel. Ammonia seems to be a winner here in this case. As you can see, it is consistently doing in A rating, and then after 2039, your methanol is going out of D rating. And then whereas your low sulfur fuel is already out of D rating. Okay, and here there is no CI rating fixed, but what we have considered here is 2% increase after which is decided. So after every year it will be 2% increase. So this is the simulation. Of course, there are challenges if somebody wants to also migrate to these alternate fuels. Okay. There are today, if we are talking about alternate fuels, you need to have a dual fuel, right? And the engines are also being developed now. We are in the transition phase, of course. And then one possibility could be, or the naval architects in the challenge would be in the general arrangement, where you need to arrange your fuel tanks. One possibility is shown over here. The other possibility is having tanks on the aft side, on the deck. That is another possibility where you can use it. All right. Then coming to the conclusion, there are local and then global regulations are tightening. And then, of course, based on these regulations, the stakeholders will also have an idea where to invest and then how to improve this supply chain management. Methanol seems to be mid and short term, and then also a long term alternatives for this one. But however, we would suggest maybe the green methanol is a good option in the long time, because in the study what we have learned is after 2039, if you are using this combination, it will go out of the rating. Then ammonia is also another strong contestant here, and then for long term we can use this. Of course, the regulations and then precautions need to be taken because of the toxic nature, and also the fuel oil tanks needs to be modified from the design concept. Where we are talking about fuel shortage of fuels, and then also we have to think about relative OPEX costs are going to increase because of these alternate fuels, because these are not coming cheap. These are coming at a cost, and then also we have to look into the aspects of cargo part, which we are losing because of the cargo tanks, the fuel tanks, right? There is a compromise between these two things. And emissions, it also becomes economics when we are talking whether you want to convert, completely. Of course, the regulations are in place, but the ships are going to be more fuel efficient by considering these energy-saving devices in future. So that is also one more aspect what we want to discuss. Clearly, decarbonization, there are risks, but also it comes with rewards, for the first movers. Yeah. Thank you. I'm on time.
It is now time for Q&A session. Please feel free to ask any question.
My name is Reju Mohan from CSL. My question is, has the regulatory framework been matured enough? Because we have alternate fuels, at least 4 or 5 different alternate fuels. Now we are talking about LNG, then LPG, hydrogen. But the regulatory frameworks, it seems like it is mentioning as a low flash liquid in general. But is it required that separate fuels need separate regulatory frameworks? And is it already in place?
Yeah, if you are looking at different fuels, of course there are risks also when we are talking about ammonia and then other LNG fuels. Okay, LNG there is a methane slip case what we are talking, and then because of which you are also increasing the GHG emissions. The whole idea of this alternate fuel is to reduce your emissions, right? So different fuels have different pros and then different cons. We have to consider all these aspects and then take a decision.
Yeah,
okay.
Because especially with regard to the safety aspect, I think technology may be matured for some fuel, but methanol and all for a certain segment of ships, it's still in development.
Yes. That's right. And what we did in our simulation is, it's not only, before somebody goes for a retrofit, for example, they can also do a simulation like this. We used, by the way, Napa voyage optimization, which uses the weather data. And then your ship can be, before doing any modification, you can also try it out. And then see how the fuel is behaving. Of course, the safety aspect is coming from the regulations, right, on board. And also there is a compromise what we are looking at. I mean, where you're going, where is your voyage, how many miles, nautical miles you're traveling. And then based on that, you can also decide your fuel tanks, and then other aspects come to place.
Thank you.
Yeah, thank you.
We have time for one more question.
Can I just add? Excuse me. Can I just add, since you have asked about methanol retrofit, now it is quite a number of projects are ongoing. Actually, this Monday and Tuesday, I was in Copenhagen at the Maersk McKinney Moller Center for Zero Carbon Shipping, sitting together with Tsuneshi Shipyard, Oldendorf, the Danish Maritime Authority, and MAN in developing guidelines for a Kamsar Max bulk carrier to be retrofitted to run it on methanol. So there are a lot of issues to be sorted out. And I mean, all the fears, the toxicity and other things are being mitigated. So soon the ships will be converted. So any alternative fuel can be used as long as you are comfortable with the safety aspects, and that is being done. So that is of no issue. I just wanted to add that.
Thank you, sir.
Yeah. Just, I think you answered on the regulatory part, and there was a discussion about methane slip. So that's, of course, a concern for the methanol and as well as bio-LNG. One of the possible solution could be, the redesign the engine itself. So instead of, the IC engine on this diesel cycle, maybe the possible solution could be the pressure engine. So high pressure engine could actually reduce the methanol slip to a very certain extent. Yeah.
Okay, if I may add, there is another project ongoing in Japan, though I did not mention here. It is to address the methane slip. So this is a 2-year project which started last year. By next year it will be concluded. The aim is to reduce the methane slip by 60%. So that will be a very big saving. So then we will be aiming at the next phase for maybe 80% or 90%. So that is also being addressed. But the results won't come out immediately. You have to wait for some time for the results.
Thank you, sir.
We will conclude the Q&A session now. Please feel free to continue discussion with Mr. Manoj Kumar Sanchana during the breaks. Thank you, sir. Your discussion on alternative pathways has given us a new compass heading our sustainability efforts. I would now like to invite Commodore Vinay Deireth, General Manager Design, Garden Reach Shipbuilders and Engineering Limited, to kindly come forward and present mementos to our 3 distinguished presenters as a token of our appreciation. Dr. Abdul Rahim, Chairman of NAPA Group and Advisor to Class NK. Mr. J. Ramkumar, Senior Surveyor, IR Class. Mr. Manoj Kumar Sanchana, Associate Vice President, NAPA. To commemorate this special occasion, I would like to invite all for a group photo. Heartfelt gratitude to our presenters. I request you to be seated back to the hall. All good things must come to an end, but every end paves way for a new start. These 2 days came in like an ocean flooding us with so much knowledge and ideas, and before we could realize it, it went back to the horizons. As we bring DIMS 2024 to a close, I hope you have had a rewarding experience with the knowledge sessions, discussions, and networking opportunities over these 2 days. This year's theme, Navigating the Future of the Indian Maritime Industry, has guided us through insightful panel discussions, groundbreaking technical presentations, and valuable interactions. We extend our deepest gratitude to everyone who contributed to the success of this seminar. I would take my time to express my deepest gratitude to all the sponsors of this event. Beginning with our platinum sponsors, DRDO and Cochin Shipyard Limited, our gold sponsors, ABB, and the silver sponsors, Indian Register of Shipping and Cadmatic. I also thank the Aries Energy Registration Area sponsor, Class NK Delegate Kit sponsor, Great Waters Delegate Badge sponsor. We also thank our associate sponsors, GRC, Goa Shipyard Limited, L&T Engineering, Centec Incorporated, Wärtsilä, Napa, Naval Group, Albody Daman, Shiptech Icon, and Masagan Dock and Shipbuilders Limited. Also, we are grateful to the supporting sponsors, Vedam, Cimerix Conceptia, SSI Ship Constructor, S&O Maritime, GMCG, Capital Ship Solutions, IBI Indobel, Shaw Shipyard, Trio Vision, Acantia, Admiral, AEI AB Tech, Eagle Marine, Sea Delta, and SEDS. Our media partner for the event is Maritime Standard, and BIS Event Management is our event partner. Once again, we thank you all for your support. We look forward to DIMS 2026 and the continued evolution of this platform to foster collaboration and innovation in the maritime industry. Thank you all for your participation and support. Safe travels, and we hope to see you at our future events. As we conclude the Dostas International Maritime Seminar 2024, let us all rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you. Have a great day.